show. Watch me as I go.
Should I look both ways before you cross me, baby? 'Cause I don't break for boys.
I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down, down, down the road. Just enjoy the show, watch me as I go.
Should look both ways before you cross me, baby, 'cause I don't break for boys.
I'm moving on.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt Fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. Yesterday was truly action-packed. Let's start with a quick recap. France. This year's Formnext partner country featured a speed presentation format covering different topics like research, materials, software and AM startups. Christoph Eschenbrenner, president of France Additive, was guest in afterwork talk with Frank Jablonski. Here, he called for a joint European approach to strengthen additive manufacturing in the continent. As a conclusion, Frank Jablonski suggested to invite President of the European Commission, Ursula von der Leyen, to next year's Formnext. Let's waft over to a completely non-political highlight. A beautiful display of athleticism, grace and elastomers took place at the Chromatic stand. The artist's clothing featured the company's logo made by 3D printed elastomers. Women in 3D printing clinked glasses at the happy hour at Restaurant Finery. The female leaders exchanged ideas and dialogues on all things additive manufacturing. Every passing day of the exhibition sees countless inspiring technologies leap into the forefront. Our camera team has handpicked some trends and product reviews for you. Alatec Dresden engage in laser material processing, hardening and deposition, welding with power and wire. At their stand, they demonstrate the EHLA hybrid, a laser hardening and cladding system, which is the first hybrid 10-axis laser system worldwide. Developed to serve both as a stationary and mobile system for laser treatment. DMJ Mori present their hybrid machine by combining additive and milling machining process for 3D parts. The laser tech generates flexibility in the finishing process. The laser head is handled by a fully automatic shuttle that requires no manual intervention. Furthermore, it features a 5-axis material deposition by coaxial nozzle for homogeneous powder distribution, independent from direction of laser deposition welding. At the Siemens stand, the visitors saw how additive manufacturing can be used to optimize complex production processes. Two representatives explain how it all works.
You see here is an electronic assembly for iWatch case. And basically what we are showcasing is how to use additive to improve the efficiency of such a factory in every industry in the world.
And with this digital twin, we start into NX and start redesigning the part. First of all, we are lightweighting the part up to 60% lighter than it was before. Secondly, we optimize the design. If you just hold it together, maybe we have a topology optimized design, which is also enabling the part to less energy.
Navigating through the fairgrounds isn't always easy. Often getting lost in the sprawling maze? It doesn't have to be like that. The Formnext TV camera team has assembled some insider tips for your ease. For busy bees, the Formnext arena has several co-working spaces spread throughout the fairgrounds. Comfortable seating lounges with all the amenities for that urgent last-minute Zoom meeting. The fair even has several options for your refreshment, reports our camera crew.
Formnext has the fix for your little craving. Grab yourself a donut today and enjoy what our 3D printing has to offer. We have cafes spread all around the fairgrounds.
Important client meetings, product informations and curious visitors. The Formnext hall keep getting fuller by the day. Have a look. Industry insiders and newbies. The Formnext community represents a truly diverse demographic. Here's what the visitors had to say about their personal technical highlights and where they think the future of additive manufacturing is headed.
So the jetting technologies, working with metals and ceramic powders, this is something that I also looking for our application for machine parts.
With technical exchange, we spoke to multiple end users, figuring out how additive manufacturing can help them in the application development, understanding the selection of parts, the selection of technology that is suitable for application. The methodologies that we see today are, way more than what it used to be back in the days.
Software developments in metal 3D printing, optimizing build speeds, that sort of thing.
This is the on the software side, slicers, simulation softwares. That's something that I would like to still check.
Peak 3D printing and the actual build volumes.
The metal techniques, the metal technology. We are a service bureau and we're producing, spare parts, mainly metallic. So we're looking at the powder bed fusion techniques.
What's interesting for us is something called cold fusion. So the polymer-bound metal powder parts that can be run on polymer systems. It's interesting.
3D free-form object printing. I believe that these technologies enabled by the software will scale down in price and cost and will be available for more industries than today.
Everything. It's prototyping, it's production. There's no industry, there's no need for 3D printing. Everyone can use a 3D printer.
Now, on to tomorrow's headlining events. Make sure you do not miss these. The Formnext Career Day hits the AM4U area today from 10 AM onwards. It's set to offer both beginners, seasoned specialists and managers just the right insight. Round up the evening with a beer and some socializing. The Formnext party starts at 6 PM in Hall 9. It presents the perfect networking opportunity for AM community members. Hope to see you there. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
I don't wanna
thank you for joining us, Head of Sales and Innovation at Curb. You have joined forces with Formnext this year and organized the Permundus Challenge. Tell us about the Permundus Challenge.
Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Oh, definitely.
Yeah.
Definitely they have. And that's what this retrospective view of the different winners of the last 10 years really show, that there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well at the applications as how to combine material and process, as how to make a really good design, and because at the end it's a design contest.
What are the developments in the business models of these companies? Like you said, small SMEs, big companies, they've all won Permundus Challenge at some point.
Yeah, there are students with ideas. Some of these ideas will go into startups, and we are happy as CIRP, as a service provider, that we could help some of them really producing their products.
And what are the expectations? I mean, the past 10 winners, what do they bring to the community of additive manufacturing?
Oh, well, that's a difficult question, and we had several winners every year, but I think it always has been a view into the future, and the future has come true for many things. So especially for people with special needs, you see quite a number of good samples how you can how you can assist people with special needs. And I believe that has become true over the last 10 years, and very good samples have been winners of the Permundus Challenge.
Very nice. Mr. Luke, thank you for your encouraging words really regarding the industry and how it's grown. And I thank you for your time, and thank you for showing us around. And we are excited to be here when the champagne bottles pop.
Thank you.
Yeah, thank you for your time.
Welcome to the third day of Formnext 2022, and welcome in our live stream, and welcome here at AM4U stage in Hall 11. Yesterday, the second day of Formnext, was very full-packed with information, with lectures, and with a lot of conversations here at the stage and down there in the halls. With a lasting impression on this year's partner country, France, we had a lot of guys here presenting their products and their solutions for the community. Very, very impressive. Today we will have another focus. We will focus on sustainability, and I'm very happy to have the right people here with me in the morning talk. So I'm very happy that you here with me, Sherry Monroe. She's Executive Director, Additive Manufacturing Green Trade Association, AMGTA, right?
Right, that's a mouthful.
Perfect. Good to have you here.
Thank you.
Dr. Martin White, he's Head of Additive Manufacturing Programs Europe at STAM, Additive Manufacturing Center of Excellence.
Good morning.
Good to have you here.
Thank you, good to be here.
And Thomas Lück is Head of Sales and Innovation of CIRP GmbH. And maybe the one or the other knows him better as the head and the organizer of Permundus Challenge, a very long-lasting challenge. We come back to that later. Good to have you here, Thomas.
Thank you.
Yeah, Sherry, your topic is sustainability. That's
right.
That's what drives you. What contribution can AM make to a more sustainable industry?
Well, I think the opportunities are throughout what businesses are doing. You know, when we talk about sustainability, we're not talking about something sort of off to the side that companies do if they have some extra time and some extra resources. From our perspective, what sustainability should look like is less energy consumption, less waste, less source material, shorter lead times, less inventory sitting on shelves, really those same strategic drivers every business is looking at anyway. And whether sustainability is the objective or if it's the fortunate unintended consequence of just running a better business, those are still sustainability wins.
Yesterday or the day before, we had here some guys from VDMA, and they had a survey, and the result was that people are, dealing at their companies with one main topic. Do you know what it was? Cost.
Right.
So, and now we're driving, when we're talking about sustainability, I think we have to talk about cost, or
absolutely.
What does sustainability cost, or do you have a better argumentation,
Right. I think if you look at it as a cost for your business, it's a little like taking your medicine. That it's not very palatable. People don't, it's hard to get motivated around that. But when you look at those same strategic drivers, how do you reduce costs? Well, you reduce costs by reducing your energy consumption, by reducing the materials you're purchasing. Those are cost drivers, but they're also sustainability drivers. And where you find that those overlap, that's where you're going to get people on board.
So you're stating it's not contrary, but it can go hand in hand?
Absolutely. Absolutely.
And do you have in your association? Do you have examples, or can you underline it with surveys or with facts and figures? Because it's always it sounds good, but can you prove it, or do you have examples from your member companies?
Absolutely. Well, we have research that we're doing, life cycle analysis that will be coming out. Actually, 4 of them that will be coming out in the next year. 2 towards the end of this year and 2 in the middle of next year. But you don't have to. If you can tell somebody you can reduce your energy consumption, you can reduce the materials you have to throw in the waste bin. Those are easy to quantify for any business. So I think if they're looking at that through those lenses, that's the first place to go. There may be some other things that they may do at some point that have costs associated with them, but there's so much they can do first.
Mm-hmm. Tom, Martin, what is your impression on the discussion about cost and sustainability?
So I agree with the comment. I think they're hand in hand. So I think sustainability is something that we have to address globally, industry-wise. I'm seeing a big change, actually, just walking around the floor in Formnext, as the discussions we're having with suppliers, bureaus, end users, is that in terms of how much does a part cost, there's now part of the quote process is this is how much energy you'll use with your parts. So there's a drive now to increase the number of parts in your build, for example, to try and reduce energy costs, because back to that main reason is how do we build a sustainable business and reduce costs? So I have seen that already. I think it is a change, and I think the industry is very excited to take this on. And it's the same with our factories. So in the UK, a lot of the additive manufacturing facilities are often in old tool shops, which have become obsolete. There's big space on site, so they put their additive manufacturing in. And they're realizing that obviously the consumption of energy, getting the supply chain and all the kind of accessories you need for additive, you need to have something fit for purpose. So I think there's a big push to actually really set ourselves up for sustainability from the start for manufacturing.
And are you thinking about certain materials when you say that? Or is it from every material we are talking about in additive manufacturing, or are we just talking about metals or plastics?
I think it's inclusive of all materials and all manufacturing methods. So my background is primarily aerospace. So the drive in aerospace is reducing the buy to fly ratio. So the amount of material you buy is hopefully reduced with additive because you're not machining material and throwing it away and not using it. So I think the metallic has a huge potential because obviously then you're not producing as much raw material, so you can get some of the energy costs down there. And I think people are realizing that actually sustainability is quite attractive to the market. So if you can sell that you have an attractive proposition for sustainability, people will decide to buy that. So I think it is a powerful tool.
We are coming later back deeper to Pomundo's challenge, but maybe just one impression. You're covering Pomundo since several years, or many years actually, and maybe there was the topic of sustainability. I think it was an important topic for you as well, right?
Well, it's the 10th anniversary this year, and what we showed this year is a retrospective of very nice winner projects of the last 10 years. And when you go through these innovations, always we are kind of looking to the future, but after 10 years,
you can look back.
But what you see is definitely that students, designers, startups, SMEs, as well as global players, more and more take responsibility seriously. And responsibility is sustainability, certainly, but also responsibility for people with special needs and other things in society. And we see more and more that it's not just a little gimmick, the look, Additive can do that.
We have the donation project for Ukraine we presented here. That's a good example, I think.
You name it, and you really see that people not just want to show off with what Additive can do and with the freedom, that people more and more really use it to take on responsibility. And it still can look good, it still can be something which you like to look at and be a product with some value. But responsibility definitely is taking on more and more importance in what these people do and send to us as their contribution to a contest.
I understood that you had this year had a special event, let's say, but the recent years it was a contest. So did you have a criteria sustainability when choosing the winner?
Well, we are a little company doing 3D printing, but we invented 10 years ago this contest because we wanted to push more things which were really additively manufactured and not just rapid prototyping. And but the jury was always people outside from our company, from all over the world, from Australia, from Britain, from Germany, designers, professors and others, and they had their criteria, but obviously within a design contest, they had a number of checkpoints for them, and sustainability definitely, and responsibility were things they looked at. And so, for example, a little food for children who need a prosthesis won 4 years ago, I believe it was, because this kind of responsibility for people and was an important criteria.
Is the trend in additive manufacturing, or additive manufacturing serves the trend of individuality? Right. So the single product, from your shoes to your medicine products and so on. Is that a driver for sustainability in your eyes?
I absolutely think so, and I think that's also a great sustainability story. If you talk to anyone in their own life, how many things have you purchased that were generic, let's say your shoes, and then you get them home and they don't quite fit your foot and they end up getting tossed out, and you go buy another one.
Sales season where you can buy cheap shoes, because they had to manufacture different sizes and they were not bought, or here suits
so
or
you
something
end up
like
having
that.
a lot of things that are thrown away. I think if you really look at a full life cycle, a true life cycle of a product, I think you find a big sustainability story there. When you're looking at for a life cycle analysis, and if you're just reproducing these two glasses, and you just look at the production or even just the use phase of it, you don't capture everything. If you don't capture the inventory that goes on the shelf that eventually gets thrown in the waste bin, or a shipment that comes in from traditional manufacturing, you pull out the first one and discover they're all wrong and have to be tossed out and reproduced. If you're not accounting for all of that, because I can tell you in your business, the finance people and the inventory people are looking at all of that, and if you really include all of those things, you're going to find a sustainability story. Now, is AM perfect for every application to produce everything? Of course not. But where it makes sense, it's going to make sense.
But
so it's a matter of identifying those.
But you agree that there is a long way to go until we get there, that we are all satisfied with the topic sustainability. I think we.
Sure.
Well, I don't know how much percent. I don't ask you, but it's not so much, I think.
Right.
So is something like Pomundo's challenge a method to come into public, to get these points you're making here on stage into the minds of the people? Do we have to do more of getting awareness, doing more marketing for the sustainability aspect, and how do we do it?
Right. Well, and I think challenges like that and events that really encourage, really opening people's minds to what development could look like, what design can look like, what the potential is, because there's just so much opportunity here, but it really requires people to get out of their thinking. It's going to take people that haven't been steeped in doing it another way for years, but you can't wait for, the young kids coming out of college and plant these seeds that are going to take 20 years until they're in leadership. It takes those folks being trained, but it takes leadership that's going to encourage risk, right? And to try these new things and have that be rewarded. Even when we do LCAs or any company is doing an LCA, it's not about at the end, is it a thumbs up or thumbs down? It's where was it better, where was it worse along the way, what's transferable, what can we learn about it, and that kind of transparent information coming out. That's what I hear companies are looking for that are looking to adopt AM, which is what we all want, is more broader adoption. They need information. They need to know where to apply this in their businesses, and that's kind of incumbent upon all of us. We can't just talk amongst ourselves at an AM event. We have to be out talking to a broader audience and helping them understand how they can bring this into their business. Where does it make sense? Where does it maybe not make sense? And then we will see more adoption, which is really good for everybody in this room.
And I believe it also shows different levels, because you mentioned individualized products, which we had many. People will worship them more, so will not throw them away year after. You mentioned the resources being used less and just produce what you need, not more than that, and the logistics are always an argument. But we also see the level of renewable materials in the production of products. We had some very nice innovations over the year, taking really green material for additive manufacturing. So it's also about how can be additive manufacturing in itself be more sustainable. But additive manufacturing can also be an enabler for sustainability in other areas. And so we had also winners from the energy area, so that additive manufacturing helps you to be more energy efficient in other areas, because that freedom helps, and maybe that's even the largest impact you might have. And so I see it's also a nice way of presenting these different levels.
But how to get them transparent? That's a big task, I think. How to get these effects you get in a plane. You mentioned the plane.
So a great mechanism. I think we're kind of talking about how do we have an impact for sustainability. So taking the ideas from maybe a competition which inspires. So ASTM in partnership with ISO and standardization through global standards is a very good way of driving impact. So where we have our best practices, we can drive that through standards.
Put in aspects like sustainability into standards you are not producing, you're discussing? Or
absolutely. So the beauty of a standard is it's consensus based. So I think from seeing what we've seen here this week, it is a hot topic. So we need further standards development. So what are the key things we need to focus on to reduce cost, energy use, have those parameters in our standards, and then that becomes adopted by industry. So that is a very good way to take the innovation.
But is it possible to define in a standard what a product has an impact in an airplane or in a car or in not shipping shoes you do not wear? How to define that in a standard?
So I think as the industry is kind of looking where we can reduce cost, those become your key focus points. So again, we have a standard coming out at the moment working on defining part families. So instead of producing one part, spending all that money and energy to qualify and certify a component, and then doing it exactly the same again for a new part, how can we share the load and the burden. And that relates back to supply chain. So you can have a digital warehouse of spares and parts, and that can all be managed through standardization. So I think you may not get everything, but if you pick the top 5 big hitters, then that's what you can focus on in standardization. Then industry can say, well, if we know to focus on these 5 things, we can then really target what we're doing and share the learning back into the community as well.
But it's not always so easy to get a sustainable product and to get it transparently. I brought it with us here, or we got a stool fabricated, and over there a table. And maybe just one sentence to these. I brought it with me. This tool is an example. It's brought to us by Forust von Anisha Melia. It's a part of Desktop Metal Forust. And this tool was designed by Ron Rail. So, and now I want to tell you, so they tried to make this one real sustainable, but it's not an easy task, I think. So each component was printed using a water-based ink, okay, dried, but it took a really long time to fabricate this one. Dried for 24 hours, depowdered to remove the unbound powder, infiltrated with the epoxy, cured for 24 hours, sanded, then components had to be glued together. Again, a semi-transparent colored stain, pigment and water-based. The epoxy was 20% bio-derived content when mixed. So and so on and so on. I can read a lot more. Sure. So first, for my first learning, it's you try hard, but you have technical limitations. You cannot use 100% bio-derived. He is working just 20%. So it's not an easy topic. Talking to to your association members, are they all willing to give so much effort in producing a sustainable product?
So it's a good example. So you can you have this tangible product in front of you, and I'd say it's back to application. So is additive the right application to make something to sit on? Mm-hmm. So perhaps we have more alternative methods that may be more sustainable and cheaper. And of course we can use this to drive design and innovation, but I think that's probably where I would start and see from our membership is we don't have to use additive manufacturing. Eventually will become a tool in the toolbox of manufacturing, and you select the tool that makes the most sense. And that's cost is a big driver, but sustainability feeds into that. So I think that's my my thought there is what is the application, and does the manufacturing method make sense across the whole spectrum?
The recent days we had the topic artificial intelligence here, and connectivity, and how can digitalization help us to monitor our processes, to make the processes better, so we do not have so much bad parts in our processes. Is it a topic one of you guys are working on including very new technology like using artificial intelligence into the processes to optimize them, sustainability in mind? Is that something on topic right now?
Absolutely. So from ASTM perspective, we canvass the industry for ideas for standardization. And in the last 2 years, the most suggestions for standardization was based around data. And that shows us that we are getting mature now, that we need this data to make everything more efficient. So we have things like a common data dictionary, which is a standard. So when we talk about these different packets of data to transfer between our systems, we talk the same language. So those standards are now existing. There's a strategic roadmap for how we use data in the industry. And again, it's not our thoughts. It's we bring the community together. What does industry think? What does academia want? What does everybody want? And we see that is a big thing.
Yeah, and I think you made the right point. That's about research and collaboration.
Right.
If everybody does it for its own, it will not work that way. And artificial intelligence, new renewable materials and things which we are as a small SME also pushing in research collaboration, because on our own we wouldn't be able to do so. And especially what you said about quality and waste, if you manage your process much better, you throw away less, and that is also sustainability. And on the material side, biomaterial, there are good chances, but it has to be with cost, and you have to bring the right partners together. And therefore, I think the point you made before with the visibility is important, and we have to look also for the visibility outside our own community.
And I think in this example here, you know, why I would say, if I were talking to the folks who printed this, I would say, why did you print this? Like, what was the reason? Was the driver some organization that's going to sell that retail or is going to use that? Why did they want to print it versus making it another way? Because was there a shipping reason where you could lightweight this? Is it because we don't know if people are going to like the brown one or the square one or the round one? We don't know. Is it an inventory issue? And you need to have not just the AM sort of stakeholding organizations in this. You need to have the companies that consider themselves end users or even consumer goods to drive this conversation, because we've all seen companies develop amazing technologies that no one was interested in, you know, that could do some amazing thing that just really didn't have a use. But if that information is coming from, you know, the end user, the boots on the ground, what do they need? Why do they need it? Because that's what drives development. That's what's going to drive, you know, printers, you know, with a bigger build envelope. Well, that's because, not just because they can build a bigger envelope, it's because there's a need for it. So that's really going to inform the entire conversation of, you know, why did they want to print that to begin with? What was their business reason? If it was lightweighting or if it was because we don't know what consumer tastes are going to be, then you work around those things, and maybe you say it doesn't make sense to print it.
So I think what I'm going to do is I will invite Anisha Melia of Forest to come here in our after-work talk, and maybe she can give us some answers, because we have a lot of questions.
Yeah.
And by the way, I want to give some credits to the other, not that we are talking about and not mentioning here the designers. That was Mike Doberak, 3D printing from the 3D printing startup Big Rep, with a large FDM printer, if somebody is interested in how it was done. And maybe Mike is here on Formnext, and he will come to the morning talk tomorrow or the evening talk today. Yeah. But you know, these examples, I think are very good examples to show. Absolutely. As you said, you have to look deeper into the topics. Time is nearly over. So we are starting into the next fair day, and I'm very happy to have had you here. I wish you a lot of success and a lot of good discussions today, all around sustainability, and tomorrow maybe a next topic. Thank you very much.
Thank you.
Yeah. Dear audience outside, we have, after some short Formnext highlights, we will have here on stage an expert insight with Rolf Anderhofstadt, and he will solve problems before they happen with 3D printing. We're very curious what he's talking about. Vielen Dank.
Great.
Thank you very much.
Thank you so much.
We're here at Evotech, and there's an interesting drone, and a big one at that, at display. Tell us about the product, please.
Yeah, we got here a very interesting drone, because most of the parts are 3D printed and are designed just for the 3D printing process. So you can see here, we got here a very lightweight design, and it's printed with carbon fiber film filament, so it's very strong, and yeah, it weighs about nothing, so it can carry a huge load.
Can we see it fly here at the Formnext Arena?
Oh no, sorry, we left the Ecos at home, so we're not tempted to fly because there's a lot of stuff.
No batteries, but I can see this thing is huge and looks possibly great in the sky. Well, thank you for talking to us, Lucas, and have a great time in Formnext.
Yeah, thank you.
Yeah, thank you.
Hello, I'm Sandra from the Formnext team, and we are in front of the UL Solutions booth. Their main focus is on safety, and we want to know more about it.
At UL Solutions, our objective is to increase additive manufacturing into new and innovative uses by increasing the level of safety and assuring that level of safety in not only the equipment used for 3D printing, but also the materials in 3D printing construction applications, as well as medical, even biocompatibility.
What is the blue card?
So UL Solutions has, for the additive manufacturing, when we research and evaluate plastic materials for use in additive manufacturing, we certify materials in something called a blue card. This blue card contains information on the processing parameters in the equipment used to make sure that that material performance, those certification parameters that we've evaluated for that material, are consistent throughout the life of that material.
Can you specify what kind of information will be shown on the blue card?
The certification program that UL Solutions has for additive manufacturing materials is the blue card. The blue card contains testing information for standardized tests such as flammability, dielectric strength, electrical and mechanical performance of that material when it's produced with standardized specimens using specific printers and specific settings for that printer. This enables users of that plastic material to rely upon that material for use in electrical and electronic products that gives them a speed to market because they can reduce the amount of testing required to get to market faster.
And can it be used for any kind of 3D printing technologies?
The UL Solutions additive manufacturing 3D printing certification program can be used for any type of additive manufacturing process. It was put together with flexibility in mind. We currently have materials certified for material extrusion, fat polymerization, powder bed fusion. But the program is flexible, and any new technology in additive manufacturing that is developed can be incorporated for that certification program. To learn more about the UL Solutions services that we offer the additive manufacturing community, please feel free to visit our website at ul.com/am or ul.com/bluecard. All the information on the certification services that UL Solutions offers can be found there.
Hello, ladies and gentlemen, and a warm welcome also from my side to the third day of the Formnext 2022 here at the stage and, of course, at the screens in our live stream. Welcome. Good to have you here back again. This day, the third day, is traditionally the career day at Formnext. So beside very interesting experts, insights, and specific panels of today, we will tackle as well the topic of education and career opportunities in additive manufacturing. Just a quick remark for our international listeners and guests here in the audience. The first session will be held in German. So keep that in mind. The first session will be in German and we will switch back to English at 10:40. So, dann mache ich mal auf Deutsch weiter. Herzlich willkommen nochmal auf Deutsch. Wir beginnen den Tag mit einem sehr interessanten Einblick in ein Unternehmen, wo additive Fertigung heute schon einen sehr hohen Stellenwert erreicht hat. Thema des ersten Vortrages ist, wie Sie mit 3D-Druck Probleme lösen, bevor sie entstehen. Additive Manufacturing Solutions. Und ich begrüße dafür auf der Bühne Ralf Anderhostadt, Head of Center of Competence Additive Manufacturing Printing Shop and Media bei Daimler Truck and Buses. Ralf, schön, dass du da bist. Kommst du mir auf die Bühne? Ich freue mich, dass du da bist. Stage is yours, bitte.
Ja, auch von mir aus mal ein herzlich willkommen und einen guten Morgen. Und ich möchte natürlich die Chance jetzt nutzen und Ihnen einen Einblick zu geben, was denn bei uns innerhalb Daimler Truck zu dem Thema Additive Manufacturing läuft. Und zwar auch ganz stark in Bezug auf den industriellen 3D-Druck. Bevor ich loslege, ganz kurz, wie sind wir organisiert bei uns innerhalb Daimler Truck zu dem Thema 3D-Druck, industrieller 3D-Druck. Und hier sind wir in einer sehr agilen Projektstruktur. Wir arbeiten hier mit Scrum Mastern, die die priorisierten Themen bei uns im Konzern treiben. Und darunter ist ein sehr crossfunktionales Projektteam mit mittlerweile mehr als 30 unterschiedlichen Bereichen, mit denen wir wirklich aus allen Facetten das Thema 3D-Druck beleuchten. Da ist dabei natürlich eine Entwicklung, ein IT-Bereich, ein Legal-Bereich und auch, ich glaube, das passt ganz gut zum späteren Panel, natürlich der Bereich HR, Weiterbildung und Ausbildung. Wie gehen wir hier konkret vor in dieser agilen Struktur und Organisation? Und da leben wir die Philosophie Think Big, Start Small, Move Fast. Also sprich, Think Big, was ist unser großes Big Picture? Wo geht die ganze Reise mit dem Thema 3D-Druck hin? Und da haben wir für uns ganz klar definiert, es ist ein digitales, neues Geschäftsmodell, wo die ganze Reise hin mündet. Nichtsdestotrotz ist es immens wichtig, dass wir natürlich die sogenannten Low-Hanging Fruits auch ernten. Also sprich, wo können wir denn mit dem 3D-Druck heute schon kurzfristig unterstützen, beziehungsweise, und ich glaube, da passt die Zeit auch im Moment, so angespannt sie ist, ganz gut dazu, Lieferkettenproblematiken, Klimawandel, aber auch das ganze Thema Inflation kann der 3D-Druck heute schon extrem viel abfedern. Fällt unter dem Thema, unter dem Block Start Small und dazu kommt natürlich auch noch der Aspekt, dass wir uns natürlich an dieses dynamische Umfeld, in dem wir uns bewegen, auch immer wieder an neue Herausforderungen anpassen dürfen. Und das ist genau dieses Schnellboot, wo Sie hier in der Mitte sehen. Ich beginne mit einem ganz kurzen Blick drauf auf unser Start Small, also sprich, was ist denn tatsächlich schon bei uns umgesetzt? Und ich gehe gar nicht auf jede Bubble ein. Ich glaube, das würde den Rahmen jetzt hier an der Stelle auch sprengen. Ich nehme mal die zweite, die für uns ganz bedeutend ist, nämlich das Thema, wie viel von unseren aktuellen Teilen, Truck- und Busseitig, sind heute schon 3D-druckfähig. Und da stehen wir zum heutigen Tag bei über 15% aller Teile. Warum erwähne ich das so explizit? Vor 3,5 Jahren lagen wir so ungefähr bei 7%. Also man sieht, wo die ganze Reise hingeht und wir entwickeln aktuell Werkstoffe. Wir schauen, dass wir weitere Werkstoffe qualifizieren, zertifizieren und diese Zahl wird weiter steigen. Also sprich, das Potenzial des 3D-Drucks für uns wird immer größer. Ich glaube, auch ganz spannend ist die Zahl, dass wir Stand heute schon deutlich über 500 unterschiedliche Teile, Serienteile, komplett freigegeben haben. Sprich, diese Teile gibt es nur noch als 3D-Druckteil und die sind in einer Anzahl von mittlerweile knapp 45.000 Stück schon in unseren Fahrzeugen verbaut. Also ich hoffe auch im Moment auf der Straße unterwegs. Sprich, wir setzen dieses Thema schon ganz konsequent bei unseren Fahrzeugen ein. Und auf dieser ganzen Reise haben wir auch gespürt, dass der 3D-Druck, der industrielle 3D-Druck deutlich mehr Potenzial noch in sich hält. Und zwar, wenn wir von unseren Teilen oder von unseren Produkten den sogenannten Digital Twin oder den digitalen Zwilling erzeugen. Also sprich einmal die 3D-Druckdaten in Kombination mit mit dem Kochrezept, also dem Digital Part Report, verheiratet als digitaler Zwilling. Und wenn man genau dieses Thema oder diese Essenz in einem digitalen Lager speichert, gibt es natürlich mannigfaltige Vorteile. Sie sehen hier einen ganz kurzen Einblick in unser Digital Warehouse, welches wir bei uns eigentlich täglich noch aufbauen und weiter ausbauen. Wir haben Stand heute von über 2000 Teilen bereits die Daten in unserem digitalen Lager, und in diesem digitalen Lager sind dann natürlich auch Themen drin, wie es wird geprüft, die technische, die wirtschaftliche Machbarkeit, sprich es gibt auch in der wirtschaftlichen Machbarkeit immer wieder den Abgleich zu den Echtsystemen, zu den ERP-Systemen. Wir sind natürlich hier verknüpft, das sehen Sie jetzt hier, mit unserem CAX-System, wo dann die Daten entsprechend automatisch rausgezogen worden in dieses Dashboard, plus weiteren Informationen zu den Teilen. Können Sie jetzt hier nicht lesen, aber so Themen wie, gibt es für dieses Teil schon eine 3D-Druck-Lizenz? Und da springe ich jetzt auch auf die nächste Folie, weil es genauso unser digitales Geschäftsmodell, einmal das digitale Lager als Basis und auf diesem aufbauend dann in Richtung Digital Rights Management. Und dazu haben wir Mitte des Jahres, im Mai diesen Jahres, eine Presseinformation rausgegeben, wo wir genau dieses Thema, wir bieten unserem Kunden parallel zu dem physischen Teil auch die Möglichkeit, eine 3D-Druck-Lizenz zu beziehen und dann genau am, ich sag mal, Point of Use, das kann der Point of Production oder auch der Point of Sale sein, dieses Teil dann auf zertifizierten Anlagen, mit zertifizierten Werkstoffen zu produzieren. Dieses Thema haben wir mit Partnern umgesetzt, der Firma Vibo und Firma Farsun, wo wir hier diesen Start gemacht haben, und man spürt hier auch ganz großes Interesse aus dem Markt raus für dieses Thema. Und auf dieser Reise haben wir aber auch in den letzten Monaten, Jahren, so seit der Pandemie, ganz viele Anfragen bekommen von Unternehmen aus ganz anderen Branchen, die gar nichts mit unserem Segment zu tun haben, also mit dem Bus oder mit dem Truck, zum Beispiel aus der Landwirtschaftsbranche, aus der Wohnmobilbranche, wo auf uns zukamen und angefragt haben, wie seid denn ihr gestartet, wie habt ihr in diesem Feld losgelegt? Sprich, ihr lebt ja diesen Blueprint bei euch innerhalb Daimler Truck, ihr macht genau dieses Thema, wie kommen wir in diesen industriellen 3D-Druck? Und daraus hat sich dann unsere Consulting-Einheit Additive Manufacturing Solutions gebildet, wo wir heute schon einige Unternehmen an der Hand in diese neue Welt einführen, wo wir hier partnerschaftlich genau dieses Feld begehen. Teilweise vom Beginn an schon, sprich, wie findet man dann richtige Komponenten, aber ganz spannend sind gerade auch diese Punkte digitales Lager und Digital Right Management, wo natürlich ganz viel Interesse auch da ist. Und auf dieser Reise, sowohl intern als auch dieser neue Block in Richtung extern, stehen natürlich einige Herausforderungen an. Und eine Herausforderung ist natürlich das ganze Thema fehlende Fachkräfte, sprich auch das Thema Weiterbildung. Wie kriegen wir denn dieses neue Wissen, ich sage ganz bewusst auch disruptive Wissen, weil da verändern sich einige Dinge in der Wertschöpfungskette, wenn wir dieses Modell weiterspielen. Wie kriegen wir das denn an unsere zukünftigen Fachkräfte vermittelt? Und wir, also jetzt bei Daimler Truck und Daimler Buses, sind hier im engen Austausch auch schon mit Industrie- und Handelskammern, wo wir schauen, was gibt es denn hier für Weiterbildungsszenarien. Aber ganz viel läuft Stand heute noch intern, wo wir durch interne Weiterbildungsprogramme dieses Wissen weiterbringen und vermitteln, weil es einfach die Essenz ist für die Zukunft. Und ich glaube, das ist auch schon meine Abschlussfolie. Das ist eine ganz gute Überleitung in das anstehende Panel zu dem ganzen Thema Weiterbildung, fehlendes Fachpersonal, gerade in diesem hochspannenden und wachsenden Segment Additive Manufacturing Solutions.
Mega, Ralf, ganz lieben Dank für die Insights. Bevor ich hier meine Fragen losschieße, ich habe natürlich ein paar, hier an die Audience und auch zu Hause nochmal ganz wichtig, wenn Sie gerade zuschauen, nutzen Sie die Kommentarfunktion unseres YouTube-Livestreams. Dort können Sie Ihre Fragen platzieren und es gibt dann jemanden, der die für mich oder für uns dann aufbereitet und hier auf unseren Monitor bringt. Gibt es denn Fragen aus dem Publikum an den Ralf? Sonst fange ich mal locker an und dann kann sich jeder noch überlegen, ob er seine Frage stellen möchte. Ralf, wir reden ja immer darüber, wie weit sind wir denn? Jetzt seid ihr ja schon relativ weit. Du hast natürlich auch gute Möglichkeiten. Die erste Frage, die ich immer habe bei so einem großen Unternehmen wie Daimler, wie empfindest du die interne Akzeptanz deines Themas?
Also das ist natürlich, wir sind 2015 losgelaufen, Sven, und das ist natürlich schon so ein Punkt, wo man ganz viel Vorarbeit leisten muss und sagen, Mensch, da kommt was Neues, diese Ängste und Sorgen auch zu nehmen, dass natürlich die eingefahrenen Modelle, gerade aus der Konstruktion, es verändert sich ja nicht alles schlagartig, es kommen neue Möglichkeiten hinzu, aber genauso diese Barrieren abzubauen, wo ja oft wirklich aus Ängsten und Sorgen aufgebaut sind. Aber mittlerweile, es ist ein langer Weg natürlich, laufen ganz viele, durch das, dass wir ja hier auch so crossfunktional unterwegs sind, ganz viele sehen die großen Vorteile dahinter, die sich aus ökonomischer und ökologischer Sicht ergeben. Aber ist natürlich kein Weg, der jetzt von heute auf übermorgen gemacht ist.
Jetzt war ich selber lange im After-Sales Automotive tätig, kenne also ein paar After-Sales-Kollegen. Da kann ich mir vorstellen, wird nicht jeder gejubelt haben, wenn da jetzt der Ralf um die Ecke kommt und sagt, Leute, wir können den After-Sales revolutionieren. Ja? In Zukunft können wir theoretisch Ersatzteile da drucken, wo sie benötigt werden. Das hebelt natürlich so ein bisschen die klassischen Businessmodelle aus, die man da hat. Wie sind da die Reaktionen im After-Sales?
Ja, also es ist natürlich schon an gewissen Stellen ein bisschen ein Unbehagen da, aber dieses Unbehagen, sage ich immer wieder an der Stelle, kommt ja nicht durch das, dass wir das jetzt machen. Das ist ja genau der Markt. Ich sage immer wieder, wenn wir dieses Thema nicht umsetzen, dann gibt es viele andere große Unternehmen, tolle Unternehmen, die genau ja auch in diese Richtung schielen. Also von dem her müssen wir uns, glaube ich, einfach dem Zeiterzahn auch ein Stück weit stellen. Und das heißt ja nicht, dass es jetzt einen kompletten Abbruch gibt, sondern das läuft ja parallel. Man läuft hier langsam los und es wird dann ein angenehmer, sage ich mal, Switch und von dem her ist die Akzeptanz eigentlich sehr hoch, muss ich sagen mittlerweile. Ja.
Im klassischen Pkw-Bereich habe ich persönlich einen ganz guten Überblick, wer da 3D-technisch unterwegs, 3D-drucktechnisch unterwegs ist. Wie empfindest du so den Wettbewerb bei euch im Bereich Truck and Buses? Wie aktiv sind die anderen Player am Markt, was das Thema angeht?
Ja, also das war
Gibt's da einen Austausch, wäre auch mal eine Frage dann.
Ja, Austausch haben wir in der Art und Weise relativ wenig, also eigentlich gar nicht großartig, aber man kriegt natürlich viel mit, weil die Family ist ja sehr eng miteinander vernetzt und von dem her spürt man natürlich schon, dass viele genau in diese Richtung schielen. Und ich glaube, das Spannende ist, wenn dahinter schauen, dass diese Verzahnung ja auch über die Branchen hinweg, also es muss nicht unbedingt, jetzt sage ich mal, ein Mitbewerber aus unserem Segment sein, weil durch das Thema 3D-Druck hast du natürlich die Möglichkeit, auch viele andere Teile aus ganz anderen Branchen miteinander zu kombinieren in einem 3D-Druck. Aber ich glaube, es schläft niemand in diesem
Ich hoffe
Bereich.
nicht. Ich hoffe persönlich nicht. So, wenn ich jetzt mal, ich spinne mal einen Fall, wenn ich darf. Ja, ich bin jetzt großer Spediteur, habe eines eurer Fahrzeuge und ein Fahrzeug bleibt irgendwo in der Nähe von, I don't know, Hannover liegen. Wie weit entfernt sind wir davon, dass mir da jemand ein Ersatzteil schnell druckt, wenn es nicht verfügbar ist? Ist das ein Szenario, was man sich in der Zukunft vorstellen kann?
Also das hast du, wir haben uns nicht abgestimmt, aber das ist ein tolles Beispiel, weil Hannover ist relativ nah an Hamburg und in Hamburg wird die erste Außenorganisation von uns, wo genau unser mobiler 3D-Druck-Container hingeht. Von dem her ist es natürlich jetzt so ein Rollout, wo wir jetzt schauen, wo sind denn die großen Bedarfe im ersten Step da. Da schaut man in Richtung Spanien, jetzt habe ich gerade Hamburg schon gesagt, man schaut, was kann man mit Skandinavien machen. Das ist jetzt ein Stück für Stück, wo wir genau dieses Modell ausrollen. Und von dem her ist es ganz schwierig, jetzt Hannover war ein tolles Beispiel, aber hättest du ein anderes gesagt, muss man einfach schauen, wie die regionalen Bedingungen.
Wir sind am Start, ne? Also es geht jetzt, jetzt langsam los.
Genau.
Ne? Wie würdest du einschätzen, wie ist so das Interesse in der Branche, also bei euren Kunden tatsächlich? Ist es was schon, du hast vorhin ja mal euer Lizenzierungsmodell angesprochen, ist das was sehr stark angenommen wird oder großes Interesse da? Oder?
Ja, ein überraschend sehr großes Interesse, weil am Anfang haben wir gedacht, wir haben so ein bisschen mehr Zeit dazu, dass wir da auch lernen können und so reinschnuppern. Jetzt merken wir, dass aus unterschiedlichsten Richtungen hier Anfragen kommen, sowohl von Endkunden als natürlich auch von den Dealern dazwischen. Also ganz viel von unterschiedlichen Richtungen, wo wir jetzt eher schauen müssen, wie jonglieren wir denn die ganzen Bälle und mit wem gehen wir denn als erstes ins Rennen. Also das Interesse ist sehr, sehr groß. Ja.
Ich bin immer ein großer Freund von ganz konkreten Applikationen, ne? Und du hast ja ganz viele Teile, also erstmal das Portfolio, was gedruckt werden könnte, das ist ja schon mal eine wichtige Analyse. Was ist denn so die 1, 2, 3 Bauteile, die heute am häufigsten schon aus deinem Center kommen sozusagen oder kommen könnten?
Also wir sind ganz stark, jetzt, wenn ich jetzt in den Busbereich mal reinschaue, im Interieurbereich unterwegs. Also sprich, das sind Griffeinleger, Griffhalter, also jeder, wo durch den Bus durchläuft und sich festhält, das sind die optimalen Teile. Es gibt viele Abdeckungen dazu. Aber auch im Metallbereich haben wir schon für Abgasanlagen die Halter gedruckt. Also das ist ganz mannigfaltig, ganz viele unterschiedliche Themen. Aber schon stark auch, gerade so aufgrund der Kunden, Sonderwünsche, also sprich, wir passen ja die Busse genau so an, wie der Kunde es sich wünscht. Ergibt sich natürlich gerade aus dem Stückzahlenbereich raus ganz viele Themen raus. Also
Stückzahl ist aber trotzdem, da hätte ich auch noch einen. Das ist auch für mich immer so ein ganz spannendes Thema. Wir sind ja jetzt nicht im Pkw-Bereich, wo ich, keine Ahnung, so und so viel 100.000 Fahrzeuge jedes Jahr auf den Markt bringe. Ihr habt ja auch immer noch ein Riesenvolumen, aber deutlich kleiner als in dem Bereich. Wie wird das Thema Stückzahl gesehen? Ist es eher ein Plus, die geringe Stückzahl für Richtung additive Fertigung, weil man natürlich Lagerhaltung dadurch signifikant reduzieren kann oder gewisse Teile einfach nur noch digital auf Vorrat haben muss? Oder ist es eher negativ, dass die Leute sagen, nee, wir brauchen die Stückzahl, um die Preise klein zu halten? Was sind da so die Strömungen?
Also ich glaube, ein ganz wesentlicher Aspekt bei uns war tatsächlich, dass wir im Bus- und im Truck-Bereich natürlich geringere Stückzahlen im After-Sales-Bereich wie in dem Pkw-Bereich haben. Weil da haben wir natürlich deutlich schneller die Wirtschaftlichkeit auch. Und dann sind wir natürlich ein sehr customize-getriebenes Business. Von dem her sind wir auch wieder in diesem niedrigeren Stückzahlenbereich. Ich bin da bloß sehr vorsichtig mit dieser Aussage, weil wenn ich mal drauf schaue, was wir so Anfang dieses Jahres auch Teile umgesetzt haben, wo wir bei 5.000, 6.000, 7.000 Euro schon ein Stück schon heute wirtschaftlich sind im 3D-Druck. Von dem her geht hier einfach auch der Trichter nach oben extrem auf. Aber zu Beginn ist, glaube ich, genau dieses Thema, auch diese Wirtschaftlichkeit darzulegen, ist natürlich in geringerer Stückzahlenbereich schon sehr, sehr sinnhaft. Ja.
Jetzt hast du Interior, Zierteile, so das ganze Thema angesprochen, was ich auch total gerade im Busbereich natürlich extrem sinnvoll finde, wenn du auch da, wenn wir heute mal, was es heute wieder für eine Renaissance erlebt hat, das Thema Bus, ja. Und da muss natürlich relativ schnell wieder on the road sein, ähnlich wie beim Flugzeug. Wenn man jetzt auch mal so eher in die, ich sage nicht sicherheitsrelevanten Teile, aber in die Teile reingeht, wo dann schon mehr Beanspruchung da ist, wie weit seid ihr da heute?
Also da laufen mit Hochdruck bei uns die Tests dazu. Also wir haben Stand heute noch den Fokus auf nicht sicherheitsrelevante Teile, weil ja aus dem Markt raus noch viele Erfahrungen und Kennwerte auch fehlen. Und es ist natürlich schwierig, wenn wir dann irgendwo Bremsen, Teile drucken und man ist sich da nicht hundertprozentig sicher. Das geht gar nicht, das ist ein No-Go. Und von dem her laufen da bei uns schon seit 2, 3 Jahren ganz viele Tests, Dauerbelastungstests, gerade in diesem Segment. Und schauen wir mal, wie lange es dann dauert. Aber ich glaube, das ist auch nicht mehr zu weit in der Zukunft, dass wir hier auch die ersten sicherheitsrelevanten Teile drucken werden.
Letzte Frage, dann gebe ich dir eine wohlverdiente Pause, bevor wir dann gleich ins Panel reingehen. Jetzt bist du natürlich bei einem Hersteller und du hast ein Additive Manufacturing Center unter dir, das du bestimmen kannst. Was erwartest du sozusagen von den anderen Systemteilnehmern? Maschinenhersteller, Materialhersteller. Inwieweit arbeitet ihr da zusammen und was würdest du dir wünschen? Weil du bist ja de facto einer der wichtigsten Kunden zurzeit in der Industrie und treibst es richtig. Was fehlt noch aus deiner Sicht?
Also ich glaube, die Vernetzung ist schon richtig gut und also sowohl auf Softwareseite wie auch Werkstoffe, wo bei uns wir gerade qualitativ, also von der Qualitätsseite her, mein Qualitätsmanager wirklich hier ganz, ganz eng verzahnt auch ist. Ich glaube, gerade so, wenn wir in dieses Thema Digital Rights Management schauen, da wünschen wir uns schon nochmal ein bisschen mehr Offenheit, weil jeder hat es ein bisschen so auf dem Schirm stehen, auch viele Softwarehersteller, viele Maschinenhersteller und dann ist aber oft noch so ein bisschen diese, ich sag mal, alte Welt, wo es sagt, oh, das ist mein Geheimnis hier drin. Ich glaube, das Thema Partnerschaft und hier gemeinsam an einem Strang ziehen, ich glaube, wenn das jeder nochmal so ein bisschen mit nach Hause nimmt, ich glaube, da können wir nochmal ganz, ganz viel vorantreiben.
Alles klar, in diesem Sinne. Meine Damen und Herren, Ralf Anruf stellt nochmal einen Riesenapplaus hier von der Seite. Super, sensationell, danke dir. Meine Damen und Herren, wir machen eine kleine Pause und versorgen Sie nochmal mit Highlights der Messe. Und danach treffe ich hier 4 super spannende Teilnehmer zu einem Panel, wo es genau um das Thema Karriere und Weiterbildung geht. Bleiben Sie dran, wir sehen uns gleich.
Hello, we are in front of the Additive Industries booth and I will talk to Karriere to speak about their flagship product.
Additive Industries designs and manufactures the world's most automated metal additive manufacturing printers. Our customers benefit from the ability to scale production of their additive components. The main benefits of an Additive Industries printer are the high levels of automation that our customers can benefit from. The first level of automation is the automated build changeover, allowing customers to maximize the utilization of the machine without having to shift to a 2 or 3 shift pattern. The second is that we automate powder flow, keeping operators safe and away from metal powders. And the third is that we automate laser calibration, allowing customers to have the highest uptime. We have so far been very successful in the space industry and aviation, as well as general industry, which includes high technology. All our customers are focused on production. So it's fair to say that more than core markets, it's more about the core requirements of our customers being aligned with ours in that they are looking for a system that is aimed at production.
Adam is a spin-off of the Technikon Holding. We are a young company working in the fields of metal additive manufacturing. As we start from a greenfield planning, we directly from the start opt for maximum flexibility and automation, and that is the reason why we work with the Metal Fab G2 system of Additive Industries.
We would encourage anyone interested in additive manufacturing to get in contact with Additive Industries immediately. Wherever you are in your AM journey, whether it's at the beginning redesigning a part for additive or scaling a part for production, we have a team ready to assist you. You can reach us via our website or social media or get in touch with anyone you know on our team. We look forward to hearing from you.
Printing enthusiasts, welcome to Formnext. Formnext has 3 halls, 11.0, 11.1, and all the way across we go to 12. We're on our way to go get some nice footage for you to enjoy. And remember, it's not just about additive manufacturing, it's about being 3D. The Frankfurt Mess Fair is huge, and year after year, Formnext finds its footing here with cutting-edge technologies that the exhibitors have to show us. And hall number 12 right across has more of it. So come along, I have so much more to show you. Look at the lengths we are going to get you the content you deserve here at Formnext 2022. We'll go to great lengths for you. This 3D cutting-edge technology making you hungry and getting a hankering for hot dogs? Well, here we are, all American hot dogs. Hope they're not 3D printed, hope they're real. But are these hot dogs 3D printed?
No, but good.
Oh, well, you've got your answer here. 12.1, best hot dogs ever.
Hallo und herzlich willkommen zurück, liebe Zuschauer. Wir machen weiter mit unserem Panel zum Thema Karriere und Weiterbildung. Und ganz offen, wenn wir über die Zukunft der additiven Fertigung sprechen, dann kommen wir immer relativ schnell zu den Themen Fachkräftemangel, zu wenig Nachwuchs und damit auch aus meiner Sicht zu den wirklich großen Herausforderungen, die wir aktuell bei uns in der Branche haben. Und in unserem Panel möchte ich mit Gästen, die zum einen aktiv am Fortschritt der additiven Fertigung mitwirken, aber auch natürlich die Herausforderungen haben, zu wenig Nachwuchs zu haben, genau über dieses Thema sprechen. Deswegen begrüßen Sie mit mir auf der Bühne zu meiner Linken, den kennen Sie schon, der war nämlich vorhin schon da, den Ralf Anderhofstedt, Head of Center of Competence, Additive Manufacturing at Daimler Trucks and Buses, muss man noch dazu sagen. Ralf, schön, dass du wieder da bist. Dann Dr. Markus Hering, Geschäftsführer beim VDMA für 3 Geschäftsbereiche. Tatsächlich einer davon, Thema additive Fertigung. Markus, schön, dass du da bist. Freue mich sehr.
Hallo, guten Morgen.
Dann haben wir Christoph Haug, Vorstand bei der Toolcraft AG. Auch sicherlich sehr abhängig davon, dass wir mehr Fachkräfte bekommen, oder? Absolut. Herr Haug, schön, dass Sie da sind. Und dann, last but not least, Hans-Alfred Bräuniger. Sie sind Unternehmensberater zum Thema additive Fertigung.
Genau, ja.
Seit Jahren schon extrem aktiv, das Thema voranzutreiben. Und haben natürlich Partnerschaften auch mit der IHK, da sprechen wir nachher noch drüber. Ja. Schön, dass Sie vier da sind. Ralf, du hast in deinem Vortrag vorhin das Thema schon angesprochen. Jetzt seid ihr natürlich relativ prominent in der Branche. Jeder kennt euch. Habt ihr Probleme dann überhaupt, Leute zu finden?
Ja, absolut. Also der War of Talents ist auch bei uns angekommen und ich glaube, das spürt man auch, durch das Thema 3D-Druck natürlich branchenübergreifend da ist. Und wenn man so die Wachstumszahlen mal anschaut, was ja wirklich jährliche Wachstumsraten von 17 bis 18% weiterhin, da sieht man einfach, dass das Thema überall präsent ist und auch wir kämpfen hier natürlich, dieses Wissen an die bestehenden Mitarbeiter bzw. auch neue Mitarbeiter dafür zu bekommen.
Wahnsinn. Markus, jetzt hast du natürlich einen Überblick über die gesamte Branche, nicht nur spezifisch auf ein Thema. Ist das ein sehr aktives Thema bei euch? Ihr habt einen eigenen Arbeitskreis dafür, soweit ich weiß. Wie oft wird das so von euren Mitgliedern auch an dich adressiert, das Thema?
Es ist im Prinzip ein tägliches Thema, ja. Auch nicht nur für AM, sondern für den gesamten Maschinenbau. Wir sehen es ja auch, wenn man sozusagen in die Öffentlichkeit schaut. Wir sehen, das Thema Handwerk, Ausbildung ist ein Thema, dem geschuldet natürlich, dass die Geburtenzahlen rückläufig sind seit vielen Jahren. Also es kommt einfach weniger nach von unten. Dann sehen wir, dass viele der geburtenstarken Jahrgänge jetzt in Ruhestand gehen. Das heißt, es bricht vieles weg, viele Leute mit Erfahrung. Wir sehen, dass die Anforderungen sich verändert haben mit der Digitalisierung, mit IT-Kenntnissen, die notwendig sind, die gefragt sind. Und es sind eben ganz viele Branchen, ganz viele Unternehmen, die sich auf weniger Köpfe stürzen, die gerne haben wollen. Und es ist ein echter Wettbewerb um die Talente.
Damit sind wir schon bei Ihnen, Herr Haug. Wettbewerb um die Talente, da sind Sie mittendrin, nehme ich an. Bei Ihnen nimmt additive Fertigung großen Stellenwert ein, wenn ich es richtig verstanden habe. Vielleicht mal kurz zu Toolcraft und Bedeutung additive Fertigung und dann auch in Verbindung damit, was machen Sie dann ohne Fachkräfte oder wo kriegen Sie sie her?
Also gut, additive Fertigung ist bei uns ein neues Technologiefeld, das wir jetzt bereits seit 11 Jahren bei uns installiert haben. Also wir kommen ursprünglich aus der Zerspannung, 1989 begonnen mit einer Dreiachsfräsmaschine in der Garage, jetzt vom Einmannbetrieb Richtung 430. Wir haben noch einen Werkzeugbau, wir haben noch 30 Spritzgießmaschinen und final noch Robotic Engineering. Und wie gesagt, additive Fertigung macht mittlerweile von dem Gesamtjahresumsatz 60 Millionen, sind wir ausschließlich in Metall, knapp bei 9 Millionen. Wir haben 25 Leute bei uns in der additiven Fertigung, die im Bereich Engineering und Produktion tätig sind. Jetzt haben aber wir vielleicht, Gott sei Dank, gegenüber dem Daimler noch den Vorteil, dass wir ein bisschen regionaler gelegen sind. Wir sind 40 Kilometer südlich von Nürnberg, aber es wird herausfordernder, dass wir unsere Leute finden. Wir müssen da intelligenter sein, wir müssen mehr machen. Wir leben vom Nachwuchs, also wir haben eine sehr hohe Ausbildungsquote von also wir haben 60 Auszubildende in verschiedensten Berufen, also weit über 10%. Wir müssen einfach das Wachstum abfedern können über junge Leute und das ist so unsere Strategie.
Sehr gut. Wir kommen nachher noch zur kreativen Lösung der Toolcraft in dem Bereich. Herr Bräuniger, jetzt stelle ich mir vor, als Unternehmensberater, ich bin eher im Bereich Vertrieb häufig unterwegs bei den Themen in der additiven Fertigung, aber jetzt in Ihrem Bereich, Sie beraten ja mannigfaltige Unternehmen und jetzt stelle ich mir vor, Sie entwickeln die und Sie sehen auch das starke Wachstum, was Ralf vorhin ansprach. Ja, ja. Da stehen die aber trotzdem dann bei Ihnen wahrscheinlich und sagen direkt, Herr Bräuniger, super Idee mit dem Wachstum, aber ohne Leute, wie soll ich das machen?
So, ich versuche den roten Faden zu finden für die Unternehmen vom Prototypen über die Serie dann bis zum Ersatzteilgeschäft und der rote Faden fehlt bei vielen Mittelständlern. Also ihr habt es super schon etabliert, aber der rote Faden ist eigentlich in der Regel nicht da und viele Unternehmen sind auch extrem fokussiert auf ihr Tagesgeschäft und gucken einfach nicht über den Tellerrand hinaus. Und was so fehlt, ist der Additive Mindset im Gesamtunternehmen. Also deshalb ich fange meistens mit Workshops an der Spitze an, um die zu begeistern für 3D-Druck. Und der Blick muss breiter werden. Ich muss erkennen, dass ich auch bei Montagehilfsmitteln oder auch in anderen Bereichen wirklich große Potenziale heben kann, was den Leuten einfach gar nicht so klar ist. Ja? Also ich würde gern das auch auf den internen Mindset in den Firmen setzen, unser Gespräch, und jetzt nicht nur auf den War for Talents. Ja.
Naja, wobei War of Talents, also ich bin bei Ihnen, wenn das Mindset da ist, dann investiert man sicherlich auch an der richtigen Stelle.
Ja.
Ne? Markus, wir haben gestern in unserem Panel, in dem Afterwork tatsächlich, haben wir auch mit einmal deinem Kollegen aus dem VDA gesprochen und dann von France Additive haben wir gesprochen, und da war auch das Thema nationale Pläne, wie kooperieren wir und wie machen wir das Thema bekannter. Das ist so mein Eindruck. Wir haben so viele technische Berufe, wo uns heute die Mitarbeiter fehlen. Wie bekannt ist dann additive Fertigung und wie machen wir es bekannter, dass die Leute überhaupt sagen, wow, das ist ja super spannend, vielleicht spannender als der klassische Zerspanerberuf oder was es da sonst für Berufe im technischen Bereich gibt. Was tut ihr da von eurer Seite, um das zu pushen?
Ja, wir versuchen natürlich, dieses Thema in die Öffentlichkeit zu tragen. Ehrlich gesagt, ich glaube, das ist gar nicht die ganz große Herausforderung, weil das Thema ist einfach so spannend, so innovativ für junge Leute. Man kann sie relativ schnell dafür begeistern bekommen. Und man muss eigentlich nur mal durch die Messehallen gehen oder hier im Publikum schauen und man sieht einfach, der Anteil junger Leute ist extrem groß. Das sieht auf anderen Messen ganz anders aus. Im Bereich Maschinenbau, da ist der Altersdurchschnitt erheblich höher. Und für die ist es die Herausforderung, junge Leute zu bekommen. Ich glaube, wir haben grundsätzlich über unsere Kontakte auch zu den Hochschulen, über unsere Kooperationen mit Forschungsinstituten einen guten Zugang, damit auch zum Nachwuchs. Die Herausforderung, wie Herr Bräuninger dann schon sagt, ist eben, dass die Unternehmen das auch umsetzen, dass die jungen Leute, die das gelernt haben, die die Ausbildung dazu haben, dann in der Lage sind, das in der Praxis umzusetzen.
Oh, Herr Haug, das führt mich sofort zu Ihnen. Jetzt haben Sie ja 60 Auszubildende verglichen mit der Mitarbeiteranzahl. Eine unfassbare Anzahl, was ich sensationell finde. Wie viele von den Auszubildenden sagen denn von sich aus und spüren das auch im Unternehmen, Mensch, additive Fertigung, das ist unser Zukunftsthema, da möchte ich auch rein? Oder wie pushen Sie das?
Also generell müssen ja bei uns die Auszubildenden alle Bereiche durchlaufen, also die müssen jeden Fachbereich kennenlernen. Und von dem her kommen sie sehr früh in Kontakt mit additiver Fertigung. Und was wir dann irgendwann mal ins Leben gerufen haben mit der IHK in Nürnberg, das war eine Zusatzqualifikation additive Fertigung im Bereich Metall- und Elektroberufe. Also unsere Auszubildenden, die werden auch angehalten, das dann eben bei uns auch zu belegen. Und klar, wir freuen uns, wenn junge Leute sich nach der Ausbildung entscheiden und sagen, hey, ich möchte hier in die additive Fertigung, ich möchte eine LMD-Anlage bedienen, also Laserauftragsschweißen. Also das funktioniert ganz gut.
Okay, da ist Interesse da auf jeden Fall. Sehr gut. Herr Bräuninger, Sie haben es gerade schon hochgehalten. Ich darf das auch einmal kurz nochmal in digital, wir haben es in digitaler Form, kann ich es auch nochmal einblenden. Also es gibt einen entsprechenden Zertifikatslehrgang, den Sie mit der IHK zusammen entwickelt haben. Vielleicht mal ein Wort.
Auch dabei.
Ah, sehr gut, super. Vielleicht mal ein kurzes Wort dazu. Was können die Leute da lernen? Wie war die Idee dahinter? Wie kam das zustande?
Also wir haben 2 Lehrgänge entwickelt. Einmal einen Einführungslehrgang mit 50 Stunden und dann einen Vertiefungslehrgang. Und die werden beide angeboten, kosten auch nicht so viel Geld. Also dieser Vertiefungslehrgang wird jetzt in Stuttgart angeboten, kostet 1.700 €, finde ich, mit sehr viel Praxisteil bei vielen Firmen. Also da kann ich mich schon mal dem Thema sehr öffnen und das ist auch ein Preis, der auch für jemanden, der jetzt wo es nicht die Firma gleich zahlt, der sich einfach in das Thema da einfinden kann. Also einfach mal bei den IHKs schauen, dort gibt es ein gutes Angebot an 2 Kursen, es wird bundesweit durchgeführt. Ja.
Aber da kommen wir wieder zum Thema Mindset. Dann muss natürlich das Mindset im Unternehmen auch da sein, zu sagen, yo, da schicke ich mal jemanden hin und der kann das machen tatsächlich. Ne?
Vielleicht eine Ergänzung an genau der Stelle. Wir haben uns nämlich mal angeschaut, gerade jetzt für die Ausbildungsberufe, inwieweit ist additiv eigentlich Bestandteil heute der Ausbildungsberufe? Und die sind ja in den letzten Jahren, Jahrzehnten erheblich flexibilisiert worden, sodass die Unternehmen selbst entscheiden können, welche Punkte nehme ich mit rein, welche Schwerpunkte setze ich. Und wir sehen, dass im Prinzip gerade in den Metallberufen das Thema Ausbildung im Bereich Additive mit beinhaltet ist. Wir sehen aber auf der anderen Seite, dass nur ganz wenige Auszubildende das wirklich belegen. Und da gibt es mehrere Punkte, warum das so ist. Das eine ist, die IHKs tun sich schwer, entsprechende Prüfer zu finden, die dann wiederum dieses Thema abprüfen können. Und das andere ist, die Ausbilder in den Unternehmen müssen wir natürlich auch abholen, dass die in der Lage sind, diese Themen zu transportieren. Dann sind wir wieder bei den geburtenstarken Jahrgängen. Das sind nämlich häufig dann die Leute in dem Alter, also in unserem Alter, die Ausbildung leiten. Die haben diese Technologie nie in der Praxis erfahren. Die haben zu anderen Zeiten studiert und ihre Ausbildung erfahren. Und die müssen wir jetzt abholen, dass sie auch in der Lage sind, das an die nächste Generation weiterzugeben. Weil sonst helfen die besten Ausbildungsschemata nicht, wenn wir es nicht schaffen, dieses Thema in die Unternehmen hineinzutragen. Und da müssen wir an ganz vielen Stellen ansetzen. Oben ist sicherlich richtig, aber auch im Bereich Ausbildung, dass die wirklich die neuen Dinge schulen. Und da sehe ich einen ganz großen Bedarf. Wie gesagt, wir haben eine Auflistung, was es alles gibt. Es gibt extrem viele Möglichkeiten, sich weiterzubilden. Aber wenn es die entscheidenden Köpfe in den Unternehmen nicht wissen, dann kriegen wir es auch nicht in die Breite getragen.
Ralf, damit kommen wir zu dir. Magst du erst oder soll ich dir mal eine Frage stellen?
Gar nicht du. Also ich könnte gleich, aber...
Ja, ich habe genau dazu. Jetzt haben wir bei euch ja tatsächlich auch eine große Anzahl von genau den Personen, die Markus gerade angesprochen hat, den Ingenieuren, die eine lange Erfahrung haben, die unglaublich viel Wissen auch weitergeben können, aber natürlich zu einer Zeit studiert haben, nicht falsch verstehen, geht für mich ja genauso, wo man jetzt nicht auf lebenslanges Lernen gesetzt hat und ich freue mich jeden Tag über eine neue Technologie, die ich mir dann wieder aneignen kann. Du brauchst ja eigentlich auch neben Nachwuchs auch Leute, die mit Erfahrung kommen und in eure Themen einsteigen. Wie hoch ist da das Interesse oder ist es eher so ein Ressentiment, um Gottes Willen, ich beschäftige mich nicht mit was Neuem? Was macht ihr da in dem Bereich?
Nee, also das ist genau der Punkt, wo für uns auch ganz entscheidend war, weshalb wir sofort geschaut haben, als wir mit dem Thema industrieller 3D-Druck losgelaufen sind, dass wir die Bereiche mit dazu holen. Weil wenn jeder so sein Süppchen kocht, der eine kocht es, der andere kocht es nicht, war es für uns entscheidend, dass wir die Ausbildung und auch die Weiterbildung bei uns von Anfang an mit dabei haben. Und genau diese Punkte, dass unsere Ausbildungsleiter dann genau diese Schulungen, was heißt denn das? Und dass die dann auch vor Ort waren, da gibt es Kollegen, die waren bei der IHK schon für gewisse Weiterbildungsangebote aus dem Bereich raus. Das ist immens wichtig, um das dann auch in die Masse an die jungen Nachwuchskräfte dann ranzutragen. Das ist A und O. Wenn wir das nicht gemacht hätten, wäre es ganz dünn geworden.
Aber da sind wir ja beim ganz wichtigen Thema. Also selbst wenn wir den Nachwuchs beackern, wie wir wollen, wir haben rein statistisch einfach zu wenig. Ich glaube, da sind wir uns einig drüber, oder?
Ja, ja.
Also müssen wir ja auch Menschen, die schon Erfahrung haben, die vielleicht heute, ja doch, uns ging es einfach zu gut auch in den letzten Jahren, ja, die ja immer noch einen großen Bedarf spüren, aber die müssen wir ja auch dafür begeistern. Ne? Jetzt haben wir, Herr Bräuninger, vielleicht mal aus Ihrer Praxis, nicht nur die Geschäftsführung begeistern, auch die lange Erfahrung haben, die ingenieurtechnisch unterwegs sind. Wie kriegen wir die?
Also ich merke halt, dass wenn Firmen sehr lean organisiert sind, dann guckt man auch wenig über den Tellerrand hinaus. Man versucht, seine Lean-Kultur zu leben. Ja. Und da gehört bei einigen Firmen einfach 3D-Druck nicht dazu, ja, weil haben wir schon immer so gemacht und machen wir weiter. Und deshalb versuchen wir, low-hanging fruits aufzuzeigen und damit die Mitarbeiter dann auch für die Potenziale zu begeistern. Und speziell in Montagehilfsmitteln steckt echt mehr Potenzial drin, als man denkt. Muss ich ernstlich sagen, wenn man da einsteigt, mal ein super Beispiel findet, dann kann man da richtig viel Geld auch noch holen, was die Leute dann auch motiviert und den Blick auch weitet. Ja? Also der AM-Mindset, das ist für mich so ein bisschen das Schlüsselwort. Ja.
Ja. Ich muss auch nur dazu sagen, also es sind ja nicht nur die jungen Leute, die auszubilden oder auch die Ingenieure, sondern wir haben ja bei uns Leute, die sind branchenfremd. Und da finde ich das eigentlich sehr, sehr gut. Also wir haben bei uns Leute in der Produktion, die kommen vom Bau. Und die lieben das bei uns, weil die sagen, hey, da ist es nicht kalt, da friert es mir nicht, da regnet es nicht. Super Produktionsumgebung. Und den Leuten, denen kannst du halt auch, und da bin ich absoluter Fan von, also eigentlich wären sie ja theoretisch abgehängt und wären halt irgendwo im Bereich von Hilfskräften unterwegs. Und durch diese Weiterbildungen kann ich den Leuten halt auch noch eine Perspektive bilden, auch wenn sie vielleicht schon etwas höheren Alters sind. Also wir haben auch Leute bei uns in der Produktion, die sind 50 Jahre alt und die kannst du halt über so eine interne Weiterqualifikation halt auch im Lohnniveau dann anheben. Also wenn da eine Motivation da ist, die additive Fertigung, die ist eigentlich relativ schnell zu erlernen. Also
ich finde das einen ganz schönen Punkt, weil das ist tatsächlich bei uns auch so. Darum gefällt mir das AM-Mindset so gut. Ich glaube, darum geht es am Ende des Tages. Also wir haben bei uns in der Produktion, Konstruktion natürlich auch Mitarbeiter, die schon an die 50 oder sogar darüber
klar,
sind.
Klar.
Ganz normal und da ist Riesenerfahrung da, was du auch vorher gesagt hast. Sven, das ist ja auch wichtig. Aber genau diese zu erreichen und dann zu sagen, was können wir denn da machen und auch diese Ängste und Sorgen zu nehmen, weil das spüren wir halt extrem. Da ist eine Erfahrung, ich habe 20, 25 Jahre jetzt so konstruiert, jetzt kommt was Neues, jetzt ist ja mein Wissen weg, hier einfach auch so die Hand zu reichen und zu sagen, da geht es weiter. Und es ist ja unglaublich wichtig, dass wir dieses Wissen noch haben. Das ist so
also Anekdote aus der Praxis, wenn es um Montagehilfsmittel geht, kann man die, wenn man sie druckt, ja auch sehr filigran machen, weil man genau die Kräfte ja ausrechnen kann. Und wir drucken die dann oft mit wesentlich dickerer Wandstärke, um den Leuten die Angst zu nehmen, dass sie Angst haben, das geht jetzt kaputt, ja.
Wobei ich persönlich habe, und ich versuche das wirklich aus meinem Wortschatz mittlerweile zu tilgen, ich spreche nicht von Druck. Also drucken, ich habe 2 Söhne, der Große ist 11, der kann sich einen 3D-Drucker kaufen, irgendwo für 250 €. Ich möchte auch schon sagen, was wir betreiben, und das macht ihr genauso, ist industrielle additive Fertigung. Also das ist eine neue anerkannte Fertigungstechnologie, die auch in der Anschaffung von Maschinen ein Vielfaches von 250 € ist. Und ich versuche da auch in der Beratung, die wir natürlich unseren potenziellen Kunden irgendwo geben, also der 3D-Druck, ich spreche nicht davon, weil das entwertet das, was wir betreiben. Also ich sage wirklich, wir sind in einer additiven Fertigung unterwegs. Wir haben Lasersysteme, die dazu führen, dass wir einen Feststoff generieren können. Ist so im Moment für mich wichtig.
Du sprichst mir aus der Seele. Ja. Weil tatsächlich, das Thema 3D-Druck ist ja so, das ist ja auch bei uns gewesen. Man fängt an zu diskutieren, ja, 3D-Druck mache ich auch schon. Klar, sicher.
Ich habe auch einen Plastikdrucker zu Hause.
Aber das können wir ja in unsere Fahrzeuge nicht einbauen. Ja. Und dann stopp, weil 3D-Druck ist von ganz vorne, so wie du es gesagt hast, für 250 € bis hoch mehrere Millionen. Man muss aufpassen, dass man da nicht Äpfel mit Birnen vergleicht. Ja.
Aber vielleicht noch mal zu den bestehenden Mitarbeitern in der Produktion, also die Gewerblichen, aber auch die Ingenieure. Ich glaube, das ist sicherlich das größte Potenzial, was wir haben, was wir auch heben können. Es sind ja Leute, zu denen wir Zugang haben als Unternehmen, auf welcher Ebene und wie auch immer, aber wir haben sie an der Angel. Und ich glaube, es ist ganz, ganz wichtig, denen zu vermitteln, dass es auch eine Chance ist, nochmal neue Dinge zu lernen. Das beschränkt sich nicht nur auf die additive Fertigung. Wir haben das große Thema Digitalisierung in allen Bereichen. Also es ändert sich ganz viel. Das ist, glaube ich, das, was wir kommunizieren müssen. Das bietet viele Chancen. War übrigens immer so. Also wenn wir mal 30 Jahre zurückschauen, dann kamen irgendwann CNC-Fräsmaschinen. Das hieß für die Jungs an der Fräse auch, wir müssen irgendwas Neues lernen.
Oder CAD.
Genau, und wir haben diese Dinge auch umgesetzt. Also insofern sollten wir als Industrie gar nicht so viel Angst davor haben. Wir sollten unsere Leute mitnehmen, wir sollen ihnen aufzeigen, welche Möglichkeiten sie haben. Und ich bin mir sicher, wenn wir das in der richtigen Art und Weise machen, dann werden wir einen Großteil der Belegschaft mitnehmen können. Und die werden genau dieses Thema aufgreifen. Aber es liegt in unserer Verantwortung als Industrie, als Unternehmen, dass wir genau dieses umsetzen. Und wie gesagt, die bestehenden Mitarbeiter, die wir haben, das ist der allergrößte Hebel, den wir umsetzen können. Also diese immer kleiner werdenden Gruppe der Auszubildenden und der neuen Ingenieure, die können wir versuchen zu bekommen, das macht auch jeder. Aber das, was wir als Potenzial haben, das müssen wir stärker spielen, die Karte.
Wobei, da muss ich nochmal Herrn Broningers Punkt mit dem Mindset. Jetzt haben wir mit dem Herrn Haug einen, der ist Vorstand. Ne? Der kann, wenn der das richtige Mindset hat und Lust drauf hat, und so klingt es zumindest bis hierhin, Herr Haug, ja, das ist ja eher eine Ausnahme, nehme ich an. Ne? Wie empfindest du das denn bei den Unternehmen? Ihr redet ja dann häufig auf Level Vorstand oder Bereichsleitung mit den Kollegen dann auch. Ist da ähnliches Mindset wie jetzt bei Herrn Haug, der sagt, da will ich rein in die Industrie, da will ich mehr machen, oder musst du auch nochmal Zweifel aus?
Ich muss ja jetzt sagen, als Repräsentant des Maschinenbaus muss ich sagen, klar, machen das alle. Das ist doch logisch. Nein, ganz ehrlich gesagt, wir finden viele Unternehmen, die genau das sehen. Die sehen ja alle die Notwendigkeit. Ich könnte eigentlich viel mehr als Unternehmer liefern, ich könnte viel mehr Produkte produzieren, kann ich nicht, weil Leute fehlen. Also dieses Thema ist bei allen da. Aber es gibt natürlich auch die Unternehmen, die kleineren Unternehmen, die ich sag mal 20, 30, 40 Mitarbeiter haben, auch die haben wir im Maschinenbau, die natürlich auch ganz viele andere Themen haben. Und Sie haben dann eben gesagt, naja, ich habe ein funktionierendes System. Das muss man halt auch mal verstehen. Also ich habe ein Unternehmen, das läuft, das funktioniert, das verdient Geld. Ist es wirklich angebracht, jetzt daran anzufangen, rumzuschrauben und irgendwelche Experimente zu machen? Da kann ich den einen oder anderen Unternehmer auch verstehen. Wie gesagt, wir als Verband transportieren das immer wieder, dass es extrem wichtig ist, sich weiterzuentwickeln. Wir machen die Angebote an die Unternehmen, sagen, schaut, was um euch herum passiert, und das wird auf euch als Unternehmen Einfluss haben, wie auch immer. Auf der anderen Seite muss man das aber auch ganz ehrlich sagen, es ist am Ende eine unternehmerische Entscheidung, wie man sein Unternehmen aufstellt. Und dafür ist der Unternehmer, der Inhaber, der angestellte Geschäftsführer, wer auch immer, der Vorstand bei den börsennotierten und bei den Aktiengesellschaften am Ende verantwortlich.
Aber du sprichst ein ganz wichtiges Thema an, so aus meiner gelebten Praxis. Du hast gerade die Veränderungen angesprochen und ich bin ja viel auch in der Produktion unterwegs. Und was ich dann immer erlebe, also gerade das Thema Digitalisierung, war letztens bei einem Unternehmen Raum Stuttgart, wo es darum ging, über iPads die Produktion zu steuern. Und ihr glaubt gar nicht, was das für eine Herausforderung war, die Vorarbeiter entsprechend überhaupt in die Nähe dieses Gerätes zu bringen. Also wir haben natürlich auch, das darf man nicht vergessen, wenn man sich unsere Landschaft mal anschaut, auch eine sehr hohe Anzahl von Veränderungen. Du hast gerade angesprochen, da stecken Chancen hin, aber es kreiert natürlich auch massiv Ängste bei den Leuten, dass sie das Gefühl haben, ich könnte gerade Digitalisierung dabei auf der Strecke bleiben. Jetzt ist additive Fertigung ein unglaublich digitaler Prozess, ja, und da wird der eine oder andere Kollege, mal Frage an Sie, Herr Haug, vielleicht auch denken, oh, bin ich dann nachher noch gefragt bei dem Thema?
Also das eine ist ein toller digitaler Produktionsprozess, aber im Post-Processing, gerade bei Metall, hast halt teilweise auch noch handwerkliche Sachen. Diese Stützstrukturentfernung ist für uns ein Riesenthema. Also da fordern wir auch die Anlagenhersteller, die Softwareentwickler auf. Wir müssen da freier werden. Das kann es überhaupt nicht sein, dass ich hier toll und autonom produziere und hinterher muss ein Mensch mit einem Meißel ran. Wir sind sowieso in regulierten Industrien. Also wir müssen diese händische Arbeit rausbekommen, weil es immer kritisch sein kann, was eine Prozessfähigkeit angeht. Also da ist man auch dran, aber das entwickelt sich Gott sei Dank gut weiter, aber bei uns im Unternehmen ist es so, das ist halt unser Mindset. Also jeder Tag ohne Veränderung ist eigentlich ein verschenkter Tag. Also wir befinden uns in einer stetigen Transformation und von dem her ist es für uns relativ einfach und wir sind auch krisensicher. Also dadurch, dass wir uns ständig verändern und wir dürfen das zulassen, Kraft unserer Strategie. Also wir haben so viele Technologiethemen im Kopf, die wir uns dann ins Haus holen, vielleicht ein bisschen früher als andere vom Technical Readiness Level, aber unsere Leute, die werden da mitgenommen. Wir haben jetzt gerade so etwas außergewöhnlich für den Mittelständler. Also wir fahren unsere komplette Digitalisierungsstrategie jetzt mit einer Firma Siemens, die ja eher bei den Konzernen angesiedelt ist. Aber wir glauben an das Unternehmen und von dem her sind die iPads bei uns auch mehr und mehr jetzt im Verkehr. Wir haben aber auch noch Papier. Da wollen wir natürlich auch wegkommen davon. Und es gibt ja nicht diese festgetackerte Industrie 4.0 Strategie. Also sogar Unternehmen, das auf den ersten Blick ähnlich ist wie wir, die haben vielleicht andere Ansätze ihrer Industrie 4.0 Strategie. Also Angst haben muss keiner, sondern wir sagen eher, Leute, es gibt Chancen und wir sollten die Chancen wahrnehmen.
Herr Bräuninger, eine Frage nochmal. Mich würde nochmal interessieren, jetzt Markus, Herr Bräuninger auch nochmal, wenn wir über Größe von Unternehmen sprechen. Ne? Also vertritt der Haug ein mittelständisches Unternehmen, der Ralf ein ganz kleines Unternehmen. Ja. Wenn man jetzt mal sich die Industrielandschaft anschaut, alle haben generell grundsätzlich das gleiche Thema. A, wie ist das Bewusstsein in den verschiedenen Größen, würde mich interessieren. Wie unterschiedlich ist das? Und wie, weil Sie sagten vorhin, regionaler Anspruch, das ist einfacher. Ich habe auch Unternehmen, wo es genau anders ist, die in dem Umfeld halt gar nichts haben, sozusagen. Ne? Aber wie ist so, bei wem ist es am dringendsten, in welcher Größenordnung oder Region oder wo ist es am bewusstesten?
Also ich würde schon so sagen, so in der Größenordnung 100 bis 200, 300 Millionen Euro Umsatz, sowas in der Größenordnung. Und wir gehen oft rein und halten einfach nur einen 1,5-stündigen Vortrag über das Potenzial von AM, gerade bei der Geschäftsführung, und dann stehen die auch wirklich dahinter. Also man braucht so ein bisschen einen Türöffner. Und ich komme ja auch aus Stuttgart. Sie waren wahrscheinlich bei einem der schönen 3D-Druckhersteller in Stuttgart. Die haben einen super tollen Showroom und man könnte auch einfach mal sagen, es gibt so einen Tag der offenen Tür am Samstag. Wer sich 3D-Druck angucken möchte, kann da einfach mal durchgehen. Also dass die Firmen sich auch ein bisschen mehr öffnen, um was anzubieten, wie man sich informieren kann über 3D-Druck. Ja?
Vielleicht da noch ganz kurz anschließend, so aus der Praxis bei uns. Wir spüren das ja auch, wir reden ja mit vielen unterschiedlichen Unternehmen. Ja. Und gerade so die aktuelle Zeit mit den Herausforderungen, also sprich, ich kriege wirklich Teile nicht mehr her oder die Lieferketten sind gestört. Dieser lösungsorientierte Ansatz, der bewirkt schon auch extrem viel, dass man gar nicht unbedingt im ersten Step reingeht und sagt, hey, wir machen jetzt alle 3D-Druck, sondern hier ist ein Problem und wir suchen eine Lösung und vielleicht passt genau das Werkzeug 3D-Druck ganz gut dazu. Da haben wir schon ganz viel gespürt. Und auch umgesetzt, wo vorher so war, oh, 3D-Druck, weiß ich nicht, ob wir das machen, aber durch das, ja, lass doch mal drucken, wir haben hier Freigabeprozesse dazu und da gehen auf einmal viele Dinge, die hätte man sich vorher gar nicht vorstellen können.
Markus, nochmal eine Frage an dich. Wir haben jetzt ganz viel über den gewerblichen Bereich und die Ingenieure gesprochen, aber auch da gibt es ja Nachwuchs. Was mit dem Thema Universitäten? Ich meine, ich darf ja regelmäßig mit Katrin auch von der TUM zum Beispiel auf der Bühne sitzen und wir reden so über die zukünftigen Ingenieure. Ist das positiver, sagen wir, als der Gesamttrend oder wie siehst du so die Zusammenarbeit mit Universitäten, um da auch was zu tun an der Stelle?
Also ich glaube, bei den Universitäten, die Ingenieure ausbilden, ist das Thema Additiv irgendwie vorhanden bei allen. Und dieses irgendwie ist so ein bisschen auch wieder das Problem, was ich so damit habe. Wir haben natürlich in Deutschland erstmal eine Länderhoheit, wenn es um das Thema Ausbildung geht. Dann haben die Hochschulen selbst ganz viel Mitspracherecht, wenn es um ihre Ausbildung geht. Ich würde mir manchmal wünschen, dass es etwas mehr harmonisiert ist, dass wir einen gleichmäßigeren Zugang haben der jungen Leute, die studieren, unabhängig vom Studienort, sodass nachher auch das Unternehmen einfach auf einer gewissen Basis aufbauen kann. Das ist in der Praxis aber aufgrund der Gegebenheiten, die wir gerade in Deutschland haben, extrem schwierig umzusetzen. Was wir halt machen, ist gerade über unsere bilateralen Kontakte immer wieder die Hochschulen ansprechen und sagen, schaut mal da, schaut mal hin. Und das sind natürlich gerade die großen Hochschulen, die im Bereich des Exzellenzclusters sind. Die sind natürlich prädestiniert, die machen das auch, die haben auch die nötigen finanziellen Mittel. Bei den Kleinen ist es manchmal schwierig, die haben dann häufig wieder einen regionalen Ansatz, weil gerade ein Hersteller nicht weit entfernt zum Beispiel seinen Standort hat, dann gibt es da eine Verbindung. Also wie gesagt, wir finden das Thema AM bei allen Hochschulen, aber die Intensität und die Qualität unterscheidet sich noch erheblich. Und da würde ich mir wünschen, dass wir das harmonisieren können. Daran arbeiten wir, aber das wird lange, lange dauern, bis wir das wirklich komplett umgesetzt haben.
Also in Stuttgart haben wir in Baden-Württemberg ein regionales Netzwerk etabliert, Additiv im Südwesten, und wir haben 6-mal im Jahr ein Webinar, wo wir einfach neuere Entwicklungen aus dem Südwesten beleuchten. Geht immer 2 Stunden, haben wir mit dem IPA zusammen gemacht, Fraunhofer-Institut, und haben doch an die 100 Teilnehmer da immer. Also wenn man so regionale Keimzellen bildet, dann entwickelt sich da auch was, ja.
Aber in einem Punkt bin ich tatsächlich bei Markus, etwas, was ich auch vermisse. Wenn man sich natürlich mit den Professoren, mit den Researchern unterhält, ist häufig natürlich auch ein sehr spezieller Fokus in der eigenen Arbeit. Ja. Das beeinflusst natürlich dann auch deine Lehre, die du dann hältst. Ne? Das heißt, die einen gehen eher Richtung Laser, die anderen machen eher Materials. Ne? Also es ist ja eine ganz, ganz große Bandbreite, die wir...
Was ja im Bereich Forschung völlig in Ordnung ist.
Mega gut, ne? Aber
in der Lehre muss es halt so einen 85% Sockel geben, wo man sagt, die haben alles mal gesehen, die haben alles mal gehört und darauf kann man aufbauen. Wir wissen, es ist ja egal, auch in den klassischen Bereichen, jemand, der von der Hochschule kommt mit einem Ingenieursabschluss, der muss in der Praxis dann doch nochmal Dinge lernen, wie er es in der Praxis umsetzen muss. Das wird auch bei Additiv so sein, aber die Basis, die müssen wir angleichen. Das haben wir in den anderen Bereichen auch, bei den klassischen Produktionsprozessen, und das müssen wir bei Additiv auch hinbekommen.
Ralf, Markus hatte vorhin angesprochen, regionale Kooperation mit Universitäten. Es gibt da, ich glaube, FH Nürtingen ist das. Die haben einen sehr starken Automotive-Bezug und eigentlich einen eigenen Ausbildungsgang dafür. Habt ihr auch irgendwie eine Kooperation mit FH, Uni, wo ihr sagt, da schauen wir besonders drauf, dass viel potenzieller, abgreifbarer Nachwuchs, wenn ich mal so formulieren darf, rauskommt?
Also wir haben noch nichts konkret, wo man jetzt schon sagt, wir sind gerade an der Anbahnung, wir sind wirklich mit den Industrie- und Handelskammern bei uns im Austausch, schauen aber tatsächlich auch in den Hochschulen natürlich, und gibt auch einige Kontakte dazu. Da wollen wir genau in diese Kooperationsmodelle rein, weil wir halt genau dieses Thema sehen, also diesen Herausforderungen. Ja.
Aber bist du dann mal ab und zu auch mal an der Uni und hältst mal einen Vortrag oder gibt es sowas?
Ja, gab schon, ja. Als Gastvortrag, weil gerade so dieses Thema, es ist vollkommen richtig, dass dieser Sockel bekannt sein muss. Der ist natürlich sehr stark Konstruktion, Design, materiallastig. Aber von uns ist ja, wie vorher kurz im Vortrag auch angerissen, da verändert sich ja was. Also es verändert sich ja auch, es gibt neue Geschäftsmodelle, das bietet ja auch Chancen. Und da verändern sich ja auch Rollen in den Wertschöpfungsketten, wo wir sagen, seht mal ein bisschen das Größere, also so ein bisschen abgezielt auch in Richtung Einkauf, Supply Chain Management. Also sprich, da kommen ja viele Facetten mit rein, und darum wollen wir genau diese Botschaft auch nach außen tragen, genau in solchen Veranstaltungen. Also sprich, Rollen verändern sich im Laufe der Zeit.
Das ist übrigens ein ganz spannender Punkt, den wir noch gar nicht adressiert haben, reicht aber dummerweise die Zeit nicht mehr für. Ich komme ja ursprünglich aus dem Vertrieb, und wenn man mal genau reinschaut, das ist auch ein wichtiger Punkt, den du gerade de facto angesprochen hast, Ralf, es fehlt ja nicht nur an technischen Berufen. Ja. Wir müssen ja auch Leute haben, die Erfahrung in der Technologie haben und es auch vertreiben können am Ende. Wie finden Sie denn einen guten Vertriebler, Herr Haug, für das Thema additive Fertigung?
In der Regel sind ja wir mit diesen Fertigungstechnologien, die wir anbieten, wir haben jetzt gar nicht so den klassischen Vertrieb, weil klassische Vertrieb, der jetzt nicht die Basiserfahrung hat, der kommt natürlich sehr schnell, wird aufs Glatteis geführt. Also es meint da nicht jeder gut mit einem, sondern von dem her beraten wir wirklich mit Experten. Und wir haben ja dieses Ambitious Beratungsbranding. Das war ja nicht mal unsere Idee, sondern wir sind ja seit über 11 Jahren Zulieferer idealerweise zu OEMs, zu Tier 1s. Und es gibt die Großkonzerne, die gesagt haben, hey, wir wollen da erstmal einen guten Kompetenzpartner, weil das kostet ja da alles Geld. Also die Maschinen, die 5 Jahre alt sind, sind eigentlich veraltet. Da brauchst du die nächste Generation. Und es gibt Unternehmen, die gesagt haben, nee, wir setzen erstmal auf Eigenproduktion, also die Make-Strategie. Und diese Make-Strategie ist aber beim einen oder anderen Konzern, der halt einfach auch nach Konzernrichtlinien funktioniert, auch gescheitert. Und dann die es meiner Meinung nach richtig gemacht haben mit den Kompetenzpartnern, die haben dann auch verstanden, wo wendet man es sinnvoll an, wie kreiert man den Business Case, und auf einmal sind unsere Kunden auf uns zukommen, hey Toolkraft, vielen Dank, wir haben es begriffen, wir wollen jetzt selbst damit starten und ihr müsst uns unterstützen. Und wie gesagt, wir produzieren, wir sind kein Beratungsunternehmen, da draußen gibt es die Großen, die Kleinen, die Selbsternannten, dann kamen mehr und mehr Kunden auf uns zu und irgendwann haben wir gesagt, warum wir? Ja, ihr habt die Zertifikate, ihr habt die Erfahrung, ihr kommt aus der Praxis und so haben wir das Ganze und leisten auch unseren Beitrag. Also wir teilen Know-how. Jetzt könnte man sagen, wie blöd seid ihr eigentlich, aber ich sehe das ganz anders, weil ich open-minded bin. Wenn wir es schaffen, den additiven Kuchen sinnvoll größer zu bekommen, dann wird in der Regel auch unser Stück größer und
Sehr gut. Wir sind am Ende dieser Veranstaltung. Ich darf mich ganz herzlich bei den vielen Herren hier bedanken. Ich fand es sensationell, super interessant. Vielen Dank für die Einblicke, vor allen Dingen mal von Unternehmen, die auch ihre leidgeprüften Erfahrungen mit uns geteilt haben. Viel Erfolg für Ihre Zukunft. Ganz besonders mehr Leute dafür zu begeistern und das Thema generell voranzutreiben. Ich glaube, da sind Sie 4 genau die Richtigen dafür. Ganz lieben Dank dafür. Meine Damen und Herren, wir switchen um in einen Highlight-Block und danach begrüßt Sie mein Kollege Frank Jablonski wieder mit einem spannenden Expert-Insight. Schön, dass Sie dabei waren. Wir sehen uns in 4 Minuten. Bis gleich.
Hello, I'm Sandra from the Formnext team and we are in front of the Amiable booth. And we want to know more about their community. Let's check it out.
The Amiable community is about to help people to get on with additive manufacturing. No matter where they come from, no matter where they want to go to, it's just to look at their case, to discuss with them and to find people that contribute to each other just to get their solution done. The Amiable community is so special because it's from enthusiasts for people that are enthusiastic about additive manufacturing. So it's just to join people, to connect them, to look that they exchange knowledge, that they help each other and that they grow. The main objective of all those activities is that the solution is going to be achieved by those people that want to transfer their ideas into a product.
In this instrument, it's 80% manufacturing. It's amazing. The housing, the grill, the keys, and the mechanism inside, not the bellow. But I work on it. Look at this. And it works too.
I think people should be part of the Amiable community because it's always difficult to find the right answers to the problem that's currently on the table. We have so many experts around in different technology areas, on different materials, on different topics, that we'll always find a team where we can put things together. And people exchange. They should exchange in order to advance.
We came up with the idea of printing tiramisu when we met the guys from the Tiramisu World Cup. We have a 3D food printer. They know how to make a really great tiramisu. So we worked together in order to have a tiramisu 3D printer that has the same taste and has the approval of the Tiramisu World Cup.
If you want to be part of the Amiable community, then go to our website, sign up, and tell us what you need. That's what we must know in order to set up the right program for you guys.
That's a bad dog. What you do there? 3D printing is so far ahead in life. They even have dogs, and they're better than the real ones. You know what? You have to scoop up their poop. Oh, come on, Spot. You don't have to do that, bad doggy. Put the doggy back in your pocket. Here, come, doggy, doggy. Oh, come, bad doggy, sneaky doggy. Let's talk to the guy who's handling it. Come over here. You're from Top Solid.
No, I'm from Crucial Research.
You're from Crucial 3D.
Yeah.
Tell us about your dog. What's it called?
It's just standard Boston Dynamics dog, but we molded it with a 3D printer on the back. So now he can carry the printer and print it on.
Oh, nice. And
just for entertainment of
oh, I'm entertained.
Yeah.
So what's the name of your dog?
Just Spot.
And is he a retriever?
Just the original name of it.
Okay, and what breed is he?
Oh, I think somebody is.
Oh, that's a good answer. That's a good answer. Well, good doggy doggy.
Welcome to our expert insight short presentations. Here on stage have been prepared in cooperation with VDMA Working Group Additive Manufacturing. Our topic for today is education in additive manufacturing. And before we start with our presentations here on stage, I may have the one or the other tip for the audience out there at the screens, because here is a tremendous program for people looking for jobs. For example, we have here in Hall 11.0 at the booth number D70, that's here, and across over there it's D72. We have direct exchange with potential new employers. Okay, this is at the whole trade fair, you can have that one, but you have job wall here directly vis-a-vis, and there you can find vacancies. So maybe it's good to come here, and if it's this not enough, you find a free job application photo shoot at the booth until 4 o'clock in the afternoon today. And if this still not enough, you can have a free career consultation today up to 4 o'clock. Maybe this is the one or the other aspect to bring you here to the fair. I would be very happy to see you here. But now I'm happy to have my colleagues here from VDMA. We have the experts Stefan Braun. He's acting head of additive manufacturing R&D of KSB. It's a pump manufacturer. And Christoph Haug, he's member of the executive board of Toolcraft. And Gustavo Melo. Gustavo, nice to have you here, a project manager at RWTH Aachen University, and that's a DAP, and DAP stands for Digital Additive Production. But we are starting with Stefan Braun. We are very curious what you brought us in terms of here education and career in additive manufacturing. The stage is yours.
Yes, thank you. So, yes, my name, as he said, Stefan Braun from the company KSB. And yeah, I have one short presentation about the education we do in our company for additive manufacturing. We start direct at the bottom of the education story with our trainees. So we introduced in our company a special training content for our foundry mechanics. So the foundry mechanics in general has had different modules they have to do in their education. That begins with the metal technology, the special module for casting technology, the welding technology, and control technologies. And we added to this education additional module with additive manufacturing. So at first, we start with the technologies in additive manufacturing with the polymer 3D printing at our site, so that every trainees had the chance in their training years of 3.5 years to have the hand on the 3D printer for polymers, the MEX printers. And especially the trainees here you have in foundry mechanics have the chance to get the hands on the additive technology for binder jetting, for sand printing, especially here for the patterns, for the casting molds and cores in our foundry. And a few years ago, in 2019, we added the metal 3D printing to this education, so that all trainees have 6 to 12 weeks in their training duration at our Additive Manufacturing Center, and they do a certification for a machine operator in additive manufacturing. So all the special things we have here in additive manufacturing with metal powders in the powder bed fusion process are trained, and they do a special test after this. We introduced this especially here in the foundry mechanics because there is no education planned from the IHK directly for these trainees. And we see that the foundry technology is one field that can be directly enriched with these technologies of additive manufacturing. In general, they get also, especially here for additive manufacturing, the additional modules for environmental health and safety, and get also the insights to the material science behind the additive manufacturing technologies. Yes, at least we finalize this certification with our own KSB certificate for additive manufacturing, and after their training they are allowed to get in our additive manufacturing center afterwards also as machine operators. That's, in short, my introduction for our education.
What you are doing at KSB. Thank you very much for this insight. Maybe if we can switch back to the slide, if it's possible. You wrote down that the duration of the training is 3.5 years. Is that the standard duration?
This is the standard duration in total, yes, for every foundry mechanics. But we enriched it in these standard duration with the additive manufacturing module.
So you added some aspects into the 3.5 years that were formerly used. So it's not necessary to put on more because we have such a complicated issues here. So it really fits well into this normal period of time.
Yes.
Okay, perfect. And I wonder if you have a qualification program for older employees or people who want to change their subject in the company. Is there a program as well?
Yes, we do nearly the same. So when we get an employee as machine operator, they do the same training as our trainees and get also their test and their certification as machine operator before they are allowed to work in our additive manufacturing program.
This morning we had in our morning talk here on stage, had we some discussion about, giving more awareness to the topic of additive manufacturing, and there we talked about sustainability, but I think it's the same when we're talking about new workers, skilled workers, and people who want to, get familiar with additive manufacturing. How is it linked in your company? Is there is a marketing officer part of your team when you're talking about getting people from additive manufacturing to attract to KSB?
Yes, especially we have with our training department, they want also to get more and better qualified trainees there with this implemental of additive manufacturing to the standard processes we have in all the others as
and they talk to you. So they come to you and say, hey, what is the advantage of additive manufacturing? How can we make a better advertisement or something?
Yes.
Okay.
Yeah, especially in the foundry technologies, we have the old job of the foundry mechanism, and we want to add the mindset of additive manufacturing, because in Germany we have not that much foundries that all around the world, especially in Asia, but we're specialized here. And then we also need the specialists in different technologies with the same topic to produce parts, to produce raw parts.
Okay, one last question, because we have to think that we have two other presentations. Yeah. One last thing, we had yesterday again the topic of pumps and the spare part of pumps, and that is very interesting field of applying additive manufacturing parts. Do you work with that as well?
Yes, of course. As we have also the different customers inside KSB, especially our service department for the spare parts, but also for serial parts, and also other customers that come to us with our special certifications we have for pressure equipment as one example. That is not that much on the market.
Do you have off-site customers who may have installed additive printing machine at their production site, maybe a far away oil and gas production or something like that, where you do not deliver your manufactured KSB model, but you deliver the CAD data for printing the part by themselves?
Not at the moment.
Do you plan something like that?
It's every time something that is in plan, but not already in use.
You are discussing that with the financial people, I think.
Yeah.
Okay. Thank you very much, Stefan, for your presentation and the insights. We now switch to Christoph Haug, member of Executive Board of Toolcraft, and we were wondering what you brought with you.
Thanks for having me. So, first of all, Toolcraft, a medium-sized company in the middle of Bavaria. We started our additive manufacturing journey in 2011. Meanwhile, we have 25 people working in our engineering, in our production, and we have 12 powder bed machines, we have 2 LMD machines. And what we address is not just additive manufacturing, but also in a combination with subtractive manufacturing to achieve really high quality parts made of metal. And so we are supplying regulated industries like the aerospace, like the semiconductor, like the defense, like the medical sector. And for this, we need to have robust processes. And to be honest, in 2011, there was a lack of specification, there was a lack of education. And so we need to start also working with the Dean, creating specifications. We're still member of the Dean, so I'm in the Dean Presidium. And for now, also, we're special approved in aerospace by NatCap for this micro welding process. And for this, we need to have experts in our additive manufacturing. And first of all, we have the qualified machine operator. So we train our people who run the machines, and they have to pass an annual test. Otherwise, if they fail, they are not allowed to work with those machines. The next one is the qualified visual inspector, because we got contact, and it was mandatory to have a welding engineer. And at the very beginnings, we had an external welding engineer. Meanwhile, we have an internal qualified welding engineer, and they showed us that also the visual inspection of additive manufactured parts is highly of importance before you go maybe for the post-processing like CNC machining. To speed up also the industrial process of additive manufacturing, together with Friedrich Alexander University of Erlangen and together with the Chamber of Industry and Commerce in Nuremberg, we created 2 training courses or certificate courses for additive manufacturing. One is the industrial specialist additive manufacturing, the operator, and the other one is the designer. And this is really highly of importance because we also have people from other industries in our production, and we want to train them on these training courses, and then of course pay them also more money because they are then skilled and they are the experts. And finally, we created also a virtual training concept, and it was part of a big founded project, national project called IDEA. And so we took some founded money to start with virtual reality training, because it's really important not to train people on stupid 3D printing equipment like a very cheap FDM printer, because this has nothing to do with industrial and robust additive manufacturing. So we really build up a virtual reality process chain, starting with the printing system, going over to the depowdering, vacuum furnaces are included to cut off the parts from the build plate. We have CNC machines, we have tactical and optical measurement machines into this process chain, and people really like it, and people from Toolcraft are also being trained on these virtual but industrial equipment. So, and that's our task we do to our daily business, which is the production, but we see it necessary to leverage the additive manufacturing, not just in Germany, but also Europe and international.
Yeah, perfect. Thank you very much for your presentation. Let's step into the virtual reality training. How close are you to the real process, I wonder? For example, are you using digital twins and something like this?
So we have exactly those machines in the training concept that we have in our real production environment. So for instance, part of this is a TruePrint 5000 system from the supplier Trumpf, a 3 laser unit, and people really wear their virtual reality glasses, and they have really to do some process steps like cleaning the safety glasses with a virtual towel. They also have to clean up the dust like it is in reality, and that's really of important because it does not make sense in our training room to invest in all the hardware because they will not be in production, so it's really wasting money. And this digital twin, and it's really like gaming. It comes out of the gaming, and you feel like
that's one interesting part. It's like gaming, so it's fun to use it.
It's like an adventure game at the end. It's like an adventure game. You can jump through the process chain, and you can. The next step is also to create some. Or to solve problems by solutions. So we have a nice project with the German army. It's a big housing, far too big for additive manufacturing in the powder bed. So you need to think about, oh, I can split it into single parts, and then I can weld it together with LMD technology, and these are the next steps. So we have many, many ideas also to implement our LMD system now, but of course it takes time, costs money to get these digital twin on a really high quality, because it really has to look like reality.
So you are more than one step into a simulation here.
Yeah,
it's a real simulation. So you can. Are you working with these younger guys on improving the processes? Do you give them the tasks? Okay, not just training. Like, you know, it's somebody says that is the perfect process and just train it. Do you give the task? Try to make it better, try to make it faster?
It's our key philosophy. So, of course, I'm head of the company, but I want to
That sounds as we had a chit-chat before, but we didn't have, I'm honest.
I want to have, and 400 employees that we have, I want to have highly motivated people. We fully trust them, so they gave us the motivation. Everybody has to think about daily improvement. So if anybody has an idea, I want him tell it to me, and the perfect solution is that we implement this idea, and then we can say it was his idea. So continuous improvement process, it's a must inside Toolcraft.
Okay, thank you very much for this statement.
Thank you.
Till now, and now we have Gustavo. Gustavo brings in the part of university and young people coming to university and from university. We're curious what you brought with you.
Thank you, Frank. Thank you for the introduction. Just waiting for the slide here. Wonderful. So, good morning, everybody. My name is Gustavo. I'm a project manager at DAP, so the chair for digital additive production at Aachen University. And today, the talk, it's a short talk, 5 minutes. It's the topic, Education 4.0 for Additive Manufacturing. Some other connections here, what Christian Hock already presented, and I would love to discuss afterwards. We talk about as well, it's quite well spread that additive manufacturing capability and know-how is really important for the implementation of additive manufacturing. In this case here, I just point out some challenge that we have for additive manufacturing education. First, as you can see here from this fair, rapid development of additive manufacturing. It's a moving target. So it's really tough to take the education path or in the same pace than the technology involvement itself. Then we have interdisciplinarity as well integrity. So we have knowledge of different areas and domains, but also the understanding the whole process chain of it. We discussed the 4th point, education mismatch. So it means there is a lot of engineers, there's a lot of professionals that are now in the industry, but they have never contact with additive manufacturing before. And last but not least, hands-on knowledge. And then we do see from our studies that it's quite important for the knowledge transfer in the field of additive manufacturing. And then came COVID. And COVID brought some new variables to this equation. Now we have home office and a hybrid way of working. We do have, as we talked before, the acceleration of digital transformation. And last but not least, as Frank mentioned before, we do have this necessity of upskilling, reskilling to tackle the future of work. So the point is how we can navigate here additive manufacturing in this landscape and this scenario. For that, I would like to rephrase the Ministry of Education and Labor, Marianne Thyssen from the European Commission, that we do need to foster and use modern education and content to improve and to keep the pace of this technology development. And for that, it's a perfect hook to the current solution. That's the Education 4.0. In a nutshell, it's education enhanced by technology that could be improved and can support this learning path and keep the trace and keep the pace with the technology development of additive manufacturing. And then we ask about what would be the solutions, and I just brought some demonstration that we did here at Aachen with some partners, as well with Fachhochschule. The first one here used augmented reality to try to exactly change the mindset about how to design for additive, showing the design possibilities within the project item that was led also by BMW. We used some parts, industrial partners, or industrial parts already incorporated in our cards. And then we already tried and run out in our lectures at RWTH University. And they are now planning to apply and use industrial partners as we did in the first round in BMW. Then we have additive manufacturing or augmented reality in virtual realm here with the HoloLens. I come quick back. It's just this visualization of the parts, also to really change the mindset of the designers how to use additive manufacturing in a wise way, in a correct way. And last but not least, we have a VR training that we have developed with a conic machine, part familiarization, machine familiarization, powder handling, and this is quite important here that we discuss health and safety. So now we are putting in a situation and putting in an environment that's virtual, but safe for the trainer as well. And with this last slide, I just want to drop this leading question. Yeah? Have you already imagined to use augmented reality, virtual reality to train your team where and when they need it, and especially in a scalable way? Yeah? I really love to discuss that, either right now with the partners, as well you can come and pass by our booth at ACAM the EHLA Center for Additive Manufacturing, we're also trying out these applications with you. With that, Frank, I'm always open to questions.
Yeah, Gustavo, thank you very much.
You're welcome.
Very insightful. You brought some videos with you. And is it hard to learn these simulation or these what is it called? It's
so which part? There is two there.
Where you have the parts. Where you have to work with this glasses and so on.
Yeah.
I think it's not so easy to manage it, to handle it. Is it?
So the augmented reality itself, the HoloLens.
The HoloLens.
Yeah, exactly. Yeah. The HoloLens is a really good point. It came back from our review session that we did with some experts. Some of them had already tried out before HoloLens and some augmented reality. And from them, the learning curve
reality, that was the word I was looking for, the augmented reality. So I think it's not so easy to handle it when you have that glasses, that HoloLens, and then to work in that's exactly what I mean.
Exactly the point. Yeah.
Is it easy or?
So we have two groups there in our study that we carried out at DAP. One with prior experience, the others with not. And then we do realize that we do need to create some instruction in the beginning. So we do have, in the beginning of the training, that we use here to show, first of all, the theory of design for additive manufacturing, as well the technical and the real use case of the industry. So in the beginning, we create a nutshell or a nugget training so that they can, instruction, we'll say so they can deal and understand how to use the HoloLens. But to be honest, it was more than 10 to 15 minutes, and they already mastered and they could play around.
10 to 15 minutes, that's nothing. That's not a problem. So you don't need weeks to learn it. It's just 10 minutes.
Yeah,
and
exactly.
Then you
just
can
a small instruction, and then it opens a door to a whole new world of education content that we already described here. Yeah.
Okay, and then you can use it anywhere in the world, so you are not bounded. You mentioned it with Corona. You can use it anymore in the world somewhere to educate the people. Well, you mentioned your booth as well. Did you bring students to the exhibition here to have a look at all the things on 3D printing?
We have more than 80 students from Aachen. We just brought them, and thank you also the sponsors that supported. As again, university is quite important, but it's the connection of industry play a key role here. So I do recommend that this connection between industry and university should be fostered, not only from financial, but also that you give us what you need to learn. So then we think about how to teach. Yeah. So this is our role in the university. So that's exactly what I'm looking for here.
Okay, then we do the connection here on the stage. Please come there, then, so that we have a short discussion with all the three of you. We saw now this HoloLens business. Are you using something like this as KSB as well?
We are using this as well, especially in the service department. We have augmented reality or trainings with virtual reality, and especially also in our construction engineering department. They are using these tools too, and especially in our place in Pegnitz, we are the first that do the digitalization projects in the KSB company, and there we have a lot of all these tools that we test. What is the right way for the education of service engineers, of trainees, and so on.
And let me try to bring you guys together. Would that be a cooperation, something that you could offer a guy from KSB machinery or pump production to show him how to enhance his training with your insights?
Totally, we are more than welcome. In our university, we exactly now try to push these new developments that we have developed since 2.5 years to the scenario of industrial environment. So we are more than welcome. I do believe that here today is a platform that KSB as well with Toolcraft here look some points of synergy that we can combine our developments and apply in the industry scenario.
So the one crucial question, I think, is how many open parts, not parts, what is the right word, to attract people? How many open prospects do you have at your company so that you get, I'm lacking the right word. Give me a second.
Vacancies?
Vacancies.
Vacancies?
Thank you very much.
Well.
Vacancies.
Yeah.
How many open vacancies do you have at your company?
I don't know exactly. I would say around 15 at the moment.
15?
So it becomes more and more challenging to get the right people. So it's not just additive manufacturing. So we have some more. So we need to have milling specialists, molding specialists, robotic engineering specialists. So we are not fully covered with all the personnel that we wanted to have.
Because this morning I mentioned to the crowd that there may be some open vacancies, and I wanted to check if I say the right saying here or not.
And this is exactly the strategy we have. So 430 employees, but included in these are 60 young people being trained in different technologies. So this rate is, compared to the others, extremely high. And this is also the strategy for the future, to cover with our own educated people the upcoming growth.
Frank, if I can add up one here regarding to the vacancies. We carried out last year a mapping of 11,000 job vacancies. We created an algorithm to screen all the job positions that we have now in LinkedIn, as well the other job portals, to have exactly that, the snapshot, what do we need from the industry? Because we, at university, we're preparing the knowledge pool for the industry at the end of the day. So we do need to have this snapshot to continuously adapt our content. So then this job vacancies, the job positions could be quicker and skill-oriented, so object-oriented to the companies. So this is something that we do need to work more and more in close collaboration.
And we're also well connected with those guys in Aachen. We are a member of the ACAM, and we already had some students from Aachen or inside Toolcraft to do their master thesis. So this is exactly maybe where also is the potential of a new employee.
Let's step to another topic. What about attracting people from other nations, from other culture to Germany or to Europe? Maybe is it a topic in your companies as well? And must we have some sayings to the politicians here? Or is there something you want to deliver here and then right now?
So we have a partner in Indonesia since more than 20 years. The company is located in Yogyakarta, and we train them as well. And we just finished a master thesis from an Indonesian guy here in Toolcraft, who was studying at the TH Deggendorf. So we are open to this, and I just finished a travel to Saudi Arabia because they also have their strategy 2030, where additive manufacturing plays a major role. And so we are open also to educate people from other countries. And also with this virtual reality training, it's quite easy because you can translate it to all the languages that exist in the world. You can get access from all points of this earth, of this planet. And these are, I would say, big steps.
And does our society needs more, openness to embrace these people, or is it everything running smoothly?
The process of getting those people, so like the official documents and things like this, that could be.
Yeah, it's a part of our process. If I can give a perspective of my experience, since I'm from Brazil originally, and I do believe that's quite important to internationalization. Not only to get, I would say, brains from all outside of the world, but more than technical aspect that they have. They do have the background as well, the network. When I brought here and came to DAP, I have a lot of experience in oil and gas industry, in steel making, and those area I have acquisition, I have projects. So this play a key role. So this I also have in mind for those industries, when they bring someone from other countries, think about also the network and all the strategy, national strategies of those countries, because that's going to play a key role as well in their development and their acquisition of projects in the future.
Yeah, I think that's a very important aspect. So thank you very much. We cannot cover every aspect of this topic, but we have our area here where there is possible to dive a little bit deeper into these topics. Thank you very much. I think you are open for questions or for connection here right now at the booth. Thank you, and have a very successful exhibition today and tomorrow. Thanks.
Yes, well, thank you.
And maybe a short applause for these guys. Yeah, dear audience, let me dive once again into our career consulting here at our booth D70 in hall 11.0. I think that's a good chance for the one or the other looking for an open foreign job, getting the one or the other hint. And if you like, you can have a free job application photo shoot. All this until 4 o'clock in the evening. And so now I'm happy to wish you a very successful third day here at Formnext. And next here on stage we will have a seminar where you can learn a lot of things, the basics in additive manufacturing. It's a Discover3Dprinting seminar right back in some minutes. Stay tuned.
Julian, we're here at Siemens, and in front of us this incredible piece of technology. Explain it to us, how does this all work?
So it's amazing to have you here on the Siemens booth. What you see here is an electronic assembly for iWatch cases. And basically what we are showcasing is how to use additive to improve the efficiency of such a factory in every industry in the world. So we are talking about this part here.
Yes, and we have an approach that we have a digital twin of this whole machine and production line. And with this digital twin we start into NX and start redesigning the part. First of all, we are lightweighting the part up to 60% lighter than it was before. Secondly, we optimize the design. If you just hold it together, maybe we have a topology optimized design, which is also enabling the part to less energy usage in the machine.
So Seren, you spoke about the lightweight quality of the prototype that you have in your hand. Talk about the support structures that you use in this technology.
So support structures are a thing you need for several technologies in additive, but in FDM it's most challenging but also most efficient to use less or no supports, and that's what we realized within this design. So we added chamfers, analyzed the part and its functionality and functional elements, and then realized to support this design even in this hole. You can see like a chamfer here as well, and that is enabling us to print this part without any support.
Thank you, Seren and Julian, for talking to us and for the great demonstration. Have lots of fun in Formnext.
You too.
Thank you. This beautiful dress in front of us. Tell us about it, the technology behind it.
All right, so what we have here is taking the polyjet technology of material jetting and applying it specifically on the fabric, directly on the textile itself. By this, basically allowing the designer to go wide with his dreams, with his designs, doing basically whatever they want.
How would you say does it fare in terms of sustainability? Are 3D printed clothes better for slow fashion?
Yeah, so 3D printing combined with fashion, I think, in my mind, is the next step in terms of sustainability and in terms of environmental friendliness, because this way minimize the production, everything can be localized, so no need to start shipping things all over the world. So yeah, I think that's the next step in sustainability in fashion.
Welcome to Formnext 2022 Expert Insights Discover 3D Printing Seminar. The presentation in cooperation with the Aachen Center of Additive Manufacturing, ACAM, is the starting point of a seminar which will be continued here at the stage area of AM4U stage. And today the lecture will be in German, so if you want to follow in English, here inside and outside at the screens, make sure you attend tomorrow or have a look at our recordings, then you can find the insights. But you just find the first part of the presentation. The second part is just for our audience here at the fair. Ja, wir starten also mit der deutschen Präsentation heute. Lukas Bauch ist unser Experte. Er ist Consultant und eben Experte bei ACAM und wird uns grundlegende Einblicke in die additive Fertigung geben. Falls Sie sich noch kein Headset besorgt haben, wäre jetzt ein guter Zeitpunkt, das zu tun, weil es ein Silent-Seminar ist. Das heißt also, der Ton wird nicht auf in der Atmosphäre übertragen, sondern eben nur über die Headsets. Ja, dann wünsche ich Lukas ein erfolgreiches Seminar und wir sehen uns gleich wieder.
Ja,
die Bühne gehört dir.
Ja, herzlich willkommen zu Discover3Dprinting, unserem Basisseminar für den Einstieg in die additive Fertigung. Das ist also genau gedacht und richtig für Leute, die die ersten Schritte machen in der additive Fertigung, vielleicht auch nur erste Ideen haben und noch gar nicht so involviert wurden, um eben zu helfen, in diese doch recht komplexe Welt einzusteigen. Es gibt viele Technologien, schon viele Anwendungsbeispiele, auch ja, Geschäftsmodelle werden in gewisser Weise verändert. Und ja, wir möchten eben hier innerhalb kurzer Zeit einen recht umfassenden Überblick über viele verschiedene Themen geben, sodass Sie dann auch hier so auf der Formnext einen leichteren Einstieg haben und wissen, wo Sie sich weiter informieren können. Ja, bevor ich einsteige ins Thema, noch kurz eine Vorstellung von mir und dem Aachen Center for Additive Manufacturing. Mein Name ist Lukas Bauch, ich bin Berater am Aachen Center for Additive Manufacturing und forsche außerdem an der RWTH Aachen im Bereich der Produktionsplanung für die additive Fertigung. Ja, das ACAM ist im Endeffekt ein Ort, an dem verschiedene Forschungsinstitute und Unternehmen zusammenkommen in einem Netzwerk, um gemeinsam die additive Fertigung voranzubringen. Also die verschiedenen Themen, Softwareentwicklung, Design, Anlagenherstellung zu vereinen und gemeinsame Projekte zu bearbeiten, um insgesamt ja, die Branche nach vorne zu bringen. In Aachen haben wir bereits schon eine sehr lange Historie in der additiven Fertigung. Das ging schon 1995 los mit dem ersten hybriden Maschinenwerkzeug, das hier ja, hergestellt wurde. 1997 wurde dann das Basispatent für SLM im Campusumfeld ja, eingereicht, der mittlerweile etabliertesten Metall-AM-Technologie im Markt. 2001 ging es dann weiter mit dem ersten ja, Werkzeugeinsatz, 2008 mit einem Implantat und ja, 2015 letztendlich zur Gründung des Aachen Center for Additive Manufacturing. Das heißt, wir haben schon hier eine recht lange Historie, können hier ein breites Netzwerk zusammenbringen, um insgesamt weiter die additive Fertigung voranzutreiben. Das ist auch ein ja, bereits etabliertes Konzept an der RWTH Aachen. Auf der einen Seite die Forschung, viele verschiedene Forscher, die wirklich vertieft in einzelne Themen reinschauen, auch viel Förderung, die wir hier von staatlicher Seite bekommen. Und ja, das heißt, so diese Forschungswelt, die an der Zukunft der additiven Fertigung arbeitet, zusammenzubringen mit der Industrie auf der anderen Seite, denn im Endeffekt wollen wir in der angewandten Forschung auch die Probleme lösen, die es hier in der Industrie gibt. Ja, insgesamt bieten wir also ein Mitgliedsnetzwerk für Unternehmen, aber auch Beratungsdienstleistungen, Entwicklungsdienstleistungen, Schulungsangebote wie heute hier zum Beispiel. Ja. Nach den paar einleitenden Worten zu uns am Aachen Center for Additive Manufacturing steigen wir nun ins Thema ein. Zuerst mit einer Einleitung in den Bereich, dann werde ich einen Überblick über verschiedene Technologien geben, anhand von Anwendungsbeispielen zeigen, wie man dadurch auch Vorteile generieren kann, werde dann aber auch noch auf weitere Unterschiede der additiven Fertigung zur konventionellen Fertigung eingehen, die man berücksichtigen sollte, wenn man die additive Fertigung selbst nutzen will, und weiterhin noch einen Ausblick in die Zukunft geben, an der wir erforschen. Gut, ich steige ein mit erstmal Definitionen. Was ist denn überhaupt die additive Fertigung? Da kann man in verschiedene Normen schauen. Additive Fertigung ist ja so der industriell, wissenschaftlich auch korrekte Begriff für 3D-Druck. Und das ist definiert als Prozess, in dem schichtweise oder elementweise Material verbunden wird, um so eine Geometrie aufzubauen. Und dadurch unterscheidet sie sich ja auch von der subtraktiven und der formativen Fertigung. Nun ist es aber so, dass es nicht den einen Fertigungsprozess gibt der additiven Fertigung, sondern viele verschiedene. Das sehen Sie hier beispielhaft dargestellt in den Bildern. Es gibt verschiedene Wirkprinzipien. Kunststoff wird durch eine Düse extrudiert, wie man es auch schon aus dem Heimgebrauch kennt. Fotosensitive Polymere werden ausgehärtet. Pulver wird durch einen Laser aufgeschmolzen in einem Pulverbett oder auch durch eine Düse aufgetragen. Das heißt, es gibt hier sehr, sehr viele verschiedene Technologien mit unterschiedlichen Wirkprinzipien, und je nachdem, vor welchem Problem man steht, vor welcher Anwendung, benötigt man eine andere Technologie mit anderen Vor- und Nachteilen. Ja, die additive Fertigung ist nun in vielen Dingen sehr unterschiedlich zu den konventionellen Fertigungsverfahren. Während in der subtraktiven Fertigung Werkstoff abgetragen wird oder in der formativen Fertigung Werkstoff umgeformt wird, ist es in der additiven Fertigung eben so, dass Werkstoff miteinander verbunden wird, um ein gewünschtes Bauteil zu erhalten. Und ja, auch ein häufiges Thema in der Welt der additiven Fertigung war in der Vergangenheit das Hype-Thema. Also ist es ein Hype, der viel verspricht, oder ist es jetzt die Revolution, die alle andere Fertigungstechnologien vertreibt? Die Wahrheit liegt dazwischen. Also wenn man sich hier mal ansieht, hier ist aufgetragen das relative Interesse an den Suchbegriffen 3D-Printing und Additive Manufacturing über der Zeit von 2010 bis 2021. Und man sieht, dass insbesondere hier 2012, 2013 die Suchanfragen sehr stark angestiegen sind, vor allem im Bereich 3D-Druck, was ja im Heimgebrauch auch so der geläufigere Begriff ist. Und das war so hauptsächlich auch so die Zeit, in der die Technologie sehr gehypt wurde und auch Barack Obama ja das in seiner State of the Union adressiert hat. Aber im Endeffekt ist es so, dass die additive Fertigung eben sehr unterschiedlich ist zur konventionellen Fertigung und man aufgrund dieser Unterschiede einige Probleme viel besser umsetzen kann als mit der konventionellen Fertigung. Aber es ist mehr eine Ergänzung als jetzt ein Ersatz, der alles andere vertreiben wird. Hier ein Überblick über die Marktentwicklung in den letzten Jahren und auch eine Prognose in die Zukunft laut verschiedenen Marktforschungsinstituten, die hier ihre Reports veröffentlichen. Sie sind hier aufgetragen, die Marktgröße in Milliarden US-Dollar, und für die Zukunft sind hier verschiedene Prognosen angetragen. Man sieht, die haben alle gemeinsam, dass sie sagen, der Markt wächst, aber es ist doch recht unterschiedlich, wie stark das die prognostizieren, dass der Markt wächst. Und das kommt auch ein Stück weit aus unserer Sicht dadurch, dass eben der Markt sich noch entwickelt, er im Vergleich zur konventionellen Fertigung noch relativ jung ist. Hier gibt es noch viele radikale Innovationen, viele Themen, die neu aufkommen, und je nachdem, wie man diese einstuft, kommt man auch zu anderen Einschätzungen zum Marktwachstum. Hier ein weiterer Überblick, wie der Markt in der additiven Fertigung so gestaltet ist. Hier wurden viele Unternehmen befragt, also Service Provider aus dem Bereich AM, Anlagenhersteller und auch Werkstofflieferanten, mit welchen Branchen sie ihren Umsatz zu welchem Anteil machen. Hier liegen laut dieser Umfrage Automotive und Aerospace vorne mit 16%, aber auch schon dicht gefolgt dann in der Forschung. Das heißt, das Thema ist auch noch ein sehr großes und wichtiges Thema in der Forschung, der Medizin- und Dentaltechnik, in den Consumer-Produkten und Electronics und weiteren Branchen, auch im Militär, in Power and Energy ist die additive Fertigung im Einsatz und hat hier ihre Marktberechtigung. Nun möchte ich vorstellen, wie im Großen und Ganzen so der übergeordnete Prozess abläuft, auch wenn der dann in Teilen wieder unterschiedlich ist pro Technologie. Aber man kann zusammenfassen, dass es erstmal losgeht mit einem Pre-Process. in dem Dinge vorbereitet werden, dann kommt der In-Process, in dem der eigentliche Druck stattfindet und dann noch das Post-Processing. Und beide finden auf einer physikalischen und einer digitalen Ebene statt. Das heißt, in der Vorbereitung auf der physischen Seite muss natürlich erstmal die Anlage vorbereitet werden, verschiedene Dinge je nach Technologie müssen bereitgestellt werden, der Werkstoff. Und auf der digitalen Seite muss erstmal der digitale Bauplan erstellt werden. Das heißt, die Baujobs müssen digital vorbereitet werden. Da gibt es auch sehr viele verschiedene Dinge, die man berücksichtigen muss, auch um die richtige Qualität und ja, auch die Kosten zu beeinflussen. Und auch die Produktionsplanung muss gemacht werden, was gerade, wenn man in so einer flexiblen Nische unterwegs ist mit der additiven Fertigung, oft mal gar nicht so einfach ist, mit sehr vielen verschiedenen Produkten in kleinen Stückzahlen. Ja, danach kann es dann losgehen mit dem eigentlichen Druck. Das heißt, physisch wird die Geometrie generiert und digital können wir hier viel während des Prozesses auch durch Sensorik aufnehmen, zum Beispiel durch Kameras, durch Vibrationssensoren, je nach Technologie und können dann diese Daten nutzen und auswerten, um die Qualität zu verbessern oder auch Qualitätsmängel festzustellen und dann vielleicht auch den Druck vorzeitig zu starten oder Gegenmaßnahmen zu treffen. Dann ist es ja in sehr vielen Fällen so, dass nach dem Druck ein Bauteil im S-Bildzustand ist, so bezeichnet man den Zustand nach dem Druck und dann müssen noch weitere Bearbeitungen durchgeführt werden, um die eigentlichen Eigenschaften der N-Anwendung zu erfüllen. Manche Technologien benötigen Supportstrukturen, auf denen die generiert werden, die muss man entfernen. Dann kann man Wärmebehandlungen durchführen, Oberflächenbearbeitungen, um eben ja, die Eigenschaften so zu beeinflussen, wie man die gerne haben möchte. Und auch im Post-Prozess spielen Daten eine wichtige Rolle, in der Produktionsplanung und Steuerung, auch in der Qualitätssicherung. Und wenn man diese Daten aufnimmt, kann man dann eben später im Nachhinein auch daraus lernen und langfristig die Produktion verbessern, dadurch, dass es ein sehr digital getriebener Prozess ist. Gut, kommen wir mal zu den Kerneigenschaften der additiven Fertigung, aus denen wir dann verschiedene Vor- und Nachteile ableiten können. Additiv habe ich bereits erklärt. Nun ist es auch so, dass die additive Fertigung oft als werkzeuglose Fertigung bezeichnet wird. Damit meint man im Eigentlichen, dass es keine Abhängigkeit der Werkstückgeometrie von einem Werkzeug gibt. Das heißt, man kann flexibel den Bauplan ändern und kann dann wieder ein neues Design drucken. Und das heißt, man ist flexibler und kann auch komplexere Designs umsetzen, da man weniger Fertigungsrestriktionen berücksichtigen muss. Die Technologien sind sehr digital. Man generiert einen 3D-Bauplan und kann dann darauf drucken, muss nicht noch viele weitere sehr komplexe Vorbereitungsschritte hier durchführen und kann auch im ganzen Prozess die Daten sammeln und für Verbesserungen nutzen. Es ist aber auch so, dass die Technologien teils sehr komplex sind. Es gibt viele verschiedene Wirkprinzipien. Das Design ist sehr wichtig, die Werkstofftechnik dahinter, auch wie man die Produktion tatsächlich sinnvoll plant. Und ja, das ist auch noch so eine Eigenschaft der additiven Fertigung, dass man diese Flexibilität, wenn man die nutzen will, auch irgendwie beherrschen muss. Daraus können wir dann verschiedene Vor- und Nachteile ableiten. Sehr, sehr wichtig natürlich, ich habe es kurz schon angesprochen, die Designfreiheit. Man kann sehr komplexe Geometrien fertigen, man kann Leichtbaugeometrie fertigen und auch ja, monolithische Designs. Das meint, dass man hier durch weniger Restriktionen durch die Fertigung sehr komplexe Designs in einen Bauteil integrieren kann und jetzt nicht das Bauteil in verschiedene Teile aufteilen muss und dann im Nachgang noch montieren und fügen muss. Ja, wenn man auch kein Werkzeug anpassen muss, ist es einfacher, flexibel Iterationen zu fahren, verschiedene Prototypen zu fertigen, auch ja, technische Änderungen durchführen zu können. Das hat das Potenzial, dann auch den Produktentwicklungsprozess zu beschleunigen, schneller am Markt zu sein mit neuen Ideen. Die Designfreiheit erlaubt es auch, Funktionen zu integrieren, Kühlkanäle, Dämpfungsfunktionen, gewisse Oberflächenstrukturierungen. Das heißt, hier kann man auch zusätzliche Vorteile erzielen. Dadurch, dass man jetzt weniger von Skaleneffekten abhängig ist, es gibt zwar welche, aber die sind doch oft sehr viel geringer als in der konventionellen Fertigung, auch getrieben dadurch, dass man nicht immer neue Werkzeuge erstellen muss und hier aufwendig planen muss, kann man sehr wirtschaftlich kleine Stückzahlen fertigen, sogar individualisierte Bauteile, Dinge einscannen, drucken, individualisieren. Das heißt, hier hat man einfach auch Vorteile. Weiterhin kommt man dadurch sehr schnell von einer Idee zum tatsächlichen Produkt. Auf der anderen Seite haben wir aber bei den Nachteilen stehen, dass viele der Prozesse sehr lange Druckdauern haben. Das heißt, hier ist ein gewisser Zielkonflikt, getrieben von der Stückzahl und auch dem Volumen, das verarbeitet wird. Also wenn Sie sich jetzt vorstellen, Sie bewerten Spritzguss gegen eine kunststoffadditive Fertigung, mag sein, dass Sie durch additive Fertigung sehr viel schneller die ersten Bauteile erhalten, aber wenn die Stückzahlen sehr hoch sind und das in die Massenfertigung gehen, dann ist einfach die Zykluszeit im Spritzguss geringer als der Druck mit der additiven Fertigung für viele Anwendungen. Das heißt, hier hat man diesen Zielkonflikt, in dem man irgendwie entscheiden muss, was ist dann das Beste für den Anwendungsfall. Ja, weiter mit den Vorteilen, bevor ich dann noch weiter auch auf die Barrieren eingehe. Die Lieferketten sind kürzer. Man kann direkt, wenn man den Werkstoff vorrätig hat, fertigen und es entfallen einfach viele Zwischenschritte, viele Fertigungsstufen und dadurch resultieren dann auch in der Praxis oft kürzere Supply Chains. Es macht auch, diese hohe Automatisierungsgrad des Drucks macht es auch anreizend, sich die Fertigung wieder intern inzusourcen und hier die Automatisierung zu nutzen. Weiterhin ist die additive Fertigung, die bietet viele Vorteile auch in der Nachhaltigkeit, wenn man sie korrekt einsetzt. Hier sind insbesondere aus unserer Erfahrung wichtig, dass man Werkstoff einspart. Das heißt, wenn man jetzt nur das konventionelle Design nimmt und druckt, ist es nicht unbedingt so, dass man hier dann Vorteile hat, aber wenn man viel Werkstoff einsparen kann durch die Designfreiheit, ist auch die Nachhaltigkeit besser. Das heißt, das ist so auf der vorgelagerten Produktionsseite in der Werkstoffherstellung, aber auch im Betrieb kann es ökologisch Sinn machen, additive Fertigung zu nutzen, durch längere Lebenszeit, durch Leichtbau oder einfach eine bessere Funktion, die dann im Betrieb zu Einsparungen führt. Auf der Barrierenseite stehen jetzt hier noch die fast fehlenden Skaleneffekte. Das heißt, wenn man bei kleinen Stückzahlen hier die Vorteile hat, ist das bei der großen Stückzahl ein Nachteil. Die Bauteilqualität ist nach dem Druck oft noch nicht so, wie man sie im Einsatz gerne hätte. Bei vielen Verfahren hat man recht raue Oberflächen. Ist nicht bei allen so, aber die müssen dann teilweise nachbearbeitet werden durch verschiedene Post-Processing-Technologien. Auch während man sehr gut geometrische Details umsetzen kann, ist es dann trotzdem so, dass man die geometrischen Toleranzen gut im Griff haben muss bei vielen Prozessen und da den Prozess richtig einstellen muss, um auch die geometrischen Toleranzen gut hinzubekommen. Weiterhin, das folgt so auch aus der Komplexität, wenn man die Vorteile nutzen will, braucht es erstmal ein anderes Mindset, wie man die Technologie nutzt, andere Fähigkeiten im Design, in der Produktionsplanung, die man berücksichtigen muss, um tatsächlich die Vorteile auch nutzen zu können. Die Qualitätssicherung kann teilweise recht komplex sein mit vielen Technologien und die Zertifizierung. Hier macht man auch derzeit schon große Fortschritte, aber je nach Branche ist das, wie wir feststellen, oft mal noch ein Hindernis, um tatsächlich dann auch in die Anwendung zu kommen. Als letzter Punkt hier zu nennen sind auch die Anforderungen an die Gesundheit und Sicherheit in der Nutzung der additiven Fertigung. Hier gibt es Maßnahmen, die, wenn man die sicher ergreift, dann ist das kein Problem. Aber wenn man mit feinem Metallpulver arbeitet, natürlich Atemschutz, die richtige Schutzausrüstung. Das heißt, auch hier im Fertigungsumfeld muss man die richtigen Feuerlöscher und alles berücksichtigen, aber dann ist das eigentlich kein Problem. Und diese ganzen Vorteile sind jetzt möglichst übergeordnet dargestellt, aber wenn man dann in die einzelnen Technologien reinschaut, gibt es dann doch da wieder Unterschiede, die man berücksichtigen muss. Deswegen gehe ich nun noch weiter auf einen Überblick über die verschiedenen Technologien ein. Zu Beginn mit den Technologien im Bereich Metall, hier eingeteilt nach verschiedenen Wirkprinzipien. Das erste hier links dargestellt ist Powder Bed Fusion, Pulverbettprozesse, die schichtweise Pulver auftragen, dann selektiv dort Pulver verschmolzen wird, wo es eben zu einer Geometrie werden soll, basierend auf einem Bauplan, dann kommt die nächste Schicht drüber, die nächste Schicht und so wird das eben nach oben aufgebaut. Und hier arbeitet man bei den industriell bislang relevantesten Verfahren mit Lasern oder Elektronenstrahlen. Dann gibt es noch das Wirkprinzip Direct Energy Deposition, hier mit LMD, zu Deutsch auch Laserauftragsschweißen und dem extremen Hochgeschwindigkeitslaserauftragsschweißen. Wo dann die Unterschiede liegen, werden wir später noch sehen, wenn wir mehr ins Detail gehen. Aber bei beiden Technologien wird Metallpulver durch eine Düse geführt, durch einen Inertgasstrom und dann durch einen Laser aufgeschmolzen. Die Verfahren gibt es auch mit Draht und ja, dann abgelegt. Man hat hier also nicht das Pulverbett, sondern eher so eine selektive Ablage von Werkstoff und im Verschmelzen. Dann gibt es noch ein Verfahren, das Wire Arc Additive Manufacturing, das das Prinzip des Lichtbogenschweißens verwendet. Binder-Jetting ist hier auch sehr interessant. Das funktioniert auch mit einem Pulverbett. Nur nutzt man nicht einen Laser oder Elektronenstrahl, um das Pulver zu verschmelzen, sondern tropft da erstmal Kleber drauf, wie eine Art Tinte. Das heißt, so einen Binding Agent, der dann durch Bestrahlung mit Licht aushärtet. Und dann erhält man nach dem Druck ein noch recht fragiles Bauteil. Und dann sind noch weitere Prozessschritte notwendig. Der Kleber muss da ausgetrieben werden und das Bauteil auch nachsintern, um ein dichtes Bauteil zu erhalten. Im Material Jetting werden Nanopartikel aufgetropft in einer Art wie eine Tinte und dann ausgehärtet. Und hier kann man eben auch dreidimensional Geometrien aufbauen. Ich werde nun auf einige Technologien weiter eingehen und zeigen, wie die funktionieren. Zu Beginn mit dem Laser Powder Bed Fusion of Metal. Zu Beginn hat man ein digitales Modell, den Ausgangswerkstoff, ein Metallpulver und kann dann den Druck starten. Und hier wird dann zuerst eine dünne Schicht Metallpulver aufgetragen durch einen Beschichter. Hier sieht man es im Video. Danach wird durch einen Laser abgescannt. Die Bauteilgeometrie wird also verschmolzen, wo sie entstehen soll. Dann kommt die nächste Schicht oben drauf und Schicht für Schicht wird das Bauteil aufgebaut. Das Verfahren benötigt Supportstrukturen, da sehr viel Hitze eingetragen wird. Es kommt zu schnellen Aufheiz- und Abkühlvorgängen. Das führt zu Eigenspannungen im Material. Und um hier die Hitze besser ableiten zu können, baut man Bauteile auf Supportstrukturen auf. Die führen dann die Wärme besser in die Bauplatte darunter ab und halten das Bauteil auch mehr in Form. Und diese Supportstrukturen muss man dann im Nachgang wieder entfernen. Verarbeitbar sind hier schon sehr viele schweißbare Werkstoffe, die dafür qualifiziert sind. Stähle, Nickel-Basis-Legierungen, Kobalt-Chrom-Legierungen, Kupfer- und Legierungen, Titan und vieles weitere. Das ist auch eine schöne Spielwiese für uns als Forscher, hier neue Werkstoffe zu entwickeln. Und mittlerweile gibt es hier schon für diese Technologie eine weite Bandbreite, auf die man zurückgreifen kann. Ja, nun zum Laser Metal Deposition, dem Laserauftragsschweißen. Hier arbeitet man nicht mit einem Pulverbett, sondern das Pulver wird durch eine Düse zugeführt, durch einen Inertgasstrom, also ein Schutzgas, und durch den Laser aufgeschmolzen. Hier bei dem Verfahren ist es so, dass das meiste der Energie dann ins Substrat geht und hier eine Schicht aufschmilzt. Man sieht das hier im Video. Dadurch, dass es jetzt kein Pulverbett ist, kann man auch Schichten auf bestehende Bauteile auftragen und diese dann reparieren, wie man auch hier im Video sieht. Ja, dann gibt es noch das extreme Hochgeschwindigkeitslaserauftragsschweißen. Hier ist der generelle Unterschied, dass der Pulverstrom schon weiter oben zusammengeführt wird und dadurch der Energieeintrag mehr ins Pulver stattfindet. Man erreicht dünnere Schichten, schnellere Aufbauraten und hauptsächlich wird das bisher, wie man dann hier im Video sieht, für rotationssymmetrische Bauteile zur Beschichtung genutzt. Es gibt aber auch schon erste Ansätze, wie man Bauteile so schnell und präzise bewegen kann, sodass man die hohen Beschichtungsgeschwindigkeiten auch dreidimensional nutzen kann. Das sehen wir dann später noch im Ausblick in die Zukunft. Eine weitere sehr interessante Technologie im Bereich Metall-AM ist das Binder-Jetting. Wieder ähnlich einem Pulverbettprozess wird Metallpulver in Schichten aufgetragen und hier durch dann einen Druckkopf mit Kleber beträufelt, so dass es dann mit einer Bestrahlung auch zu einer gewissen Verbindung schon kommt. Und der Vorteil ist hier, dass man in der Regel keine Stützstrukturen benötigt und dadurch auch dreidimensional diesen Baujob nesten kann. Also mit Nesting ist immer gemeint, wo ordnet man welche Bauteile wo an im Baujob und kann dann hier sehr viel höher auch mehr Bauteile einbringen und auch das Zusammenfügen funktioniert schneller, als es jetzt mit so einem Laser abzuscannen. Das heißt, mit der Technologie erhofft man sich auch eine höhere Produktivität. Sie ist allerdings industriell noch nicht so etabliert wie jetzt Laser Powder Bed Fusion und man benötigt im Nachhinein noch diese zusätzlichen Prozessschritte, in denen der Kleber ausgetrieben wird und das Bauteil auch versintert wird und man muss auch dieses Sinterschrumpf vorher schon im Design berücksichtigen. Das ist auch noch eine Herausforderung. Wie angesprochen, können wir mit den verschiedenen Metall-AM-Verfahren schon sehr viele Werkstoffe verarbeiten. Nickel-Basis-Legierungen, die hochkorrosionsresistent sind, auch hohe mechanische Belastung aushalten können. Kobalt-Legierungen, Titan-Legierungen, Aluminium-Legierungen, die vor allem im Leichtbau sehr relevant sind. Und ja, Werkzeugstähle, Kupferlegierungen. Ja, man kann hier also schon auf viele Werkstoffe zurückgreifen und den Werkstoff auch wählen, der für die eigene Anwendung am besten geeignet ist. Sogar auch Gold und edle Werkstoffe werden schon eingesetzt, auch in der Schmuckindustrie. Gut, nun kommen wir auch zu den Polymer-Technologien. Da gibt es jetzt wieder verschiedene Wirkprinzipien, wieder auch die Pulverbettverfahren. Hier zu nennen das selektive Lasersintern und Multijet Fusion. Das selektive Lasersintern ist sehr ähnlich dem Laser Powder Bed Fusion auf der Metallseite. Nur, dass es jetzt eben Kunststoffpulver ist, man auch andere Anforderungen an den Prozess hat, andere Temperaturen, aber im Prinzip funktioniert das genauso. Im Multijet Fusion werden Agents aufgetropft. Das sind also wieder Flüssigkeiten und dort, wo die Flüssigkeit landet, die Infrarotstrahlung sehr gut absorbiert, härtet das Bauteil ab. Und dort, wo die andere Flüssigkeit für die feinen Details ist, wird das eher reflektiert und hier entsteht dann kein Bauteil. Wir haben dann noch weitere Technologien wie die Materialextrusion. Man kennt es auch schon aus dem Heim- und Hobbygebrauch, eventuell diese Drucker, die man schon sehr günstig auch selbst erhalten kann und dann ein Kunststofffilament nutzen kann, um ein Bauteil aufzubauen. Die gibt es aber auch etwas sage ich mal, im höherpreisigen Bereich für die Industrie, auch sehr große Drucker, die das schon können, auch welche, die mittlerweile mit Granulat arbeiten, also einen anderen Ausgangswerkstoff nutzen. Dann haben wir noch Material Jetting. Hier wird UV-Licht und auch ein Photopolymer und Tinte verwendet, um Geometrie selektiv auszuhärten. Und es gibt noch die Photopolymerisationsverfahren, bei denen flüssige Kunststoffe durch einen Laser oder auch einen Projektor ausgehärtet werden. Ja, soweit als Überblick über die verschiedenen Verfahren. Hier vor Ort werden wir gleich noch weiter auch auf die Kunststoffverfahren eingehen und wenn Sie auch noch mehr darüber lernen möchten, über Anwendungsbeispiele, Vorteile, Geschäftsmodelle und die Zukunft, kommen Sie gerne morgen nochmal vorbei und verfolgen Sie den Vortrag bei meiner Kollegin auf Englisch. Gut.
Ja, Lukas, vielen Dank also für diese Einsichten und für die Informationen. Es ist schon wahnsinnig, wie vielfältig auch die additive Fertigung ist und welche Methodik sich dann eben entsprechend durchsetzt, beziehungsweise welche Methodik sich eben für welches Produkt oder für welches Ziel eben am besten auch eignet. Ja, meine sehr verehrten Damen und Herren, während der Livestream hier bis 14 Uhr jetzt pausieren wird der zweite Teil von Lukas' Präsentation im Saal fortgesetzt. Und liebe Zuschauer draußen an den Bildschirmen, wir sehen uns also um 14 Uhr pünktlich wieder und dann wird Steffen Ritter seinen AM Field Guide zeigen und erklären. Und ich denke, da sind so die ein oder anderen Bilder, die wir hier gesehen haben, könnten wir da vielleicht wiederfinden. Also, wir sehen uns pünktlich um 2 Uhr wieder. Vielen Dank.
like a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.
Welcome back, ladies and gentlemen, to the afternoon program here at the AM4U stage at our third day of Formnext 2022. We talked a lot again at this Formnext about market access, innovations, demands for applications in the industry, but also about skill shortages and education. What we certainly need is kind of an overview, an introduction to the topic, but in a way that addresses a target group as large as possible. And the good thing is we have something like that, and the following speaker will introduce you to the whole topic. The AM Field Guide is one of my most important publications and provides an excellent introduction and overview of additive manufacturing and its processes. Join me on stage welcoming Professor Dr. Stefan Ritter from Reutlingen University, who will tell us all about this fantastic publication. Stefan, it's so good to have you back again. I leave the stage to you.
Thank you very much for this very kind introduction, AM Field Guide. I need to tell you a story. Some years ago, the Formnext team, and this was actually the time when the trade show was still kind of not so professional like it looks today. And the team came to me and said, hey, do you have an idea which can contribute to the field of AM? Could we do something? And I said, hey, I have an initial idea. Sometimes I have no clue what we're talking about. The machines all look the same. Sorry for some of the machine manufacturers here, but hey, these are boxes actually, mainly, yeah. They have a build room for the AM build process, then they have a control unit, and actually it's very important to think about the method, the building method behind it, and to understand it. There is not this one and only additive manufacturing or 3D printing system. There are lots and tons of different variants, systems, and that need to be understood. So I developed those very, and I would say reduced to the max graphics, and this is what I would like to introduce to you, and this is actually at the very end what you have also in your hand to give you a basic introduction into the thrilling field, and I hope you join and you feel the same way, that this is a super interesting field we are entering here at this trade show at the Formnext. So let's step back some years ago, and actually it's many 10 years ago when the real 3D printing hype began. I'm doing 3D printing since the early 90s, so from the very early days on, it was called rapid prototyping at that time. And of course we used 3D printing, 3D-Druck, something like that. But then for a very long time, it was kind of a very professional thing, mainly for product development. And in the years 2012, it really started booming. Why? Because some patents ran out, and so the maker scene discovered this, and this brought an immense push into the whole system, and unfortunately, and there are always pros and cons about this, with a lot of with too much expectation in that. Look at those headlines: the future of medicine, the new industrial revolution. Looking at this, there was too much over expectation. And Gartner the Gartner hype cycle. Gartner is a consulting agency from the US, and they are looking at new technologies, and actually there is always this innovation trigger in the very early beginning. There is this peak of inflated expectation. Then there is the valley of disillusionment, which this technology ran through, and then hopefully the slope of enlightenment. And it works a little bit like this. And some of these things which popped up in 3D printing never made its way back all the way to the peak of productivity. And others, like in dental industry, hundreds of thousands or millions of parts are nowadays produced. So you really need to understand, what are we talking about? And I will definitely warn you, just seeing parts doesn't mean that those parts are fully functional. Sometimes these are just models. Do they last long enough? I see lots of turbine blade things, high-tech stuff. Does it really work? Yes, some of them really work, and some others just look like turbine blades and are good models for that. So be careful looking at examples. Always ask the right question. This is very important when you enter this field. These are the Google search queries from the past 10 years, and look at this. It proves that in the year 2012 it became a dramatic push, this scene, 3D printing, and since then, obviously, it's really established additive manufacturing as kind of the professional expression for 3D printing. It is way lower, so there is no clear. In the common sense, there is no clear distinction. This means this and that means that. 3D printing or additive manufacturing, most of the time they are used in the same manner. Looking at the fields of application, when should I ask for additive manufacturing? What should trigger me with respect to, should I think about additive manufacturing or not? And I spotted 6 fields which are trigger fields for that additive manufacturing is worth thinking about it, actually. One of the most important ones, and I named it before, is prototyping. It started out as rapid prototyping, yeah? Rapid with respect, actually, to the old way of creating prototypes. So it was way faster at that time. I'm an engineer, and sometimes it's still too slow, and we always should speed it up. And still, a lot of applications are running in that field. So approximately 50%, it depends really on in which field you're looking at, but 50% of 3D printing is used, 3D prints are used in the field of product development, yeah, creating prototypes, creating first functional prototypes in a very fast way, creating prototypes. Here, an example of medical application. So medical instruments are really made for the surgeon hand, and so they are printed in non-steel here in plastic. Yeah, they can do handling tests, and then they say, okay, yeah, it's okay, and then it's produced in a stainless steel way or something like that. Yeah. Then actually one of the more fascinating things is, and you see some of those printing methods have the ability to print in real color. On the right side, this model is absolutely stunning, and there is no other method you can create something like that. Yeah? On the left side, so this is for educational purposes, for example. Yeah? On the left side, you see a blood vessel system. And this is a project which was done in Chicago, and coming out of computer tomography data, the surgeons can create something like that, and so they can make their discussions about how do we do the surgery and so on. They can do it with a real model in their hand and try to optimize let's say minimal invasive techniques or something like that. Model making as a special part of, let's say, prototyping, okay? Hey, then of course, the small batch production. And to be honest, yeah, looking at some of the applications here on the trade show, hey, small batches run from 2 to, I don't know, 20,000, 30,000. These are still kind of small batches. If the parts are small, this can be super efficient 3D printing. And hey, nowadays you can do calculations. You can ask the right partners, give me an offer. I need 200 parts in very early beginning of my production. How much does it cost? You can compare it with other methods. This is state of the art and very well known so far. Yeah. Number 4, if the quantity goes down to a single part, we're talking about individualization. And here, as an example, it is absolutely fascinating what can be done. And before I said, hey, please don't have any over expectations. In dental industry, for example, it was kind of a revolution, and it changed a lot, yeah? Because here we are talking about customization, yeah? Each of us has different teeth, of course, yeah? And so for teeth correction methods, this is used in an absolute standard way nowadays. So everything which need to build in an individual way, this is perfect, and hundreds of thousands of parts are produced and millions of parts are produced each and every year, referring to that field of application. The nicest part of it, and I'm a mechanical engineer and I'm always fascinating about getting new possibilities of product creation into my hands. Yeah? Who can drill a hole around a corner? Nobody. Yeah, that's not right. Yeah? Oil exploration, they can drill in large scales, they can drill holes around corners, but not in our major industries here for when we're talking about smaller parts. So how are those channels for cooling applications, for example, are created? Yeah? With additive manufacturing. Yeah? And freedom of design means we can create geometries which are impossible to be created with any other technology, with any other techniques known so far. And this is really, really interesting. You see on the lower side, the blue part, this is a metal. On the top side, these are two metal applications. On the lower one, this is a lightweight construction, bionicle design principles, which means, or biomimicry, how it's called in English, and super lightweight construction, which can't be produced with any other method in a economical way. Last but not least, as a field of application, I called it the in situ manufacturing. I want a production machine here and now. I'm here on a very remote place, here the stage, so far away from any other production site. So this is what the intention is. As the example, this is the space station, and they need to be prepared for different health issues, but they can't take all the equipment with them. And so the NASA really worked out a program where they print out those things they need for these cases here. You see instruments, medical instruments, and they are printed out. The base of it is a special filament which kills bacteria, but these are some specialties, and it's easy to understand. Yeah. But we don't need to travel into space. If we are developing something top secret, which should not be leaked somehow out, yeah. And I have a development department behind closed doors. Sometimes it's also the same case that this we need in situ manufacturing site over there, just right away. And most of the time, the most interesting applications are mixtures of those. Low quantities, I would like to have it in a fast way, prototyping. So mixtures of these create even more and make more sense to apply additive manufacturing. So if one of those 6 cases and application fields make a click into your head, then you should think about additive manufacturing. There is not this one and only additive manufacturing method. Yeah? And it is confusing. I said it in the very early beginning, because the machines seem to look like the same. They have housings, they have these control units, and you need to understand, hey, what's behind it? And as an example, here we see the plastic, the main plastic methods, manufacturing methods. There are way more, but they are, let's say, these are the most common one. According to Pareto, this is the 80-20. Here we are covering more than 99% of the market. Yeah. Some of those are powder bed based. Yeah. So the material is put into the machine as a powder. Some others, it's a solid material, and we either have filament, which is a string, or granulate, which are small grains, yeah? Or it is liquid, yeah? The three right applications and methods are based on liquid plastic. Some of them are able to print in color, like you see here, the multi-jet fusion on the left side, or the material jetting on the more right side over there. You saw the example before, this semi-transparent figurine of a human body. This is produced with such a material jetting machine, actually, process. Yeah? So, and you need to decide, hey, what do I need? What properties do I want to have in my product at the very end? Yeah? Is it a metal part, or could it be also okay if I'm printing a plastic part? Because, hey, the properties are completely different, and hey, metal melts at 1,200 degrees, something like this, depending on the metal. Plastic melts start melting at 220 degrees, so there is a big difference, and this is also the price difference in the machines. Yeah, it is way more complex to create metal machines. I don't say it's easy to create good plastic machines. Don't misunderstand me, but the specification with respect to temperature and with respect to all the thing which need to be taken into account is way higher, and that's the reason why metal printing is in general more expensive than plastic printing. And here you see on the left side these 5 printing methods. They can create in a direct way metal parts. So at the end you have a metal part in your hand, whereas those on the right side, the 3 on the right side, they create a so-called green part. So this is not a metal part, a finished metal part. This is a process in between, and this green part need to be sintered in the next step, and then after the sintering process we have our metal part in our hand. And last but not least, and I just can give you this basic introduction, you need to refer to the field guide to discover those techniques by yourself. Yeah? And in last but not least, these are what we call the other materials, because metal and plastic play the most important role. That does not mean that the ceramics are not, and the other printers are something second class or something like that. Yeah? Here we have stunning applications. You heard probably about printing houses. I mean, this is nothing more than this paste extrusion modeling. Yeah? You have a pasty structure, and you print it out X, Y, Z, and then you create objects. Yeah, it's no matter if it's icing, if it's a chocolate printer, if it's food printers. Most of them are just, the principle is paste extrusion modeling, house printers, and so on. So a lot of printers and printing methods are covered by the paste extrusion, by the process of paste extrusion modeling. Yeah. Also, binder jetting with sand and gypsum are used to print cores for the casting industry, for example. Very successful, very accurate. Nowadays, it's absolutely state-of-the-art production technique. Understanding additive manufacturing means that there is not this single 3D printing process or this 3D printing machine. And you throw some data in and the object comes out. It's a process. And we have to understand that pre-processing, the main AM production phase and post-processing are also very important phases which we need to know. And sometimes they are way more complex than the process itself, the 3D printing process itself. And the mystery about controlling this process lays more in the post-processing process than actually in the initial 3D printing process. Let's look at what those processes means. Pre-processing means actually we should design products for 3D printing. Engineers are taught to think the other way around. Most of the time we have bulk material and we grind something out. So it's subtractive thinking. Additive thinking is the other way up. Yeah? So we definitely need to think about this when we design products. And there is a lot to learn, still a lot to learn, especially when we want to discover and get out these thrilling fields of new things which can only be manufactured with the additive manufacturing processes. Then data are created, they need to be transferred to the systems. Then there is in the main phase the so-called slicing, yeah? Bringing or transferring the model into those slices, and then this data goes to the printer, and the printer starts building our models up. And then, and this is also a trend we see at the moment now here, we need to take it out. And the industrialization of these processes have already started now. So mainly the machines from in the past years were mainly based on manual processes, taking it out, yeah? And this will be transferred now into automated processes, especially when we're talking about larger scales. And then in the final stage, the post-processing can be super important for the quality of our parts. So after post-processing, and I will have some words on that, and the quality assurance, then at the very end, we end up having our 3D printed part in a good quality. Post-processing can be, depending on the method, can be quite different. Some of the parts need to be heat treated because internal tensions need to warp our parts or tend to warp our parts. Yeah? Then we have to remove support material. No material can float in the air. Yeah? Sometimes we need to build up support to create our structure, so we need to get rid of this support. Then, of course, cleaning processes need to be applied on almost each and every of these methods we apply. We need to clean the parts. Sometimes we have even tougher cleaning methods like sandblasting to get the loose material on the surface away. UV curing is applied on our vat-based polymer methods, for example. Then, of course, it's also very obvious that the parts sometimes are not finished and they need to be machined afterwards. Yeah? When we're talking about sintering processes, the part need to be sintered. And this sinter process is a very important process to keep the dimensions under control, because here we have to face with a shrinkage of 20%. So the prediction of this is very important to get dimension-wise good parts out of this process. Some of the parts need to be infiltrated with resins to make them leak-proof. And finally, sometimes also in plastic industry, parts are dyed in different colors to appear in wonderful colors. So a lot of post-processes sometimes need to be applied on our products. And if we are looking at a table, plastic and metal, you see that, that there are lots of different ticks here in these tick boxes, yeah, which are absolutely necessary to be applied on individual processes. So always think about it. It's not just the printer itself, it's the whole environment, it's the machinery up front and the machinery also you need to apply those post-processes to get proper 3D printed parts at the very end. Coming back to some trends of 3D printing, where does it go? In the very early beginning, we had this model that 3D printers wanted to sell also the materials, like the coffee machine, coffee capsule business model or so. And we are on our way to break that up. Lots of big material suppliers are on their way to supply materials for the additive manufacturing processes. And the machine manufacturers open their closed black boxes, yeah, to be able to address this problem and to be able to adjust machine settings for these individual materials. This is a huge trend and it will go on, and those machines tend to be more and more open, not to use this material which is proprietary just from the original equipment manufacturer. Of course, there is a big trend with respect to quality. Machines are getting more precise, machines are getting better, and this is always kind of a huge trend over the past years. And hey, from year to year, it is stunning how much development is done in this field. Then the process as a whole is also taken into account. So far, it was mainly a manual process. Yeah, parts were taken into the printer, loaded there, then taken out of the build platform or taken from the build platform. Next step, manual manufacturing work. And here there is a huge trend towards automation when we are talking about higher quantity processes. No question about that. Then speed. Manufacturers try to speed their machines up. Yeah, we're not using one laser. We are not using 2 lasers. No, 4 lasers are kind of standard so far. Yeah, when we're talking about laser sintering, for example, the speeds, nozzles are developed for higher speeds. So a lot of effort is brought into that field, that the print time can be lowered. And hey, on one side, we want to print in very fine details, and on the other side, we want it right now actually in our hand, yeah, and this is of course conflicting targets, and manufacturers and the whole industry works on those processes to make it even faster. And last but not least, hey, each and every Formnext you see new application methods which I haven't introduced to you today, but which is, of course, quite obvious: glass printing, super exotic materials, but you see constant development with new metals, new materials, which can be printed with also other methods which I haven't introduced so far. So let me finish this talk and actually put a big recommendation. Take those field guides with you, study those field guides. Yeah, it is reduced to the max. This field guide is available, of course, here. We have it in a French, French, English version, and a Finnish, German version at the trade show here. And all the other versions can be downloaded on the Formnext website for educational purposes. It's always free, so use them, spread them, and have fun and success on your discovery tour of the Formnext. And yeah, I just have to say thank you very much for your kind attention.
Big applause for Stefan. Stefan, thank you so much. I mean, you saved my life several times with the AM Field Guide. As a moderator, I'm highly dependent on an update of this field guide every time I'm here. Thank you so much. Any questions from the audience here? Give you the opportunity to ask a question. If not, I do have a question, yes. Stefan. I mean, as I'm a regular visitor at fairs and exhibitions around additive manufacturing, I know that we have so many innovations coming up, so many new technologies. How often are you asked for updates?
I'm asked for updates, but I always, and we do updates each and every year. We do updates. But to be honest, the basics will stay the basics. Mm-hmm. Yeah? And we are talking about the basics. This is not the latest innovation. It doesn't show the latest innovation. We show the core which describe the different methods. And so this will remain the same. Some of new techniques will pop up and have enough power to make it into the field guide, let's say, yeah. And I don't say I cover the whole AM world as of today. We're covering the major methods as of today. Yeah.
Okay.
That need to be understood.
So, final statement from your side, because that would be interesting for me and definitely also for the audience. Where do you see additive manufacturing this year in 2020? Because you're observing it all the time. What do you think is needed to do the next step?
I mean, this automation, yeah, is very obvious. And what we see here at the moment, large parts. All of a sudden, we see those printers creating super large parts. Net shape part, that means they need to be finished somehow with a milling process or something. That is a huge trend, and I think, hey, there will be constant development over the next years, no doubt about that.
Yeah. Awesome. Was again a pleasure to have you on stage, not only for the great presentation, but also for your work. I highly appreciate that, I can tell you, in a very personal way. So thank you for being our guest, Stefan. Big applause again for Stefan. See you next year. Bye-bye. Thank you.
Thank you very much. Yeah.
Dr. Stefan.
Thank you.
So the audience at the screen, the audience in this hall, we will do a short break with our highlights, and we will be right back with another fantastic expert insight about potential and necessity of corporations in Europe at AM Manufacturing. So stay tuned, see you in 3.5 minutes.
Hello, I'm Sandra from the Formnext team, and we are in front of the UL Solutions booth. Their main focus is on safety, and we want to know more about it.
At UL Solutions, our objective is to increase additive manufacturing into new and innovative uses by increasing the level of safety and assuring that level of safety in not only the equipment used for 3D printing, but also the materials in 3D printing construction applications, as well as medical, even biocompatibility.
What is the blue card?
So UL Solutions has, for the additive manufacturing, when we research and evaluate plastic materials for use in additive manufacturing, we certify materials in something called a blue card. This blue card contains information on the processing parameters in the equipment used to make sure that that material performance, those certification parameters that we've evaluated for that material, are consistent throughout the life of that material.
Can you specify what kind of information will be shown on the blue card?
The certification program that UL Solutions has for additive manufacturing materials is the blue card. The blue card contains testing information for standardized tests such as flammability, dielectric strength, electrical and mechanical performance of that material when it's produced with standardized specimens using specific printers and specific settings for that printer. This enables users of that plastic material to rely upon that material for use in electrical and electronic products that gives them a speed to market because they can reduce the amount of testing required to get to market faster.
And can it be used for any kind of 3D printing technologies?
The UL Solutions additive manufacturing 3D printing certification program can be used for any type of additive manufacturing process. It was put together with flexibility in mind. We currently have materials certified for material extrusion, fat polymerization, powder bed fusion. But the program is flexible, and any new technology in additive manufacturing that is developed can be incorporated for that certification program. To learn more about the UL Solutions services that we offer the additive manufacturing community, please feel free to visit our website at ul.com/am or ul.com/bluecard. All the information on the certification services that UL Solutions offers can be found there.
We're here at Aerotech, and there's an interesting drone, and a big one at that, at display. Tell us about the product, please.
Yeah, we got here a very interesting drone because most of the parts are 3D printed and are designed just for the 3D printing process. So you can see here, we got here a very lightweight design, and it's printed with carbon fiber film filament, so it's very strong, and yeah, it weighs about nothing, so it can carry a huge load.
Can we see it fly here at the Formnext Arena?
Oh no, sorry, we left the Ecos at home, so we're not tempted to fly because there's a lot of stuff.
No batteries, but I can see this thing is huge and looks possibly great in the sky. Well, thank you for talking to us, Lucas, and have a great time in Formnext.
Yeah, thank you.
Yeah, thank you.
Ladies and gentlemen, welcome back here to the AM4U stage. We have the next expert insight for you, and it's a really interesting topic because we have already several times in our presentation the topic that in order to get AM to the next level, there needs to be more cooperation between the market participants. Especially in international comparison, it's important to join forces in order to keep the speed of development high. Our next expert insight will deal with this issue. Join me in welcoming our speaker for this topic, Mr. Chris Binon, General Director of Flam 3D, on the topic Money and Time, why we need pan-European cooperation on additive manufacturing. Chris, I hand over to you. We're excited to hear your speech.
Right, thank you very much, and thanks for the very nice introduction. And good afternoon to all of you, and thanks for being here with me today. indeed a bit of, let's say, considerations when it comes to European cooperation, where we stand now and where we could or should be heading. Now, at first, perhaps the question, do we need pan-European cooperation on additive manufacturing? Do we actually need more? Because in fact, if I go looking at this website of Cordis, the community on R&D innovation in services, I just Googled 3D print, their projects or the current projects on 3D printing in Europe. The result is no less than 7,432 projects on 3D printing. So, hey, do we need more of these projects in Europe? Well, then I would like to say, when I'm talking about more cooperation in the EU on additive manufacturing, I'm not necessarily talking about more projects on additive manufacturing. So that being said, why do I think that we need more of this pan-European cooperation? And for one way of looking at it, there is the issue of smart specialization. Now, I do read quite a few national agendas or national roadmaps or regional roadmaps on additive manufacturing, and then when I look at their smart specialization section, they all look exactly the same. That's not what David Ricardo meant when he was talking about smart specialization 300 years ago, right? And that is, I think, why we indeed need to look into, well, real smart specialization. And we can't do that unless that we cooperate, unless that we actually look into this matter together. Thinking about these 7,000 and so on projects, it's not like we have a lack of projects. It's that we actually need more smart specialization and looking into what actually do we do together or not. I think that's a very important reason why indeed we should be cooperating in that sense. Now, the second issue is that, well, we can't deny it, there is actually still quite a bit of work to do when it comes to additive manufacturing. The work isn't done yet. We can't say we're a mature industry yet. When I look purely at the technology, and we do see it evolving each year, of course, but yes, we can still improve. For example, on the cost per part, I think that's basically the basics. Why do you apply 3D printing? That's because the cost per part is right for what you want to achieve. And there we see multiple innovations, and we still need to keep on supporting those innovations, that's for sure. Secondly, there's, of course, we all know that, a lot to do about quality. And then there will be many people here at the fair saying, look, oh, no, but our quality is within specs, or the dimensional accuracy is just like injection molding, or things like that. So, sure, quality is getting under control, and some of them are particularly good at it, that's for sure. But I'm also here talking about the cost of quality. We're not yet at a level whereby you can just take out things out of the printer and say, here, dear customer, that's it. The quality is exactly what you need. There's a cost involved. You need to check it. You need to have it controlled. And quite often, it's still a product that needs to be analyzed and not a process. But we're taking steps into that. Now, as for automation and integration, and I'm very glad to see here at the show that there are many of, well, a movement towards this integration and automation, and I think indeed that also will lower the cost per part again. I think AM-Flow is a very nice a movie explaining exactly that, how this integration allows you to diminish the cost per part. But that's still work to be done. And instead of working with the 7,432, I learned it by heart by now, projects, we need to look at how can we divide the work better. Because a bit of duplication isn't bad, of course. A little bit of even competition in R&D isn't bad, of course. But now my impression is really that we're doing too much of the same, and actually in that sense wasting a bit of time and money. So that's another reason to look into that. But then I thought, interestingly, that's what we perceive from the additive manufacturing world that has to be done. We need to improve the cost per part, we need to improve the quality, etc., etc., etc. For sure. But last year, we actually asked about 160 companies, end user and potential end users, why are you not using additive manufacturing? What do you have to overcome to actually start applying additive manufacturing? And let's have a look at the number, well, let's first have a look at 4, 5, 6. It's only there that they start talking about things like quality and cost per part and things like that. The number 3, I think, is very interesting. First, lack of internal expertise and know-how on additive manufacturing. Perhaps we'd like to, but we don't know. We don't know enough about the topic to actually say if we need it, if we can do something with it. Number 2, I will skip. Number 3, yeah, we don't have a business case, or it's not a clear business case. Well, for me, actually, not seeing the business case only has to do, of course, with knowledge, with expertise on the technology. As soon as you have enough expertise, you can, maybe not always, but you will be able at least to see the business case. Now, and once you see a business case into something, investment isn't an issue anymore. If you know you're going to make money with making that product by 3D printing, and you already calculated that the cost for the machine for making that is so much, and it's in your business model, the investment isn't the issue anymore. So I also link number 2 directly to actually knowledge on additive manufacturing. So again, we could ask like, oh, so Europe isn't doing enough on education in additive manufacturing. So I did Google that one as well, with the keywords 3D printing and education and courses, and no less than 5,765 projects actually have that tags in their project. So I don't think we're missing projects there. I don't think there is a lack of initiatives, but again here I think there is a lack of real cooperation, of real thinking on what we should be doing together. Thirdly, or another reason you could say why we need to work more together on this European level is because we need money, don't we? We all do. But good money. I think it was last year, and I heard a few actually of our members. We're a membership-based organization in the Benelux. They actually told me like, okay, I want to expand. My business is going well, I'm a printing service, I just need to get the next SLS machine or HP machine or whatever. I need to bring it in. And the banks don't know it, and what they don't know, they don't trust. They don't want to give me a loan. I'm kind of stuck. And so they keep on looking actually for this extra push that they need to keep on growing. That's one thing that is hampering us, and so there is actually a potential of us explaining to the world, hey, what is it? What can you do with it? Where is your cost per part? Where is your business model in it? Also to the banks. I'm not only talking about banks here, but for example, I'm also thinking about well, again, examples that I see of just, what was it? Yeah, 3 years ago. A government that gave funding, significant amount of funding, to a startup company that was about to make an FDM printer with no specific USP. So the government just gave money to a company to do something that so many of us are actually already doing, which is, I think, to come to the title again, a waste of time and money. So there also, I mean, we must use this wisely because there is an enormous amount of money available, let's say, on project work, but it must be spent wisely. So apart from banks or project possibilities, etc., there's also, of course, another thing, and here I must thank the friends of AM Power. I suppose many people already know AM Power, and those who don't, I really would say go visit them. They're in D122 in Hall 12.0. They have a lot of knowledge on these topics, but this one has also to do with money. If you look at startups in different regions in the world, we're not doing too bad here in Europe with 49% of the startups that they found. That's not too bad, right, on a world scale. But if you then look one slide on to the amount of money they actually are able to get in, to fund their startup. Let's go back. And back. 49%, 21%. We have to work together to attract those guys who are willing to invest and say, hey, in our region something is going on. We need you to be here. And of course, there's more and more happening there. And we know, well, there's a few good examples in that sense. But there's more to it. And we need to speak with one voice. This is the region, because we're smaller than many regions in the world. It's just a couple of hours flight from the one side to the other. Come here, come and have a look. We have something on offer. And that's also, I think, why, again, we need this cooperation. Now, furthermore, another reason that I see indeed to get on with this cooperation and to actually do something more together is because, and we all know that one, Europe is at the same time fragmented and united. Of course, it's one region. There's a lot of laws being made at the European level, a lot of things, well, when it comes to machine building, etc., that we all have to work towards and to work on that according to the same standards, according to the same levels. But at the same time, there are different regulations on a local basis. There's the international cooperation is quite often very fragmented. In Belgium, for example, we don't only have a national authority which is responsible for international cooperation, but we have got regional ones as well, of course, and we have 3 regions. So that brings a bit of extra work together. Also on that level, I think not everything has to be united, not everything has to speak with one voice, but we have opportunities there. I think we have opportunities there to actually go together as a community to a higher level, to a European level, and to sell that idea of, hey, we are actually not doing that bad, aren't we? So, that's another one. And then lastly, and something we sometimes do forget in our business, it's not about additive manufacturing. Additive manufacturing is a means to an end. It's something which allows you, in European terms, a key enabling technology, allows you to actually be more competitive. And that's always a story that I'm telling to every company or SME or whatever that I'm encountering. It's about your bottom line. It's about improving your competitiveness as a company. And in Europe, well, I wouldn't say we're losing it, but we are seeing a world which is in many aspects just as good or better than we are, right? Economic-wise, apart from other things. Of course they are better than us. But economically, well, there's regions that are as good or better schooled than we. There's regions who have anyway cheaper labor than us, etc., etc. So what's our USP? How will we do it? Anyway, one of those things that you have to keep into account, of course, is at least let's not run behind. Let's keep up with the speed. Let's keep on improving this bottom line for our customers and keep on improving their competitiveness. And additive manufacturing is one tool to do that, or one tool that allows us to do that. For me, I think personally that's an important point. Yes, we're all passionate about additive manufacturing, but there's more to it. There is a next level to it that we do have to keep into account, and that is bringing us further. And that we can do on the level of on the European level, I think, better than all separately. Now, seeing all these arguments and these reasons why we should actually be cooperating a bit, to me they all have to do, in the end, as I already mentioned a few times, with money and time. Basically, it's about spending our money wisely, it's about spending our time wisely, and since anyway time is money, it comes to the same thing, doesn't it? So that's, I think, also a reason to actually do this together. So in a pan-European cooperation on AM, it's not about doing everything together and doing only one vision or only one direction or dividing the cake really into separate chopped parts per region or things like that. No, but it could be about working on one vision, more vision, on division of tasks, on indeed this smart specialization, because there are some smart specialization regions in our area, and about having, on some topics, an approach, a plan, a direction we can go to and actually make this thing better. A bit of, make America great again? No, make Europe stronger on the field of additive manufacturing. So this one, for me, is actually a call to action, not only to Europe, not only even to organizations like ours who are basically dealing in the field with networking and bringing supply and demand together, but I think to all of us to actually think like, okay, we need to win this game. We need to be on top. So we need to lobby, we need to advocate for a common strategy, and let's go for it. And I think that will help us a lot, and it will make it much more reasonable, the outcomes versus what we're actually spending on it all. Now, that being said, I'm guilty as well. We just recently started a European project. I'm sorry. It's a big one. I just want to introduce it as well because it actually does go in that direction. It's a 35-party program from all over Europe with about, I think, 16 million to spend starting in January. And we did actually depart from this bottlenecks. These technical bottlenecks that we see, that we all know, by the way, and we started looking at not 3D printing, but at the end there, optimization of production. That's what it's about. It's not about 3D printing, it's about optimizing our production. It's about this bottom line. Using, in our case, because that's the only thing we know something about, 3D printing. It's by 3D printing. It's not a 3D printing project, it's about the potential user who might benefit from additive manufacturing. So we identified these bottlenecks, and that's what we're going to work on in a couple of concrete solutions. For example, on the 3D metal printing, lots of steps taken there already, but sure, there is room for improvement, isn't it? Tools and molds, imprinted electronics for plastics in there, production lines, the integration and the automation, which we're looking into at this case, or in this case specifically for the dental industry, dental implants, dental aligners, and then automated production line for high mix. You will notice there is not just low volume there, because of more and more we're moving into high volume, aren't we? Those are the solutions that we're working on, and then one step further, we're looking at this leveraging of the potential, the snowballing and leveraging of the additive manufacturing. In other words, one step beyond. So who's thinking about madness right now? One step beyond? It is a bit of madness that we're actually doing. But we want to go further. Not just about this dental implants or dental aligners, but much that we will discover there will be copyable to other SMEs, to other opportunities. And that's exactly what we want to do. We want to involve other SMEs. We want to support other SMEs, and not just by putting it on a website and saying like, hey, there's a website with information on 3D printing. No, we really want to involve them in there. And that's actually combining with these challenges that we saw. It's about really getting people into it and explaining to them how we can use additive manufacturing. At the same time, when deploying it, when impacting it, when sustaining it, it is also about the money. It's about, okay, we need to tell the world that there is actually something going on here, and we will find, or we will really go looking for additional investments for these companies, for these startups, and for these scale-ups involved, not only in the project, but also the ones that we will pull into the project. And of course, and that's the last part there, we will start a movement, a trusted community. Well, with 35 partners, we do have a head start, of course, but we want to build on this through also initiatives like Vanguard Initiative, etc., to come to a real, more pan-European cooperation. That's not the end point. This project won't solve anything, but I really want to remain to this call to action, to actually go out there and call people to action to make sure that we work together on a European level. Now, I've said enough. I think because I can talk for long, but as Walt Disney already said, the way to get started is to quit talking and start doing. And with that, I would like to thank you very much for your attention. I hope we can work on this together in the future, and for sure we'll be seeing each other again. Thank you.
Applause. Great, thank you so much. Thank you so much. Any questions from the audience here on site to Chris? Any remarks? Awesome, then if not, I would ask at least a few questions.
Sure.
I mean, I mentioned before, it's quite interesting for me because we tackle this topic quite often during the days here at Formnext. What about cooperation? Ralf Andohstedt from Daimler Truck and Buses mentioned this morning he sees hindering the cooperation is sometimes not sharing secrets and not sharing too much. How do you experience that in your organization if the market participants come together, and how openly, how frankly they are speaking about their innovation and cooperation?
It's an issue for sure, but it's actually very funny that you ask it, because I'm a bit in a special position. We have NDAs with all our members, and we're a membership organization, and so they tell us quite often much more. And then, for example, 2 weeks later, we meet somebody and we see a potential fit there. Like, hey, wait, you could actually be working with that guy. But of course, we can't tell it to the other guy, like, oh, he's doing that. But we can easily return to the one guy and saying, like, hey, you might want to talk to that guy because they're working on that, and that's not a secret. And then that can really help a lot. But I suppose that's a bit of an exceptional situation, because indeed, in most cases, when you really work on projects, then you have an issue. Although I think that the secret might be actually just to put not all the competitors next to each other, but think in value chains. As long as you think in a value chain and everybody in this chain has a different role and has something to offer to one another, they will much more easily share, and then you get to real business also.
Now you're responsible for a specific region, and how does this connection, because we are talking about a cooperation on a European level, so is it more like that you with your organization talk to organizations like VDMA, or are you approaching directly industry partners in other countries in order to get this vivid?
Well, we're more demand-driven in a sense. We generate demand in the market and we hope to connect it to the supply side. So we don't go hunting elsewhere, let's say. But we do feel the need indeed to tackle some issues on a European level. And then indeed, I mean, I know the colleagues from the Danish AM hub, and I know the colleagues from the Swiss and Austrian, and yeah, so we do talk together, and I do hope that we're moving in a direction whereby also we, because I think as organizations we should also be looking at what can we do, can actually combine these strengths, and then indeed give a bit of an example to the companies to do the same where appropriate, of course, because it's still about business.
And now let's change the perspective finally in order to get this all rounded off. If I talk to our industry partners, they tell me we are already only thinking in an international model. It's no longer about it's just us in our specific region. And I think this applies to Belgium as well, to the Benelux. I mean, they're multinational, like material, multinational companies. Aren't there like a step ahead compared to the organization that is focusing on a region? So how does that fit together?
Sure, you're totally right. You got me there. No, you're totally right. There's definitely, like I say, your estimate is as good as mine. 10 to 20% of this additive manufacturing companies who are totally global and globally active, and there, compared to them, we're lagging behind because they're not interested in these regional small markets, so to say. But that still leaves us 80 to 90% of additive manufacturing companies who are, well, or active locally or trying to break out, or both. And so there is still room for help there or for support on that level.
Awesome. I'm so happy that you had been here. In my opinion, it's a super important topic, and not only for region. As you just explained, it's more like, in my opinion, I'm totally with you, we need a pan-European cooperation here, very much stronger, more detailed, more open, in order to push our business in the right direction and to be competitive to other regions as well. So I highly appreciate your speech. Thank you so much. A final big applause for Chris. It was a pleasure to have you here. Thank you so much.
Thank you very much.
Thank you.
Have a nice day. Thank you.
Great. Ladies and gentlemen, before we keep on going with our next expert insight, we want to provide you with the current news of additive manufacturing. So please enjoy our Formnext news the next 8 minutes, followed by a highlight. And then I promise you, we go into a deep dive in another very exciting topic. So please stay tuned, and we'll see you in a couple of minutes. Thank you so much.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt Fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. Yesterday was truly action-packed. Let's start with a quick recap. France. This year's Formnext partner country featured a speed presentation format covering different topics like research, materials, software and AM startups. Christoph Eschenbrenner, president of France Additive, was guest in Afterwork Talk with Frank Jablonski. Here, he called for a joint European approach to strengthen additive manufacturing in the continent. As a conclusion, Frank Jablonski suggested to invite President of the European Commission, Ursula von der Leyen, to next year's Formnext. Let's waft over to a completely non-political highlight. A beautiful display of athleticism, grace and elastomers took place at the Chromatic stand. The artist's clothing featured the company's logo made by 3D printed elastomers. Women in 3D printing clinked glasses at the happy hour at Restaurant Finery. The female leaders exchanged ideas and dialogues on all things additive manufacturing. Every passing day of the exhibition sees countless inspiring technologies leap into the forefront. Our camera team has handpicked some trends and product reviews for you. Alotech Dresden engage in laser material processing, hardening and deposition, welding with power and wire. At their stand, they demonstrate the EHLA hybrid, a laser hardening and cladding system, which is the first hybrid 10-axis laser system worldwide. Developed to serve both as a stationary and mobile system for laser treatment. DMJ Mori present their hybrid machine by combining additive and milling machining process for 3D parts. The laser tech generates flexibility in the finishing process. The laser head is handled by a fully automatic shuttle that requires no manual intervention. Furthermore, it features a 5-axis material deposition by coaxial nozzle for homogeneous powder distribution, independent from direction of laser deposition welding. At the Siemens stand, the visitors saw how additive manufacturing can be used to optimize complex production processes. Two representatives explain how it all works.
What you see here is an electronic assembly for iWatch kits. And basically what we are showcasing is how to use additive to improve the efficiency of such a factory in every industry in the world.
And with this digital twin, we start into NX and start redesigning the part. First of all, we are lightweighting the part up to 60% lighter than it was before. Secondly, we optimize the design. If you just hold it together, maybe we have a topology optimized design, which is also enabling the part to less energy.
Navigating through the fairgrounds isn't always easy. Often getting lost in the sprawling maze? It doesn't have to be like that. The Formnext TV camera team has assembled some insider tips for your ease. For busy bees, the Formnext arena has several co-working spaces spread throughout the fairgrounds. Comfortable seating lounges with all the amenities for that urgent last-minute Zoom meeting. The fair even has several options for your refreshment, reports our camera crew.
Formnext has the fix for your little craving. Grab yourself a donut today and enjoy what our 3D printing has to offer. We have cafes spread all around the fairgrounds.
Important client meetings, product informations and curious visitors. The The Formnext hall keeps getting fuller by the day. Have a look. Industry insiders and newbies. The Formnext community represents a truly diverse demographic. Here's what the visitors had to say about their personal technical highlights and where they think the future of additive manufacturing is headed.
So the jetting technologies, working with metals and ceramic powders, this is something that I also looking for our application for machine parts.
With technical exchange, we spoke to multiple end users, figuring out how additive manufacturing can help them in the application development, understanding the selection of parts, the selection of technology that is suitable for application. The methodologies that we see today are, way more than what it used to be back in the days.
Software developments in metal 3D printing, optimizing build speeds, that sort of thing.
This is the on the software side. Slicers, simulation softwares, that's something that I would like to still check.
Peak 3D printing and the actual build volumes.
The metal techniques, the metal technology, we are a service bureau and we're producing spare parts, mainly metallic. So we're looking at the powder bed fusion techniques.
What's interesting for us is something called cold fusion. So the polymer-bound metal powder parts that can be run on polymer systems. It's interesting.
3D free-form object printing. I believe that these technologies enabled by the software will scale down in price and cost and will be available for more industries than today.
Everything. It's prototyping, it's production. There's no industry, there's no need for 3D printing. Everyone can use a 3D printer.
Now, on to tomorrow's headlining events. Make sure you do not miss these. The Formnext Career Day hits the AM4U area today from 10 a.m. onwards. It sets you off for both beginners, seasoned specialists and managers, just the right inside. Round up the evening with a beer and some socializing. The Formnext party starts at 6 p.m. in Hall 9. It presents the perfect networking opportunity for AM community members. Hope to see you there. With these top stories adding wins to our sales, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Hello, we are in front of Inner Corporation and we talk about their new technology for post-processing 3D printing parts.
Inert Corporation is a custom solution provider for pre- and post-processes in the additive manufacturing industry. So Inert solution to depowdering is an automated system that pulls the environment under a vacuum while blasting it with inert gas while it rotates and shakes the powder loose with vibration.
The powder storage system was developed as an enclosure to store bulk powders in a controlled atmosphere. The idea is to keep powders from oxidizing while in the open atmosphere. Storage can now be placed into the container and controlled to less than 1% oxygen and maintaining a controlled atmosphere level to prevent oxidizing of powders.
Our gas purification system enables us to remove oxygen and water contents inside the chamber of the printer, allowing to go below 1 ppm of oxygen and moisture, which enhance the quality of the printed parts. Our customer base is global. We supply our industrial customer as well as the universities. So people can come and get in touch with us visiting our catalog and our products on our website, inertcorp.com.
The skate park's an important part of my life. I enjoy the thrill of the next trick, testing my own limits, and pushing myself beyond my comfort zone. But it only works if I can rely on my board 100%. Creating reliability and safety in an industry that also pushes limits is a meaningful part of my role in the AM community.
Yeah, welcome back, ladies and gentlemen. Another exciting expert insight to come. And I tell you, the next topic is quite complex. It has to do with alloy. And this is why we are fortunate to get two experts to present their work to us here. For the expert insight, rapid alloy development for AM using automatic alloy screening methods and EHLA, I welcome on stage Klaus Büssenschütt, Materials Development Specialist from the RWTH Aachen University, and he has a chair for digital additive production. And we have Lennart Zeig, Senior Expert Extreme High Laser Application, EHLA, Professor DAP, RWTH Aachen University. It's good to have you both on stage. Stage is yours, please.
Thank you very much. Hello everyone, thank you for joining our talk today. My name is Klaus Büssenschütt and this is my colleague Lennart Zeig, and thank you for the kind introduction. Today we are going to talk about rapid alloy development for additive manufacturing, and this talk is splitted. At first I will tell something about automated alloy screening methods, and afterwards my colleague Lennart will tell you something about extreme high-speed laser application. So let's dig in, I would say. For the motivation, you can see here in the middle this control arm for a car, and you can see on the left side the microstructure of the conventional casting process. You can see that the structure is pretty homogeneous. We have grains around 200 micrometers and more, and we have a pretty homogeneous orientation of all of these grains. If we take a look at the additive microstructure, we can see a lot of differences to the conventional casting. We can see that we have a lot of dislocations. We can see a lot smaller grains and grains elongated in building direction. We can see segregations of different elements, and we can see a texture, a strong texture in building direction. The thing is, we have two completely different processes, and so we achieve completely different microstructures. And this is why we need special tailored alloys, especially for additive manufacturing. If we look at the steel production on Earth, we can see here for 2008 that we have a global demand of 1 billion tons, and we can see that there are more than 2,000 different steel grades. The thing is, 54% of these steel grades are flat products and 46% of these steel grades are long products. And where is the powder for additive manufacturing? So this was 2008, and by now the production of powder has increased, but the share of powder in the worldwide steel production is only at 1%. So we need a lot more powder production for additive manufacturing. Why is it so challenging to develop new alloys for additive manufacturing? If we take like 90 processable elements into account, then when we just want to make a mixture of 2 different elements, we have over 4,000 different combinations we can produce. If we have 3 elements in a combination, we have over 117,000 possible combinations. And this goes on and on. So if we think of new alloys with 10 or more elements, we have a lot of combinations we need to screen, and we need to find out which of these combinations are worth processing. And what we want to achieve is that we want to have materials produced with AM which have superior properties in contrast to conventional processing. So what we are doing there is, if you take a look at this big red arrow, this is the time for conventional alloy development. And what we are doing is the rapid alloy development approach. We start with computational alloy screening, and afterwards we do high throughput screening and testing, so we come out with just a small number of processable alloys in the end. Let's take a look at our use case, just to make it a little bit more clear. We have this turbine blade here on the monitor, and this turbine blade has different requirements. We can see that we need high temperature stability, we need creep resistance, we need a low density, we need oxidation resistance, and in the end, we want to make it for AM, so we need processability in AM or in LPBF. These are the requirements we have for the material for this turbine blade. And the material currently used for this use case is nickel-based superalloy. We have, in this example, the nickel-based superalloy 247, and this is used in the conventional method, not in the AM method. This is used in the conventional method because we have a high content of gamma prime precipitation, and this ensures the stability, the high temperature stability and creep resistance. The problem there is we can use it in casting, but we cannot use it in AM, because in AM we have different cooling conditions, and so we have hot cracking in this material if we want to use it for a turbine blade. So it's not efficiently processable in additive manufacturing. What we do then is we take a look at the microstructure of this reference alloy, and so we can see that we have grains consisting of gamma phase. You can see it on the left, and we also have in between the grains, on the grain boundaries, we have gamma prime precipitation. What we also can simulate is are the different elements and how these elements will segregate to the grain boundaries. And what we do with that, this is the microstructure of the material, a little bit more schematic. What we do with that is that we want to vary different elements of this reference alloy. So we take a look at the different elements. We see each of these elements has its own task. For example, we have aluminium, titanium, and niobium. Their task is to form these secondary phases, and their task is to form to ensure the high temperature stability. We also have tantalum and tungsten, which are strong solution strengtheners, and we also have rhenium, which decreases the formation of cracking supporting phases. So what you see here is that we vary all these different elements to a certain value. And what we come up with then are, as it stands here, over 50,000 possible composition samples. So this is a lot, and we can't produce 50,000 different samples and then see in the end which is the best. So we start with computational alloy screening. Computational alloy screening consists of two main stages. We start with very easy, very fast equilibrium calculations, which will filter out the alloys which are totally not usable for our use case. So in the first stage, we just make a really rough filtering after very easy calculation models. Afterwards, we are left with around 10% of the first 50,000 compositions, so we have 5,000 compositions left. And these go into stage 2. In stage 2, we use the slower but more precise calculation models to calculate the alloys which are, in the end, the most promising for additive manufacturing. What we also use here are reference alloys, in this case 21 reference alloys, which are alloys where we already know how processable they are. So we can compare the alloys that we screen with alloys where we already know that they work or that they don't work. And in the end, we are left with 5 to 127 5-composition samples. Let's dig a bit deeper into the two stages. Let's start with stage 1. We can go back and take a look at the different requirements we defined in the first place. And in the first stage, we want to filter after the necessary microstructures that are necessary for the use case. So in our case, it's the high temperature stability, which is the most important, and the processability in LPBF. So what we do is that we set a threshold for a certain phase. In this case, it's the gamma prime phase. And we set a threshold there that we have a minimum of this phase in all the alloys which will be filtered out in the end. So this is the first threshold we set. The second threshold for the processability is that we set a maximum for phase fraction for phases which will support cracking. So we don't want cracking in LPBF, and this is why we say, okay, maximum 5% of these phases which will make cracking more possible in our alloy. So how this looks in the end, the blue points are all the alloys we had in the first place, all the 50,000 alloys. And in this yellow square, we can see the remaining 5,000 alloys which meet our thresholds we set in stage 1. So we are in the middle here at the 5,000 something composition samples, and now we go to stage 2. In stage 2, we use, as I said, the slower calculation models, and as you can see in the requirements, we have low density and oxidation resistance left, so we didn't meet all the requirements we want to meet in the first place, and we still have to work on the processability because we only had like one parameter for the processability. So now we take different cracking parameters into account to ensure in the end that the alloy we have filtered out will not crack in LPBF. This looks something like this. And you can see the solidification interval. This is a parameter for cracking. And this needs to be very small so cracking does not occur in our alloy. You can also see the 21 reference alloys, which are in green, purple, yellow, and red. And from green to red, the processability decreases. So the green alloys are the ones where we know they are processable. The red ones are the ones where we know that they are not processable in additive manufacturing. We can see that most of the green ones are on the left side and most of the red ones are on the right side. So we can say in the end that we need a very small solidification interval. And so we set this cracking parameter to a very low number. So all these alloys which have a high solidification interval will be filtered out in this stage. What we also do is that we take the Pareto optima of different other parameters, for example, the density or the oxidation resistance, and there we can use just the optimum of the alloys we want to filter out in the end. And so, in the end, we have all our requirements met and are left with 5 to 127 different composition samples, depending on the Pareto optima we set in the stage 2. And now Leonard will tell you what we are doing with the remaining 5 to 127 combinations.
Yes, thank you, Klaus, so far. Yeah, as Klaus mentioned, we're now down from 50,000 to approximately 127 possible combinations. And the challenge for us on the experimental side is now, how do we get down to a lower number of interesting combinations and screen as many as possible physically? Now, the first thing why some type of new screening approach is needed is because of the AM feedstock material, which is typically powder of high quality, which needs to be customly atomized. So we have created individual compositions which are not commercially available as powder material as of now. So the first thing we would need to do now is go into custom powder atomization. That's the process shown here. It's, for small batches, extremely costly, time-consuming, resource-consuming, and the powder that we receive from the gas atomization itself needs to be further processed before we can actually start some type of experimental screening. Now, first step after powder production would be sieving. We would then go into a powder qualification to ensure the powder quality for the process. And in the end, we would need to repeat this 127 times, and that is for application-driven alloy development just not feasible and not affordable. Now, the possible challenge to overcome this is something we call rapid alloy development, and the entire advantage we can see here. So first shown, we have the conventional alloy development, meaning we create for each of the desired compositions our own custom powder. It's extremely time and cost consuming, and this can partially be overcome by a rapid alloy development approach called dry mixing, meaning we have elemental powders for the desired composition, and then rather than having a customly atomized powder, create a powder blend of the material that we want to investigate. Now these powder blends are a good way, they save time. However, especially for powder bed processes, we have the overflow, we have the entire process chamber. Those need to be filled, and therefore there's a lot of powder lost. Plus, we don't have the exact same composition in every particle. Now, taking this one step further and trying to save more time would be an approach called in situ alloy development, meaning we will directly feed elemental powders into a nozzle-based system and therefore don't create any powder blends separately. Meaning we produce through a DED process directly specimen with a desired composition without wasting any material. Now, the second challenge that we need to overcome here is we have developed this process for conventional DED, meaning we cannot directly transfer to laser powder bed fusion. And the difference you can see on the slide here, the DED is characterized by certain cooling rates in the marked region, and the cooling rate that we achieve in the process has a high impact on the received or produced microstructure. Now, unfortunately, the cooling rates of laser powder bed fusion do not really overlap with those of DED processes, meaning using just DED as an AM emulator is not feasible. Now, a recent development is the EHLA technology, which replicates a quite large range of the desired cooling rates, but that is unfortunately limited to rotationally symmetric parts to create the extreme feed rates. Now, we have a machine just recently received for EHLA 3D, and that can be used, which I will explain in a minute, as an AM emulator for high throughput screening, combining both worlds. So we have the local powder supply from DED systems in combination with the cooling rates that can be achieved in laser powder bed fusion. And what this machine looks like is, we'll have a look at that now. So it's a specially designed machine with a parallel kinematics which overcomes the limitations of conventional kinematics, which don't allow these high feed rates which are required to achieve the desired cooling rates. And this is being done through a parallel kinematic system that allows us feed rates in the range of up to 200 meters per minute and acceleration in all axes up to 50 meters per second squared. Now, this machine, I'll show you a small process video here. The powder is being fed locally through into the nozzle where it's molten inside the melt pool, and it allows thin-walled structures and bulk material as well of individual compositions. And some samples of produced parts that have been printed already on this type of machine are shown here. So one is the bulk material, which is interesting for sample production and investigation. And on the other, on the right-hand side, we have a thin-walled aluminum structure, which is a development for aluminum applications. Now, this machine allows us, as I said, to replicate the processing conditions and build an AM emulator. And the second challenge here is now, how do we get the desired powder mixture into the process? So we said we have replicated the cooling conditions. We're emulating, for example, an LPBF process, and the powder is being fed into the nozzle. Now, the question is, how do we get the powder into the nozzle in the right moment? The first step that we have here in our advanced mixing system is a mixing unit, which is being fed from a cyclone. And the gas or the material is always being fed through a mixture of gas and powder. And the cyclone is there to eliminate excess feeding gas that's too much for the process. Before that, we have a powder switch, which can determine the powder flow into an overflow container to save powder, and to switch into the cyclone and the ongoing feeding system only in the moments where we actually need powder in the process. That's powder saving for all the times where the process is not running or that we need to stabilize the powder feeding. And the powder feeding is done through individual powder hoppers. And the mixing unit that I mentioned now, the reason why we have it is, you can see it now on the bottom of the slide. Instead of just having one of these powder feeding systems, we are feeding up to 8 of these powder lines. And that is also the key reason why we need the cyclones. Each powder line accumulates a certain amount of needed feeding gas, and the feeding gas is one of the key parameters to influence particle velocity on the way to the substrate. Now, if we are accumulating too much feeding gas, we need to reduce it somehow, and that's a development that it has come up with the cyclones, to use the cyclone to carefully or precisely adjust the gas flow that determines finally the particle speed when they leave the nozzle and enter the welding process. Now, what does this look like in reality? We can see here on the very left side the individual powder hoppers. So it's acrylic clear containers where the elemental powders are being put into. The powder hoppers feed the powder actually into our machine. For each powder, we have an individual powder switch on the upper left-hand side, and then the powder goes either into the cyclone on the right or in the collecting container on the bottom, or it's being fed into the mixing unit on the bottom right. Now, from the mixing unit, we feed the powder into the machine, and the combination of these two things, the fast handling system together with our individual or advanced powder feeding system, allows us to emulate LPBF processing conditions in our EHLA device. Now, what's the actual advantage of it when we're looking into material screening and sample production? What we have here is the state of the art for screening individual material in laser powder bed fusion. So we can build multiple individual specimens for further investigation on one build plate, but due to the global powder supply, we are limited to one chemical composition. Meaning, if we have 127 materials to screen, we would have to do this 127 times. The only flexibility that we have here is the energy input that we can actually adjust for each sample. So it is feasible for parameter development, but not for material development. Now, with our machine, this is what's possible. We can not only adjust the heat input or the process parameters for each sample, but also change the chemical composition for each and every sample, meaning the 127 combinations that we have come up with so far in the digital screening can be much more easily screened in less build jobs with this system. And that's the the absolute key advantage that has been developed here. Now, one thing is influencing chemical composition and assuming that we have the same energy input, the same processing conditions and as in laser bed powder bed fusion. But the entire approach is only feasible and valid if we can ensure that the processing conditions that we produce in this machine can be compared or are similar to in the desired later on applications such as laser bed powder bed fusion. Now, the way we do this in this machine is it is equipped with a wide range of monitoring and preparation systems to precisely adjust and control the processing conditions that we have inside our specimen or that has been exposed to the specimen. Now, the first thing is a VCSEL system. It's a local preheating system, a diode of laser arrays that allows to preheat samples that are in production precisely and locally. So it's not a global heating system, but rather you can almost imagine as a picture from individual heat pixels where each can be controlled precisely and separately to adjust the local temperature. Then we have in the machine 2 laser line scanners. One is shown here, the other is in the parking position. So the laser line scanners are used to verify the geometric accuracy of our build jobs. Meaning in between each layer it is possible to get a 3-dimensional model of the part that's being printed at the moment, and that is done through 2 laser line scanners depending on the material and depending on the reflectivity. We use a different laser beam wavelength to scan the parts. Next system that we have available is a pyrometer. It's a high-speed pyrometry system that allows us to monitor the temperature inside the melt pool. So we monitor directly the process itself at 10 kilohertz to ensure the cooling rates and the temperature in the melt pool and the processing area as desired. Now, there's 3 more systems that I want to mention that are available on this system for material development. First thing is our infrared camera. It allows thermal imaging, and that's especially of interest for monitoring the entire energy household of the produced samples in general. So how does the specimen or the part that we are printing cool down in general, and how does it heat up? Especially during the beginning of the process, we see that we start with a cold substrate plate, and then we have a continuous heat buildup through the process energy that we are putting into the system. Or if the part is preheated with the VCSEL system, then for the times when we're in process, we expect cool down, and that can be monitored with the infrared camera. Now, the next system that I want to mention is the high-speed camera that's available, where we can take pictures of the process itself, meaning we can see single particles on their way when they leave the nozzle at approximately 6 meters per second and hit the substrate. There's a gap of 1 to 1.5 centimeters where the particles travel through air or through shielding gas onto the substrate. And what is happening to these particles while they are preheated, how they are leaving the nozzle, that can be monitored with a high-speed imaging system. The last thing that I want to mention there is the LIBS. As I said, we are mostly focused on producing specimen of different chemical compositions. The LIBS system allows us to easily check the chemical composition of our samples after production. So we can directly go into analysis. Have we seen evaporation for certain elements? Have we hit the desired composition, or do we see maybe unmixing or other effects in the process that are not desired? That's the system as we have it now in the moment. And something that I want to put on now is how do we what does it look like in reality when we've produced first results? Now, the thing that we started with in the beginning were simulations of the microstructure and the elemental distribution for certain elements in the chosen alloying system. Now, this is what we have simulated, and this is what we've seen in the experiments that have been conducted so far. And I would say that we're at the moment quite close to getting a nice loop there in linking experimental and simulation data for the experiments and that have been conducted so far. Yeah, that's the end of our presentation, and I want to just close with a short summary. So we've seen why is it important to develop custom materials for additive manufacturing. We are facing entirely different processing conditions, and so far it is common practice to use long-known materials which have been developed for entirely different applications. And the market of additive manufacturing is growing, and there are some customly designed alloys, but very few. And the main challenge has been so far the extreme amount of work that is required to come up with new suitable elemental compositions. And that is our new approach to overcome this by first using digital methods to reduce the number of possible compositions in a way that we can finally screen those that we have come up with. So we have seen the machine that is capable of emulating AM technologies and screening different materials. And the result of that is printing multiple specimens on one build plate with different chemical compositions, and therefore rapidly accelerating the alloy development process. Now, last step, we've seen that experimental data is matching our simulations so far, and we are now in the process of finally producing specimen and then later on testing with mechanical testing the produced specimen. Yeah, thank you so far for your attention. The research that we do has been mostly funded by the Federal Ministry of Education and Research in multiple different projects that are shown here, and the machine has been funded by the DFG. Yeah, thank you for your attention, and we're there to take your questions.
First of all, a big applause. Thank you so much, two of you. Klaus, Leonard, excellent presentation.
Thank you.
Thank you very much.
Any questions? Well, we have quite a big audience. Any questions from the audience so far through the whole process? If not, I do have one. But I leave it first to you. If not, how many, I mean, honestly, I'm not an expert, and you exceeded far my knowledge of alloy development, but how many people are involved in such a project? Because we see the two of you, but how many people are behind?
In all projects mentioned, yeah. I would say more than how many are in campus?
A lot.
Yeah.
Let's say like...
If we just mention our groups, maybe
like 50 to 100, something like that.
Yeah.
Yeah.
So,
but directly working here, I would say around 20.
Not bad. So you are currently researching and pushing that topic forward. At what point do you cooperate with industry, or where comes industry in place? Is that at a certain point where you talk to end users in the industry about your development, or?
It is. The interest is growing a lot. People face the challenge that the available materials are not suitable. They're interested in custom or application optimized materials. Those are not available, but still, so far it has been the main concern. It is too costly, too time efficient to come up with custom materials for smaller applications. So that interest is definitely growing.
But I can add for the computational part that to find parameters to screen something, we have a lot of input from industry that we know the requirements, so we can't just say from our own expertise that these requirements are useful for this material or something. So the industry gives us some input that we can use in the screening, so they are already involved in certain steps of the screening process.
Klaus, you mentioned at the very beginning the use case of the turbine blades. Is that something after research that is now feasible, or is it still undoable in additive manufacturing? I mean, this is how you started, right?
It is feasible to produce turbine blades with additive manufacturing. I think it will take a lot of research and a lot of time to produce them in a way to make turbines a lot more efficient than they are right now. so that it's really useful for industry to use additive manufactured turbine blades and not the turbine blades casted.
So you got a lot of input from the industry, that's as far as I got, in order to validate and to get more data, especially for the computational side. Now you are getting closer to your results, and the test results are already quite promising. Is it now the stage where you say we are looking for use cases here in the industry? Is that why you're here at Formnext, or what is the purpose then of being presented here?
It's definitely there to promote the technology. It's available for industrial applications, and we would be ready to screen more materials, definitely.
Okay. Very good. And what about the, let's say, the material provider? Because we're talking a lot about materials here at Formnext. They're doing their researches as well. Are they approaching you in order to, let's say, step into such a research to fund you additionally? Is that a topic from the industry that's coming up? Or?
Yes, definitely.
Yeah?
Actually, in the project where we do the computational screening, we have powder providers and material providers in the research team directly themselves in there, so they are already in the system.
And then let me allow the last question, because it's, you see, it is interesting. I hope it's okay for you. If we compare now material developers in the industry compared with your work, who is then a step ahead? Let me put it that way. So if you are, let's say you are developing alloys, like many companies do, are they quicker than you are in your research projects, or are you a step ahead? So is there kind of a competition? Or
I would say with this machine technology, we are at least one step ahead, since there are not that many of these machines in the world. So for this approach, we're definitely ahead.
Okay, thank you so much. Super interesting to have you here. Excellent presentation. Thank you so much for being our guest. Big applause for Klaus and Lennart. Thank you so much.
Thank you.
Thank you very much.
See you at your booth. Thank you.
Thank you.
Yeah, ladies and gentlemen, this was quite interesting. We come to our last session block, I would say, at the third day of the Formnext 2022. We will tackle again a little bit the topic of sustainability, as it's quite important. And before we do so, and I can promise you we have an excellent lineup of speakers and a very interesting panel discussion at the very end, before we go into the afterwork session, we will provide you with some more highlights of this year's Formnext. So please stay tuned. I will see you in a couple of minutes back here on stage. Thank you so much.
Hello, we are in front of the Additive Industries booth, and I will talk to Karriere to speak about their flagship product.
Additive Industries designs and manufactures the world's most automated metal additive manufacturing printers. Our customers benefit from the ability to scale production of their additive components. The main benefits of an Additive Industries printer are the high levels of automation that our customers can benefit from. The first level of automation is the automated build changeover, allowing customers to maximize the utilization of the machine without having to shift to a 2 or 3 shift pattern. The second is that we automate powder flow, keeping operators safe and away from metal powders. And the third is that we automate laser calibration, allowing customers to have the highest uptime. We have so far been very successful in the space industry and aviation, as well as general industry, which includes high technology. All our customers are focused on production. So it's fair to say that more than core markets, it's more about the core requirements of our customers being aligned with ours, in that they are looking for a system that is aimed at production. ADAM is a spin-off of the Technikon Holding. We are a young company working in the fields of metal additive manufacturing. As we start from a greenfield planning, we directly from the start opt for maximum flexibility and automation, and that is the reason why we work with the Metal Fab G2 system of Additive Industries. We would encourage anyone interested in additive manufacturing to get in contact with Additive Industries immediately. Wherever you are in your AM journey, whether it's at the beginning redesigning a part for additive or scaling a part for production, we have a team ready to assist you. You can reach us via our website or social media or get in touch with anyone you know on our team. We look forward to hearing from you.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so I give you my praise, that's right. I'm so I give you my praise, that's right. I'm so I give you my praise, that's right.
Hello, ladies and gentlemen, and welcome back to the AM4U stage on day 3 of the Formnext 2022. We go on in the last session, and it's called Deep Thought, and we want to tackle a topic that is quite important and gets even more important every year in additive manufacturing. I'm talking about the topic of sustainability, as it continues to be one of the central issues in the development of our industry. Together with really important representatives of our industry, we want to get into a deeper consideration with our Deep Thought block. The first speaker and an important guest on our AM4U stage is none other than Melissa Orm, Vice President of Boeing Additive Manufacturing. And she will be giving a keynote on the topic additive manufacturing as a sustainability driver. And I'm super excited to welcome her here on stage. Melissa, please come and join me. Melissa Orm, big applause, ladies and gentlemen.
Okay, sound check. Sounds good. Okay. Well, it's really great to be here. Thank you for having me. We will describe it. I wanted to tell you a little bit about myself. I've actually been in the additive manufacturing space for about 3 decades. I began as a professor at the University of California, Irvine, where my research was focused on what we now call additive manufacturing. At that time, it was solid freeform fabrication or net form manufacturing. I moved into a startup after that. I was a supplier. I was the chief technology officer of Morph3D. And now I'm vice president leading all of additive at Boeing. That's polymer and metals, flight hardware, as well as research, development, and anything that helps the company with respect to additive. So a little bit more about Boeing, in case you don't know. We have 20 AM sites worldwide in the United States, in the United Kingdom, Canada, Australia, and soon to be opening other places as well. You may not know, but we have over 70,000 additively manufactured parts flying in Boeing products, 70,000. Many of those are polymer. Some are wire DED. Many are powder bed fusion aluminum, a few tie electron beam. At Boeing, we do have a factory in the Pacific Northwest with the full end-to-end value stream for polymer as well as metal, and all of the post-processing capability as well. And finally, the digital integration. We have created what we call the Intelligence Center, which focuses on all things digital with respect to additive. This is our digital thread creation. For every step in the value chain, we're extracting data automatically, and we're archiving that in our data library, which resides in the cloud. And we have formatted that in an easy way for engineers to find, so that they can now do their, create their machine learning algorithms, or their data-driven models, or their hybrid, physics-based data-driven modeling, and feed that back into our value stream. So for stability, for optimization, and for basically, efficiency, making sure that we get it right the first time, and reducing that power consumption. So, at Boeing, people ask me, like, so how many parts are you printing? And sometimes people want to just print a part for the sake of printing a part. And we always want to make sure that, the parts that you choose add value. And I've separated that into 3 types of value. One is on the part level. And so we might be able to, make a part faster or cheaper, or add functionality, or increase performance or quality. Product value, then this is very important, where we can say, I don't want to optimize the part, I want to optimize the airplane, or the helicopter, or autonomous system, or whatever our product is. And so we use additive manufacturing to change the architecture of the actual Boeing product, which in our case is things that fly. And then there's program value, and we have, that might be tooling, or it might be wind tunnel mock-ups, or it might be using additive manufacturing to get an award, right? Because of the additive content, because we're able to deliver faster, cheaper, and higher quality. So everything we do, has to reside there, and we're really focusing on that product value. Here's a few examples. I've shared some before, so I've consolidated on a single chart. The picture on the upper right, the first one, that's our MQ-25 autonomous refueling drone. It's quite large. It's fixed wing, and the first part on the lower left is the heat exchanger, and we've cut that in half so you can see all the fins inside. And it's quite big. It's built on a EOS M400 at the maximum, using all of the volume of the build, basically. The second picture on the lower left is our new product line. This is a fully 3D printed satellite. Its dimensions, are half of a meter, I would say, on all axes. And it's basically a new product line. We're doing this in collaboration with our partner Millennium Space Systems, although the 3D printed component, all the additive is Boeing invention, if you will. We found that we can reduce the lead time by 5 months and the cost by 30% by switching over to the additive solution. The third picture, that's the Chinook, high-intensity searchlight, and so that is in powder bed aluminum, also built on a EOS M400 to give you an idea of size. I'm quite proud of that part. It's been in service with the customer since 2019. I think it might be the first powder bed additive part on a helicopter, which has a quite intense vibe environment. It was redesigned to withstand that vibe environment, as well as salt, fog, sand, shock, acceleration, and so it's very sturdy and it's performing quite well. We've delivered 16 ship sets. And the last is the aperture cold plate. That's also on a 400, and that's a multifunctional part. It's a waveguide, a heat exchanger, and a structural component. So those are just some examples of some parts that we have basically already inserted onto programs. Currently, we have about, today, we have about 1,200 different parts in our manufacturing flow from somewhere in that value stream. I wanted to talk now about our Eco Demonstrator. And if you're not familiar with the Boeing Eco Demonstrator airplane, it's a series of airplanes that we use without passengers. We fly it. We test new technologies on it. And so it's called the Eco Demonstrator because all of the new technologies have to do with sustainability. It's flown with a mix of sustainable aviation fuel. And just 2 months ago, 2 of our parts flew on it. The first is the Inconel bracket, which is shown on the right in the middle. And the lower one, that's me, so that you have a sense of scale. It's not a part that's this big, right? It's a part that's this big. And that's the APU exhaust duct. And so that was created with DED blown powder. And it's titanium. And it performed quite well. So we're quite excited about that technology, and that's something else that we're maturing within Boeing. So at Boeing, we're not, dedicated to one only technology, but whatever our applications are, we will try to make sure that we have the technology that's suitable for that, right? So different applications have different technologies. Powder bed fusion for some of those smaller parts, DED for some of the larger parts, and we're always open to looking at what's next. So Boeing, like many other companies, is committed to decarbonizing aviation, and we're committed by 2050 to be decarbonized flight, essentially. So these are our commitment numbers by 2025 for our operations. Cut greenhouse gases by 25%, water consumption and solid waste to landfill by 20%, energy use by 10%, and hazardous waste by 5% compared to 2017 levels. And so Boeing Additive Manufacturing, that's the group I lead. We call it BAM, Boeing Additive Manufacturing, all of additive within Boeing. We've committed to reducing the same things. But you'll notice there's no numbers there because we weren't sure, right? And we're still not. It depends on the application. So that's what I'm going to show you, basically, some of our first studies. So with additive manufacturing, there are many different facets of sustainability. And I've really broken it down into 2 large categories. And each of those have subcategories, of course. The first, which we call indirect, is the actual manufacturing process. So that's how much, what our sustainability trade is in our operations. And the second is the impact of the part produced. So people kind of forget about that part. If we are able to lightweight a part, then we, need less fuel to propel it to where it needs to go. But it's not just lightweighting. If we're able to actually change the architecture of, say, an airplane, if we're able to make the wing smaller, it's going to have less drag. If we can remove those blisters on the underside because we've been able to architect the internal aspect smaller, then the airplane will have less drag. It'll use less fuel. That's a really big impact, a bigger impact than the difference in weights of the components inside, right? That became smaller. So that's very important. It's something that additive manufacturing offers that traditional manufacturing does not. That being said, I'm going to focus on the first part, the manufacturing process, because I have a case study to show you today. And in that case study, we haven't optimized the part. So in each case, the performance of the airplane is the same. And this is just another way to look at the same thing. We're going for zero impact. We have indirect, which is the operations, the extraction of the raw material from the earth, and the conversion of that to a principal material. The logistics, the production, the distribution, the storage, and the direct, which we're calling actually the performance of the airplane. So this is the value stream. For AM, so it starts with the raw material extraction and the raw material conversion to a printable material, and then that transport of that printable material to wherever we will print it, the fabrication process, post-processing, distribution to where it needs to go. Also, there's distribution and post-processing too that we take into account if we send coupons and we receive them, things like that. The performance and the recycling. And so we have this the cycle that you can see below. It's not 100% circular, but we have the design for additive clearly lets us design lightweight, optimized, smaller components. Production, we're able to recycle powder. And I should say, in the design aspect, we're really working to be smart in our designs and to design without support structures. I know that a lot of people are looking to machines, as the solution to remove support structures, but we're really working at Boeing to be smart in the design of components and design it knowing which way it's going to be built and to ensure that there's no support structures needed. And we have some really cool examples of that. Distribution, additive lets you print at point of use in certain cases. Use, reuse, and repair. We've found that some of our parts are more durable than traditional. For example, that MQ25 heat exchanger, it survives beautifully on a vibe table where the brazed counterpart doesn't. It fails at the joins. So the additive component is actually more durable. It'll last longer. It won't need to be replaced. It won't be scrapped. And I think I've said everything else, the raw materials and recycling. So we created several life cycle assessments, and I have one that's cleared to talk about. We finished it less than a year, so that's pretty good time for Boeing. But I have a few more that are just finished, and I'm not able to show you those. But the one is a good example. So this is what we look at. We look at the energy consumed, the materials consumed, water consumed, hazardous waste to landfill, and total emissions of greenhouse gases. And we'll look at that in each of these aspects in the raw material extraction and conversion. So we've done this for both traditional manufacturing and additive manufacturing for the same part as a comparison. So you'll see in the first area there, the first segment that says raw material extraction and conversion, it also has ingot, right? And so that's for when we're basically using a hog out or casting or something. So we use this also for the traditional process. It has atomization if we're using a powder. It has wire if we're using a wire feed. So we're looking at all of that. And then the same in the manufacturing processes. What's the energy consumption? What are the emissions? What are the materials used? Water consumption, transportation in every aspect, from the raw material out of the earth to where it needs to be printed, to coupons going to a test house, to the part going to a heat treat facility. All the transportation to finally to putting it where it needs to go. The usage and the waste disposal. So this is the elements of the life cycle assessment that we've performed. And so our first case study that I can show you is the 787 aft galley support bracket. Now it's shown on the lower right, and so what we see is the as printed. It's a near net shape. This was done with tie wire, and so it has a little bit of machining, and the machined part is right next to it, right? And so this went into production on every 787 Dreamliner since 2017. There is this part and 6 others. So there's 7 different part numbers on the 787 since 2017. So we have data of the manufacturing process prior to additive and with additive, so we thought this would be a good case study to begin with. Because we didn't optimize it, there's no gain in performance of the airplane. Somebody's happy. All right. Okay. Okay, I expect that from all of you. I'm only kidding. Right, okay. Okay, so this is the result. Okay, this is the big moment. No, okay, I'm only kidding. So the blue here is the traditional, the reference for the traditional manufacturing. And in this case, the traditional was a hog out. So we had a block of titanium that was machined to make that part prior to 2017, right? And so that's represented by that blue line. The orange is the tie wire. And so you can see in total energy consumed, global emissions, solid waste to landfill, total hazardous material use, and water consumption were always 40% or less than that of the traditionally manufactured component. So this was a really great case study. And that was driven by the fact that the traditional case is a hog out. There's a lot, it's a big block of titanium. There's a lot of machining. There's a lot of scrap, mining a lot of material, transporting a lot of material. All of that outweighed the AM energy consumption. Typically, it's high. Argon gas shielding, it's not necessary traditionally, and the stress relief. But even with those things, the traditional used a lot more of our resources. We looked at other effects too, and some people call these secondary effects. I'd like to say they're also primary effects because they're related directly to human health as well as the planet health. We have human toxicity, carcinogenic and non-carcinogenic. It's pretty important, I think. Acidification of the earth, water depletion, global warming, land use, ionizing radiation, and many other aspects, as you can see. And so, again, the blue line is the traditional manufacturing, and the orange is our additively manufactured component. So you can see that in this case, additive manufacturing demonstrates reduced harmful environments and human impact. I think it's quite evident. But the question arises, will all additive manufacturing exhibit this sustainability benefit? No, right? So basically, if I'm, this was a really great use case. We had a large hog out of titanium. It took a lot of machine work. It resulted in a lot of scrap. However, if we're going to now say, let's additively manufacture a sheet metal bracket, okay? Well, that's going to use a lot of energy, a lot more than making a sheet metal bracket traditionally, right? And so that won't give you a good sustainability case. And there's things at Boeing that we're doing right now that I can't show you, but I know the answer, all right? And so, but I want to say, I don't think we would additively manufacture a sheet metal bracket anyway. If you go to that first chart of where does it add value, I don't think there's any place that would add value, right? Unless for some reason you can't get it from a supplier and you're stuck and you have to launch something tomorrow or something like that, right? In some extreme example. But typically what we find, so far at least, and we're still early, we've only completed 3 different parts of different modalities, different technologies, different types of parts. So far what we find is that those situations where additive manufacturing, sustainability aside, does not have a good business case, it's also going to have likely a pretty bad sustainability case, right? So just like in additive manufacturing in general, not thinking about sustainability, it's not the cure-all to every single part. There are times when you want to use it. And in that case, the same goes for sustainability. There are times, and a lot of times, when you're going to have a really positive sustainability trade. But there are times that you won't, right? And so what we're doing at Boeing is creating a strategy around when we will. And then really being honest and working to develop our operations such that we use additive as a sustainability driver in those cases. There are other opportunities as well. And so we're probably all familiar. A lot of people, first thing they talk about is recycling powder. Yeah, that's really important, and we can do even better by nesting a little more and so forth. But don't forget that it takes energy to recycle powder. People think that suddenly it's all free, right? We have to reatomize, we have to transport it, but it does have a benefit, and that's why we do it. Recycling of support structures is something that we're working on, but better yet is creating parts that don't need support structures, creating smart engineering. A lot of these things can work with smart engineering, and so that little part that I'm showing you, that's the Amos 10 command horn antenna. It was originally a heritage part that had, I don't remember the number of parts. We consolidated it and have now 57% of the parts. So we did a lot of part consolidation. It had the original one had a tuning set screw for the internal aperture. It had actually some tape, in between pieces for sealing. It was clumsy. So we redesigned it for additive, and it doesn't need any support structures. It's so robust, right? Because you don't have to touch it. All you have to do is machine the bottom interface for attaching it to the spacecraft. And it might look like a small little insignificant part, but it powers the electronics of the spacecraft. So if this thing fails, your mission fails, basically. It's an important part. Simulation guided builds. This is where we're really working with our intelligence center to reduce the number of physical iterations. I won't tell you that we get it right the first time every time, but we're getting better and better, and that's also very important for sustainability. Machine utilization, we're looking at the trades of multi-lasers and nesting for energy consumption per part, and something I'll be able to share at some point later. Post-processing optimization, nesting as many things as you can instead of doing things separately. And finally, using energy sources, sustainable energy sources in our operations. And we also have the opportunity for greenhouse gas reductions by printing at points of use. And this is something that we're actually doing at Boeing. So we've developed this, we call it Secure Print solution, where we have a build file that's vetted, and the whole end-to-end value stream is created within Boeing, and when it's robust and stable, we lock it down, we encrypt it, and we send it with Secure Print to a qualified supplier someplace on the globe. We've already worked with Germany, Singapore, Italy, several places in the United States, Australia. While it's printing, we can watch it being printed in real time. We're streaming data back. The operator doesn't see the machine instructions. It just goes straight to the machine. And we can basically specify how many times it's printed, what serial number machine it's printed on. And so it's also basically really important for security. But if we want parts at a certain point of use, where we need a spare or a repair or something, then this is a really nice way that we remove that carbon footprint from transportation. And additive manufacturing gives us the ability to consolidate parts that subtractive manufacturing doesn't. And I think this is the biggest benefit of additive manufacturing when thinking about sustainability. We have a situation at Boeing right now where we have a certain component where we have eliminated 40,000 parts on one vehicle due to additive. That's 40,000 things that aren't being fabricated and transported and assembled and checked for quality, right? This is a fantastic sustainability driver. And in fact, people are always asking me at Boeing, Melissa, how many parts are you printing? And I said, that's the wrong question. You have to ask me, how many parts am I eliminating? That's the right question. So the most sustainable part is no parts. While manufacturing it, it consumes no energy. It emits no harmful greenhouse gases. It consumes no hazardous materials, creates no waste to landfill. It's always repeatable and reliable, and it costs nothing. So this is what additives can do, what traditional cannot. And so finally, I want to leave you with a quote that means a lot to me. It's a Greek proverb. A society grows great when old men and women plant trees in whose shade they know they shall never sit. And so this is why we think about sustainability. It's not necessarily for ourselves, but it's for people who come after us. And it's the right thing to do. So with that, I will like to thank you.
Big applause, ladies and gentlemen, Melissa Orm. Melissa, great presentation. Thank you so much. Yeah, leave it first to you to ask questions. We have such a big audience here. There's one question. We do have a microphone today, so we should use that in order to let the people in the stream understand the question.
Thank you very much for your presentation. So at Boeing, obviously, you're using a lot of technologies that are on the market, but which technologies do you consider that are coming to market, if you can disclose, that will benefit of using these sustainable principles that you're using? So which technology you might see that on the future will help the sustainability?
Okay, that's really a good question. And so at Boeing, we are open to looking at any technology that serves that solves a problem for Boeing products, basically, that helps us somehow, that adds value. So it could be in new material development, bio-based materials for printing, for example. It could be an entirely new platform that nobody has thought of yet, that I can't even tell you what it is because we don't know, right? But we're continuously looking for new technologies. There's a lot. There's liquid jetting, for example. That's not very well developed. That might have a good sustainability trade. We don't know yet. But whatever's out there, we're going to examine it. And if it provides value to Boeing, if it's something that our business units need to help us with sustainability and also cost, performance, quality, schedule, then we'll definitely look at that.
Yeah, and my last question will be, obviously, because all these new technologies are related to startups, so do you have at Boeing any startup program so that startups worldwide can apply and get all the technology being deployed on a Boeing program?
So we do partner with a lot of companies and a lot of small companies too. We have a really broad research and development portfolio, and we already are working with a lot of startups. And we partner with Horizon X AI, which is an investment group for this purpose. And so there's some companies even in this forum that we have invested in and we consider partners and we're developing. Yeah.
Thank you.
You're welcome.
Let me ask also a question to you. You just mentioned whatever benefits the company and brings that forward.
And sustainability is benefit
I know what you
company.
mean. Don't get me wrong. But sometimes I ask a critical question. So considering your work, I mean, I know you have quite some targets. Is sustainability a part of your personal targets as head of additive manufacturing?
It is.
It is.
Yeah, a part of my personal
development targets, whatever you have.
Yeah.
So
it's definitely. I think I mean, from a personal point of view, we have to do something. We're at a point in the climate, where we're in trouble. And we have to work together, and big corporations like Boeing are committed, and I'm committed.
Very good.
Yeah.
You mentioned this part reduction, that possible part reduction of 40,000 parts, basically.
Yeah.
How many of them are already realized? So what is the progress on that topic? Because, I mean, it's the one part to identify them, and we heard some very interesting speeches on reducing parts and identifying parts. But what is about the realization of that topic?
I think, what we're doing right now is all the parts in flow right now, they're new parts. They're not taking, well, not all of them. We have some examples of that, but we have new designs, right? And they're all looking at consolidation over what would have been traditional. 40,000 parts is something that we're planning to print in 2023. The little command horn antenna, that had a lot of part reduction. That upper white bracket, oh, I didn't show that. That's a different chart. But we have a lot of, I mean, basically every part, I think, has its consolidation. Maybe a traditional might have been, you know, we would have node fittings on carbon fiber, and we've made that all additively, for example, on satellites. And so there will be a lot of part consolidation. This is something that's really big.
Before any other question, because I have so many, I could spend now 50 minutes just asking questions. I have another one that is more technical one. If we're talking about part reduction, that basically could mean that you combine parts, and you are able to do so because you're using additive manufacturing. Right. Are there any of those combinations already in place or in planning?
Yeah.
Yeah? Yeah. Can you mention, if you're allowed? I mean,
yeah, you know, that little command horn antenna that I said powers up the space, the satellite. That's a consolidation of, I mean, I'm counting, there must be at least a dozen parts or more from that part, from an old heritage to that one, right? So, yeah.
Personal feedback, what I really liked was the eco demonstrator, because remember we discussed last time what is already in place and what is realized. I mean, this is really reality in place. I mean, if you have airplanes flying with 3D printed parts in it and in a heavy use, brings me back to my generic question that I have to ask all the time, Melissa. Please apologize that. I mean, we are often talking about interior parts, and it's, if we're talking about space, there are a lot of critical parts already printed in 3D printing. But of course, it's unmanned. We send it into space. Whatever happens there, don't get me wrong, but it's not critical for us.
It's a good place to start.
Yeah, absolutely, and this is why I highly appreciate that. But where's the status if it comes to like major parts in the airplane? How close are we? I mean, this is always a question that's quite interesting for me.
Well, I mean, first of all, the Chinook helicopter has people in it. Of course, it's a searchlight that goes under it, so that's probably okay. The part that I showed you, that's you know, has a structural load in the 787 since 2017. We call that a structural component. Okay. And it's already there, right?
So let's say we are super close, basically.
And now we have our first powder bed part will go into production in about 2 months. It's not a safety critical part. You know, we're easing into that, baby steps, right?
Yeah, but anyway, it's highly appreciated. Let me round off this session. Melissa, thank you so much. We're seeing you later in the panel discussion again. It was a pleasure having you. Great presentation. Big applause. Melissa Orm, thank you so much. Yeah, ladies and gentlemen, before we come to the next topic, of course you will be delivered highlight blog, but let me say the next topic is a little bit from the other side round, because we will tackle the question, how important is sustainability for mechanical engineering? So please stay tuned, enjoy our highlight blog, and I will see you in 3.5 minutes.
From the Formnext team, and we are in front of the Amiable booth, and we want to know more about their community. Let's check it out.
The Amiable community is about to help people to get on with additive manufacturing. No matter where they come from, no matter where they want to go to, it's just to look at their case, to discuss with them, and to find people that contribute to each other just to get their solution done. The Amiable community is so special because it's from enthusiasts for people that are enthusiastic about additive manufacturing. So it's just to join people, to connect them, to look that they exchange knowledge, that they help each other, and that they grow. The main objective of all those activities is that the solution is going to be achieved by those people that want to transfer their ideas into a product. In
This instrument is 80% manufacturing. It's amazing. The housing, the grill, the keys, and the mechanism inside, not the bellow. But I work on it. Look at this. And it works too.
I think people should be part of the animal community because it's always difficult to find the right answers to the problem that's currently on the table. We have so many experts around in different technology areas, on different materials, on different topics, that we'll always find a team where we can put things together. And people exchange. They should exchange in order to advance.
We came up with the idea of printing tiramisu when we met the guys from the Tiramisu World Cup. We have a 3D food printer. They know how to make a really great tiramisu. So we worked together in order to have a tiramisu 3D printer that has the same taste and has the approval of the Tiramisu World Cup.
If you want to be part of the amiable community, then go to our website, sign up, and tell us what you need. That's what we must know in order to set up the right program for you guys.
That's a bad dog. What you do there? 3D printing is so far ahead in life. They even have dogs, and they're better than the real ones. You know what? You have to have school up their poop. Oh, come on, Spot. You don't have to do that, bad doggy. Put the doggy back in your pocket. Yeah, come on, doggy, doggy. Oh, come, bad doggy, sneaky doggy. Let's talk to the guy who's handling it. Come over here. You're from Top Solid.
No, I'm from Prusa Research.
You're from Prusa 3D. Tell us about your dog. What's it called?
It's just standard Boston Dynamics dog, but we molded it with a 3D printer on the back. So now he can carry the printer and print it on it.
Oh, nice. And
just for entertainment of
oh, I'm entertained.
Yeah.
So what's the name of your dog?
Just Spot.
And is he a retriever?
Just the original name of it.
Okay, and what breed is he?
Oh, I think some batteries.
Oh, that's a good
Just the
answer.
batteries.
That's a good answer. Well, good doggy doggy.
Welcome back to the AM4U stage, ladies and gentlemen. The question, how important is sustainability for mechanical engineering? This is a question that, of course, also interests us at Formnext. And that's why we're lucky enough to win a speaker for the topic. Dr. Markus Hering is Managing Director, beside other functions, for the Additive Manufacturing Association Working Group at VDMA. And I'm super happy that he will guide us through that topic. Markus, come to me on stage. Stage is yours.
Yeah, thank you, Sven. Good evening. Welcome. I should talk about the relevance of sustainability for mechanical engineering. This is quite a big challenge because I just have a few minutes and can deliver just an overview about this topic. Usually it would take at least 2 hours to go to all the details. So I have to be a little bit away from the details and would like to give you an overview. I would like to start with VDMA. So our organization, the German Federation for Mechanical Engineering, our headquarters is here in Frankfurt on the other side of the Main River. We have around about 500 employees, what is not usual for associations, but we go very deep in details. We have around about 37 trade associations, so that means subgroups for all the different types for mechanical engineering. Additive manufacturing is one of these. We have regional subsidiaries in the regions in Germany and also in the European countries, because we have, meanwhile, a lot of European members. Overall, in mechanical engineering at VDMA, we have around about 3,500 member companies that are producing different type of machines and technology. What, in general, at VDMA, our main topics, what we are discussing right now? One of the current ones, of the actual ones, is Green Deal of the European Union, and what are the consequences for mechanical engineering for the companies. It's a task about sustainability, about energy use, energy consumption, energy efficiency, substitution of carbon as energy, as fuel components. Part of this is also the sustainable finance discussion. So the financial situation of the companies, what is linked in the future and still started with the questions of sustainability. We have Power to X. So the question, would we have in the future a new type of energy based on hydrogen? It's an interesting alternative for some technologies, for some branches. And of course, digitalization is the other current topic what we have in all facilities. This is a big issue. OPCOR is the global production language what we introduced to the market, where we are working on in different joint working groups, also for additive manufacturing. We do a lot of in research, in innovation, and of course we deliver a lot of statistics to our members. We're speaking about benchmarks for the industry. We're speaking about export control, what is important for our industry. We're speaking about trade fairs. We give legal advice. We're speaking about regulations with a global impact. So a lot of things what we do in general. I would like to go especially to the point of sustainability and what is coming from the Green Deal in European Union. Just an overview here, what you can see. We have one point is the climate aspect. So the use of energy and the results and the consequences of using this energy. This is a big issue. You see some directives and regulation will based on that, and European Union is working on that. There is overall the target that we work in Europe in a couple of years, CO2 neutral. And then we have all the questions about circular economy, so that we bring all the products, all the materials, what we use in production back to the circle, back to the beginning. That means we have to think in design, how we can recycle the products, how we can recycle the materials, what we use for the machines, what we build up, and also looking to the process with the materials, what are later on used on the machines, what our members have produced. And you see, if you're looking in some details here, you see a circular economy action plan. You see different materials under discussion. So plastics is a big issue for different use, especially single-use materials based on plastics is a big issue. And then we have some cross-cutting issues like sustainable finance, what I mentioned before. So we see that especially financing institutes, financial companies looking how sustainable is a company. Is that on a good way, the development on the right way? We see there is in the future a need for a sustainable report for companies. There will be two different steps, starting first of all with companies more than 500 employees, and later on then also companies with more than 250 employees have to deliver a sustainable report every year. So that's not just for the mechanical engineering industry, it's also for the users of the products and issues. So for every company, more than 250 employees. And also the situation of the employees along the product chain is on the focus of the Green Deal. So you see a lot of administrative work, a lot of subjects coming up and will be relevant for mechanical engineering. And again, going to all the details, that will really run out of time what I have today to speak to you. OPC UA, as said before, digitalization, the global production language, we are working on that. And it's also a small element what is linked to sustainability, because based on the digitalization of the procedures, of the process, of the material information, we can follow up and can put together all the information what we have along the process chain. And since this year, we have also a joint working group for additive manufacturing in OPC UA. Power to X, I mentioned before, important for the hydrogen use, and also additive manufacturing is an interesting and a relevant technology for hydrogen, because a lot of procedures, we have a lot of benefits by using additive produced materials. Let's have a closer look to additive manufacturing at VDMA. So we have a working group with around about 200 member companies, and we build up the complete value chain of additive manufacturing. That means we have the suppliers of the material, of the raw material, powder, or whatever we use. So the huge variety of technology and different types of technology. We are not focused on metals or on polymers. We use every material, and we have in focus every material what is usable for additive manufacturing. We have the suppliers of software, of machine control systems. We have, of course, the OEMs of additive manufacturing machines and technology. We have also included the periphery and the post-process and finishing suppliers. They are important to have the finalized product, and we have also this internal product chain in additive manufacturing. On the other side, we have included the research institutes, the developers of new technology. We have design simulation, the building up digital twins of additive manufacturing technology. And we have integrated also the providers of additive manufacturing. They provide this as a service at the market. Very important, very interesting. They have a huge experience in using additive manufacturing. One big issue is the integration in industrial procedures, in the facility, integrate additive manufacturing together with classical subtractive methods of production technology. And last but not least, with 3,500 members, we have also a lot of, at VDMA, a lot of users of applications and technology in additive. Our goal when we started nearly 8.5 years ago with additive at VDMA was the industrial use of additive manufacturing was in the focus of our work. And we have seen, and you can see here also, if you're working around at Formnext this year, we see AM is on the way to the industry, is achieved the industry, and we see right now a lot of industrial applications, a lot of products. You have heard before, aviation is one part, but also our industry, mechanical engineering, is a user what is using more and more additive applications, additive materials, and also serial production based on additive is becoming more and more important. We have a closer look to the process chain of additive, so from design thinking up to the finalized product with the post-press, including the post-press technology and also the automatism of this procedure, if it's possible. Machine connectivity, I mentioned before. An issue is how we can measure, how we can control the quality of the product, of the materials. Do we need certification? How we can handle that we have the acceptance of the produced, in additive way produced materials for the industry. We see coming up new technologies also in additive from time to time. The other question is how we can handle the material recycle. The not used powder, for example, but also the open question is how we can recycle the additive produced products at the end of the day. Always the task is new industrial applications for additive produced materials and products. We do market surveys, and of course, that's the reason why we are here. We are active in exhibitions and in events. If we're looking around our members, this is an example which sectors, which branches are relevant for additive produced products. We see Mechanical engineering is important, is becoming more and more important. With the new approach in thinking in construction, we use more and more AM-produced applications and products. We see automotive, we see aerospace, it's relevant. We see, of course, medical is a sector, electronics also becoming more and more important, and also process technology. You see a huge variety of different industrial sectors have relevance with AM right now. Again, a look to the process chain of industrial manufacturing. You see, first of all, at the beginning is the concept, then you have the preparations to do, then you have the entire additive manufacturing process, and then you have the post-process, and at the end you have the application. This is necessary to have in mind because if we speak about sustainability and AM, we have to take a view on different aspects. One is, of course, the machine, the additive machine itself and the system around. There is also the question, how is this at the end of the life recyclable? What are the components what we have used for this machine? Of course, this is the same questions what we have with other machines and other technologies, but we have to have, as producers of additive technology, a view on that if we're speaking about sustainability and additive. Then we have the part production in the process, including the material and the material recycle, what we need for that. That has a huge impact. And the third point is the parts, what we have produced, how we use that in the daily life. Can be in aviation, is always a good example because it's usually a long life, what we see then, but it's also how we use it in other procedures and what is the impact and the relevance on sustainability in this field. I would like to block out the first point because sustainability and production of machines is an issue for every technology. If we're looking to the part production and to the material cycle, we see some benefits. I have seen Melissa mentioned some of these topics before. We have less material, what we use. There's now subtractive procedure. That means we are able to save natural resources. We can save tool costs, and we can save, depends on the application, depends on the solution. From time to time, we can reduce energy costs. We are much more flexible with additive than with the classical procedures. That means we are able to produce on demand. Low volumes, so volume 1, 2 is the typical example for additive. And we can produce generally on-site and so reduce logistic cost and transportation of materials and of products. And of course, one big issue is an added value functional integration within additive products that can reduce costs in energy, can reduce costs in production, can reduce costs later on in use. If we look into the IM parts in use, of course we have the freedom of design that have consequences on the final product, how it looks. Always, if we see all the successful applications, it looks in a different way. Usually we try to receive a higher efficiency of the product. And of course, we are more open with this new approach and the new thinking of design. We are open for innovation. Lightweight is a topic in a lot of industries. Aviation is a typical example of that. If you're able to reduce the weight of the product, you can save energy costs if you use the plane later on. And of course, the question of how I can repair products, how I can refurbish products, what I can use, or how I can reuse products what are produced. On the other side, we have some challenges on this. Of course, it's a challenge, the energy consumption of the process and the energy consumption of producing raw materials, especially if you're speaking about powder-based technology. The build rate and the question, the speed of this is an issue directly linked with the question of costs per part and the cost of production. The process chain integration is an issue where we have to work on to be quicker, to be faster, to have a better quality control. And of course, environment, health and safety is also a question how we can have closed systems, how we can handle the material in a better way. If you're looking to the product, the question is quality control, certification, how we can make sure that the customer, the user can trust the product quality. We are working on that, and we have in some sectors still implemented systems to do this. Big issue is we need experts and know-how. So that means a new thinking of design, a new thinking of construction, a complete new approach on that. That is what we need. And last but not least, we need acceptance on that. So everybody is giving me the sign. I'm a little bit late, but okay. Last slide is we see a lot of perspectives for additive. We see a lot of new applications in mechanical engineering, in e-mobility, in aviation, in aerospace, a lot of sectors that have still a huge perspective in using additive. We see the alternative concepts for mobility in the future. That includes aviation. So they will think also on alternative concepts. How will plane aviation fly on which energy basis in the future? There is a huge opportunity, a huge perspective for additive. Lightweight construction is always an issue in a lot of applications, a lot of industries. Optimized components, always relevant to everybody. We need innovative solutions in different sectors. The new manufacturing process offers a lot of opportunities for being more effective. We have the big challenge here in Europe that the number of employees, what we need is not available at the market, so we have too less staff. So if we are able to use digitalization, new procedures, we can reduce staff. Would be helpful for us. And this is the highly digitalized manufacturing in the future, based also on additive. So you see there are a lot of perspectives. That was a quick run with the view of how mechanical engineering sees additive, how mechanical engineering is influenced by the discussion about sustainability. Thank you for your attention, and I guess later on we will see each other in the discussion.
Awesome. Thank you so much, Markus. Excellent presentation. A big applause, please, for Markus Hering. Thank you, Markus. We don't have time for question marks, unfortunately, so I have to kick you off stage. See you in a minute in our panel discussion. Ladies and gentlemen, very interesting overview over the topic of sustainability. And as promised, we saved the best for last, because you can expect an exciting panel. We will provide you with some more highlights of the fair, and in between, we are preparing the stage for an exciting panel. You will see Melissa again, you will see Markus, and many interesting persons more, but I will tell you just after the break. See you in 3.5 minutes.
Hello, we are in front of Inner Corporation, and we talk about their new technology for post-processing 3D printing parts.
Inert Corporation is a custom solution provider for pre- and post-processes in the additive manufacturing industry. So an inert solution to depowdering is an automated system that pulls the environment under a vacuum while blasting it with inert gas while it rotates and shakes the powder loose with vibration.
The powder storage system was developed as an enclosure to store bulk powders in a controlled atmosphere. The idea is to keep powders from oxidizing while in the open atmosphere. Storage can now be placed into the container and controlled to less than 1% oxygen and maintaining a controlled atmosphere level to prevent oxidizing of powders.
Our gas purification system enables us to remove oxygen and water contents inside the chamber of the printer, allowing to go below 1 ppm of oxygen and moisture, which enhance the quality of the printed parts. Our customer base is global. We supply our industrial customer as well as the universities. So people can come and get in touch with us visiting our catalog and our products on our website, inertcorp.com.
Printing enthusiasts, welcome to Formnext. Formnext has 3 halls, 11.0, 11.1, and all the way across we go to 12. We're on our way to go get some nice footage for you to enjoy. And remember, it's not just about additive manufacturing, it's about being 3D. The Frankfurt Mess Fair is huge, and year after year, Formnext finds its footing here with cutting-edge technologies that the exhibitors have to show us. And hall number 12 right across has more of it. So come along, I have so much more to show you. Look at the lengths we are going to get you the content you deserve here at Formnext 2022. We'll go to great lengths for you. All this 3D cutting-edge technology making you hungry and getting a hankering for hot dogs? Well, here we are, all American hot dogs. Hope they're not 3D printed, hope they're real. But are these hot dogs 3D printed?
No, but good.
Oh, well, you've got your answer here. 12.1, best hot dogs ever.
Welcome back, ladies and gentlemen, for our last session of today. We have an excellent panel that will discuss further on the topic of sustainability in our Deep Thought block. Let me present you the excellent lineup we have here today. We have Frank Rosengreen-Lorentzen, CEO of the Danish AM Hub. We have Markus Heringen, Managing Director at VDMA for Additive Manufacturing. We have Melissa Orm, Vice President of Boeing Additive Manufacturing at Boeing. And last but not least, Dr. Philip Reeves, Managing Director at Reeves Inside. And of course, if you have such an excellent lineup, you need to have an excellent and spicy moderator. So please let me present the moderator of this panel here, Professor Dr. Janusz Schleifenbaum, Chairholder of Digital Additive Manufacturing at RWTH Aachen. Johannes, a pleasure to have you as a moderator. Hand over to you. Enjoy your session. Thank you so much.
Thank you, Sven. So, first of all, I'd like to, of course, thank you two guys who bring us a bit on, let's say, on a certain speed level into the topic of additive manufacturing and sustainability. And you pretty much put our eyes on the importance of that. Of course, I mean, today we cannot neglect anymore the importance of reducing CO2 emissions, thinking about how can we get, I mean, with a good understanding of a resource that we use. In general, manufacturing, I'd say, we're here at the home of the family, the AM family. So starting with the first question, and maybe that points out the first one for you, Melissa, but the other ones are well invited as well. How do you assess the current level of importance of the topic sustainability in the field of AM on a global level? Do you think it's rather high, so in a sense that we have to include measures, whatever it takes, into every single step that we want to take in the future? Is it that high, the importance? Is it medium, that are other topics as well, or is it rather low? We have to think about productivity, process stability whatsoever. How do you think, where is the right level for sustainability?
Well, this is my personal opinion, and I think it's high. We're at a really important part in this planet, really important time that we have to pay attention to what we do. And right now, it's kind of an experimental phase with additive. People are playing with machines. They're creating a lot of scrap. They're just, and I think we have to stop that. Yeah. And we have to just, use it as a tool and not as a toy.
Yeah, true.
Right? Yeah.
Agree. Frank, maybe your thoughts on that?
Yeah, so just echoing what Melissa just said, the conversation is there for sure. It is high on the agenda, but I think also there's a question around the maturity of the discussion, where I still think we're in a phase where in Denmark we have this term called the sticker phase, that you have stickers on everything and you say, I'm part of this, I'm part of that, and therefore I am. And that's not really helping anyone anywhere. We need to push real things out there. We need to bring the data and the proof that this is better than a traditionally manufactured product, part, or component. That's not difficult to do. There I see a bit of lack in maturity. It's something we did in Danish AM Hub just the last year. We brought 15 small and medium-sized enterprises on board in our projects. We gave them DFAM as a tool, so design for additive. We created completely new parts, lighter, more optimized, and we've calculated all of them in terms of the carbon footprint. It's not difficult to do. It is expensive, though, let me tell you. But that's the road we need to take as an industry. There's often been this challenge against AM that it's a technology that hasn't found its problem. And I really hate that as being part of the family, right? True. I really hate that. Well, guys, the problem is right here. It's the climate problem. It's the CO2 emission. We have a technology here that can really reduce material. And we need to bring, I know it's not perfect. Everyone in the family knows it's not perfect. And we don't need perfection. We just need to be every day a little bit better than what is there today. And prove that with data.
Yeah, cool, thank you. Phil, I mean, in a positive sense, you're an AM dinosaur. You know the industry quite well, I guess. And the interesting side story was that you two guys over there met in Austin, Texas, like in '96, and we had. But anyway, that's detouring a bit. But what do you think, if you look back into your additive manufacturing career, not only Stratasys, what you do today, all the consultancy, all the things that. Is that really, is it there? Is it accepted that it's that high as the two others said, or what do you think?
We were just talking before. I've come here every year, but in 2009, I came here with a software company that we'd spent about £2 million developing an LCA tool for additive. And it fell off the edge of a cliff. Nobody was interested, nobody at all. You take an STL file, you build a virtual supply chain, you take a CNC machine part, you do 2 comparative LCAs. No one cared. No one at all. Yeah. We canned the project. Now, and I think the reason we canned the project was, at the time, nobody was really interested in production. We were talking about production, but really we were just prototyping. Now we're here, and this Formnext is really different to others, that I would say there's more dominance here about process integration, automation, full shop floor end-to-end. And now's the time we can really talk about sustainability. Because we shouldn't be looking at an individual additive machine. We should be looking at the systems talking to one another and saying, how do I optimize efficiency? How do I stack flow my builds? How do I think of everything in terms of energy consumption and waste reduction? And actually, I think we can do it now. I don't think we could do it in 2009. So I think we're right at the right time to make sustainability a big part of the agenda. Yeah. And certainly environmentally and economically. At the end of the day, economics drives companies. And with the cost of energy, the cost of raw materials, we may as well make the most of it and really drive the sustainable agenda.
Yeah. Marcus, I mean, you are heading the Additive Manufacturing Working Group at VDMA, and these are 3,500 companies or even more in Germany alone, 4 million of employees. What do you feel if you go to your members, and do they feel the sense of urgency as well? Is it rather high, low, in the middle? Where is it from your point of view and your members' point of view?
It's high. So I can confirm what the others said before. It's now on the agenda of everybody. And also, it's not just the society what is speaking about sustainability and what that means for them and for countries, for the world. It's also the customers coming with the questions to the suppliers and to the manufacturers. And they would like to know how sustainable is the product, how sustainable is the procedure, and you have to deliver information. You need data on that. So we have to work on that. And on the other side, I tried to mention that before in my presentation. The authorities have changed this point also. In 2009 it was not a topic, but now we see in Europe it's a topic with the Green Deal. In US it's a topic. It's funny, in India it's a topic. They have to deliver information on sustainability also. So it's a global challenge to deliver this data and this information. What I see on the other side, the challenge for the industry is, it's not the only one. The only topic what is important. We have others what are also important, and that makes it so difficult that we have to work on different tasks simultaneous, and we have to find solutions in different tasks. But however, sustainability is on top of every manufacturer right now, in mechanical engineering, also in additive manufacturing.
And I heard that all throughout the show that this is not a problem that a single company or whatsoever can find solutions for. We have to collaborate. I mean, it's a bit like bringing Olds to Athens, but there's quite a hype about additive manufacturing sustainability. But if we look at it at a more detailed level and take a closer look at the recirculation of materials, maybe there is not that good in terms of zero waste, zero energy. You said it, the best part that we have is the part that is not there. So there's always the sense of greenwashing in the air and just putting another sticker on that. Is that an appropriate assessment? Is that always logic in that step in that we are? And if it's not appropriate, what can we do to get over it? What do you think of that, Phil? Maybe you can start with that at first.
Yeah, I mean, I always come at things from the viewpoint you have to think of things in a full life cycle assessment. You can't just pick on the material is not sustainable, or the process is energy inefficient, or the distribution chain is too long. You have to look across all of it, and there are cases of, you know, really awful materials being used in additive manufacturing that use a huge amount of energy, titanium, aluminium, just to get them out of the ground before you atomize them. You know, they're not great materials, but we live with that, and we work in different ways to find more sustainable materials. But we offset that by doing fantastic part consolidation, topology optimization, weight reduction. We save fuel in aircraft. All those knock-on effects offset the fact that the material has a huge embodied energy. So I think we have to not focus too much on saying, oh, the material's not sustainable or not recyclable. Let's focus on the kind of the low-hanging fruit first. Let's deal with inefficiencies. Let's improve utilization. And then when we've got that pinned down, let's then start moving on to more sustainable material.
Yeah. Maybe from a company perspective, Melissa, I think there's always a technical point of view that you have, but also I see, I mean, Boeing stock-listed company, and I see that capital markets also force us to do that. Is that helpful, and to what extent can we use that power that capital markets push on our technology and really bring things from a technical and business point together?
Is that for me?
Yeah, it's for you, for me.
You know, it is helpful, right? I mean, any sort of push that we can get, you know, it helps us. I mean, in terms of sustainability, it's the basic right thing to do, business case or not. But you know, the business case helps. You know, helps our finance, you know, focals at Boeing and so forth, right? But I wanted to piggyback off of what you said about, you know, yeah, titanium's not the best material. Aluminum, we dig it out of the ground. But if we could make it with a fraction of the material that we used in the traditional, that we were making it anyway, that case study I showed, we were, you know, hogging out a great big chunk of titanium before additive, and now we're just printing a smaller amount, right? So it's not perfect, you know, it's not like 100% emission free or energy consumption free, but
It's
we
way
showed it's
better
about
than- yeah.
35%
Yeah.
of the energy, right, of the other. So, I mean, we do have to look at the whole end-to-end life cycle. Yeah, I mean, maybe actually the printer uses a lot of energy, but when you look at the machining, the hazardous waste, the water consumption, the transport, and so then with additive manufacturing, it's very important in aerospace, more than others, that we want to make it lightweight to use less fuel, right? And so we have that big driver for additive to make it lightweight, use less fuel. The product becomes more sustainable than just the part and manufacturing of the part, right?
True. Thanks. Marcus, I mean, in the end, a life cycle assessment means life cycle, so you have to look at the parts. It's a bit of a hard of a perspective for a machine tool manufacturer or an additive machine manufacturer, because you're just delivering the drill and not necessarily drilling the hole into the wall, which is decisive in the end. But what do you think can the machine builders, the machine manufacturers themselves, what can they contribute to that really being green from the very beginning on?
I think we need a very responsible way how we handle this situation, because we have to look in details, we have to deliver data and transparent information about the procedure.
Transparent.
And I guess also important is we shouldn't say in general additive is more sustainable than others. This is important, because if we do that, somebody will find out maybe another procedure is better, and then we have exactly what you said before, greenwashing. Then we stand there and we will never come back from this point.
True.
So I guess we need an open discussion within the industry. It's a typical job for the associations where we can involve all the different parties, and then we have to deliver the information what are available, what we need. If we need some research, we have to do that, and the transparent data is the basis for the discussion. And we need, of course, some more data than we still have today.
Yeah. Frank, from a perspective of a country that is rather small, not many resources in there, somehow comparable to Germany, we have also none of the resources. The resource we have, we don't use anymore for good reasons. What do you see are, if you look into your community, what are good examples where additive manufacturing can be a decisive game changer? Are there any ones, and how do you get them? How do you get really into those examples?
Yeah, first of all, I would challenge a little bit. I would say in Denmark, actually, we have a lot of resources. One of them being green energy.
Yeah, sure.
Which I know pretty much every nation is envious of right now. So yesterday we had a bit of a storm in Denmark, and when I printed something in my basement and that material was compensated, so the material provider would tell me, you know, that's a whole other discussion, but would tell me that that material is CO2 neutral. And the print in itself, yes, the printer uses a lot of energy, but it's actually, you know, when I had the product in my hand, it's actually close to CO2 neutral today. So it is something that we have because we have a lot of resources in Denmark, and we have a lot of skilled people and producers with this. Now, coming back to which application or which sector, we have in Denmark, we have 10 really, really large producers like Novo Nordisk, Danfoss, Grundfos, Lego, Velux, and some of the Coloplast and the rest. And then we have a jungle of small ones. And what excites me is when the small ones, they really get this. Because that's also kind of a confirmation that additive is really on the roll. We don't have a car industry like you have in Germany, but we have 400 suppliers to the German car industry. And they are competing against Chinese manufacturers or American manufacturers. They are actually doing a really good job because they're finding a niche. They're finding a niche and a specialty that only they command. And when they start also using this new fantastic tool that additive is, they create more jobs, they create more value. So that's just one example of how this great nation that Denmark is, with all the resources that we have, how we find these niches and these expertises and build wealth from that also with this new technology.
Yeah, maybe directly jumping on that, by the way, I just wanted to say to the audience, if there are questions, don't hesitate. I see other AM dinosaurs here as well. So feel free to answer questions, to ask you questions. But I want to jump on that. Do you have any precise examples out of your community where you see that AM is really a topic, AM sustainability is really a topic that was integrated into some sort of other projects, and where it gained importance that you really can feel, and it gave a positive outcome as well. So it was not only pain, but it was also success, because we heard there are many problems that we have to solve, and it's always a bit of pain, right?
Yeah, I do. Typically, the producers that we talk to, typically there has to be a business case.
Yeah.
Typically, still, I wish that we could say, we do this because it's more sustainable, but typically we need to find a business case. And obviously, just the one coming to mind is we have a drone producer in Denmark. And this drone is a really large drone, and it helps maintain wind turbine farms in Denmark and in Scandinavia. Just taking the hinge of this drone has 8 arms, and just taking the hinge there, and that hinge used to be manufactured with 4 parts, and because we can print it, it's just 1 part. And also, since we can use generative design, we can take a lot of material away, and that drone in itself is 11 kilo lighter because of that. Now, if you look at the production phase in itself, it's worse off to use AM, because we're shifting from aluminum to titanium, and we are using titanium powder and a lot of energy. It's worse off. But if you're thinking of that this drone, the next 5-6 years, will fly up in wind turbines and can have a lot more load, and also has these 11 kilo lighter, so it uses less energy. That's really fantastic and amazing. Cool. But the conversation in manufacturing is not there right now. It's my own personal opinion. People like us, like the Danish AM Hub, and we're a philanthropical fund with a little bit of money and a little bit of expertise. We have also to push this, prove this, and then bring the cases alive. And just going to our website, you can see 50 cases of how we've used AM in Denmark. And soon you will be able to open source see these 15 cases of Danish producers saying, okay, we want to share that. Where also we have these carbon estimates.
One thing on that, is there a common DNA? What made a project successful? And maybe you don't showcase the ones that were not so successful. It's just a maybe educated guess. But what's the DNA behind it? How can we make them successful, and what should we maybe avoid?
Yeah, so I think also just echoing Melissa's presentation, when you work with these things, you start getting like a feel of the strategy behind when is it a good idea to print things from a sustainable point of view, also from a business point of view, but also from a sustainable point of view. And obviously we've built that into our projects, but even when we do so, sometimes we also get surprised that, okay, it wasn't actually a good idea to print this. And I think for us, since we're an open source, a philanthropical fund, it's easy for us because we'll just lay it out there and say open source, we achieved these benefits in terms of maybe lead time or a better business case, but we did something that actually emitted more carbon into the atmosphere. And just being honest about that, think of manufacturers out there across the world, right? 31% of human emissions today are from how we make stuff, because the materials are so bad as they are. Let's just be honest about what we're making, so it's not a surprise about what is this? Where is the CO2 emissions from that? Where has this been produced? Why don't we know stuff like that? So just being honest about that conversation is something that I think we can drive forward.
And maybe transparent. Melissa?
I think if we're all transparent about when is it a good sustainability trade and when it is not, it will be more believable, will be more genuine, right? People won't think we're just greenwashing additive as the solution for everything. And we're finding cases where you shouldn't, print it. It uses a lot more energy and it uses hazardous materials, and we're going to publicize that. Yeah. It's balanced with the good ones, of course, right? And so that I think it's our job to teach people when it is a good time and when it is when you shouldn't, right? Otherwise we're disingenuine.
Yeah. It's about transparency along the whole chain, right?
Right.
I think also it's also about thinking beyond just traditional manufacturing applications. I've done some projects recently in fashion, where we're using additive manufacturing to displace traditional supply chains. I did a great project a few years ago in the petrochemical industry, which kind of sounds a bit perverse.
Yeah.
But using additive for better heat exchangers that reduce the energy consumption of the process industries.
True.
Now that's kind of it's a different area. It's not weight reduction, it's not topology optimization, it's efficiency improvement. Yeah. And actually some of those gains can be enormous. And there's a huge environmental benefit. Better heat exchanging, even through to valves, better valve systems. Anything that takes energy away from systems has a knock-on sustainable benefit. Yeah. And I think we probably have an education job to do outside traditional engineering and maybe getting into the process sector, into the Six Sigma guys and saying, let's start looking at wastes within your business. Yeah. Not just your manufacturing waste, but your process waste.
Still, we have to drill it down to the process. Once we decide, okay, additive manufacturing is a sustainable option for production, still there are many different kinds of additively producing that. Yep. Different machines consume different energy. Marcus, is there a need for also the transparency for the machine tool builders like we have with the washing machines, A+ and stuff like that? Do we need something like that? And is it helpful or is it not? Is it also greenwashing? What do you think?
Good question. It seems to be a good solution because everybody's able to see that. But we have seen that with the consumption products with A+ and so on, and at the end it was A+++, whatever, and then we reduced the system to a different
maybe we
step.
start at G also, H or whatsoever.
I guess for industrial products or for machines, what are used for industrial procedures is not the right answer. It's too simple, and as we have seen before, the challenge what we have is so complex. It depends on the product, it depends on application, it depends on the conditions where we use later on the product, where we produce the product, which material we use, so that we are in general able to put a logo or a sticker on the machine and that's it. And then it's sustainable. That is also a good example for greenwashing because I guess it's not the solution.
Yeah, but
because it's too complex.
We could do, I mean, there does need to be more standards though, and again, I'll come back to this. If you try and do an LCA, between two comparative metal additive machines, they both quote completely different sets of metrics for everything because they're trying to compete. So one will tell you build speed in cubic millimeters per hour, one will give you Z height. Right. Yeah? One will tell you what their maximum power consumption is when you turn it on at spike, and the other one will tell you what their steady state is. And there's no data because everyone does a data sheet that's based on metrics that benefit them. And actually, as an industry, what we should have is a regulated set of metrics for a machine that says steady state power, peak power, build rate for different materials. And okay, I know it's very difficult to do, but we haven't done that. Other industries have. They do have very comparable metrics that allow you to make a choice between the two vendors. But additive hasn't, because we're just too damn competitive with each other.
True. Melissa, you want to add something?
And then once we get to that point, and I'm assuming we will, where we have the data on all machines, we still, have two different companies using the machine differently and getting very different results, right?
Right.
And we have to be smart as engineers to, do the proper nesting and maybe simulate the build so that we don't have to develop it 12 times to get it right, physically, right? So there's a lot of things that we can do as on the people end, to use the machines a lot more, to get a lot more efficiency out of them.
True.
Right? People don't, and so I like to think about like the energy use per part. Yeah. Not like the energy of the machine, right? Because if I put one part in there, or if I, I'm able to put 12 parts in there, and if I have, then you have to look at the number of lasers, and so you'll say, well, that machine with 12 lasers has like massive energy, but if I can make all these parts a lot faster, then maybe there's a better trade. Maybe the energy consumption per part is lower than in a single laser, lower energy machine. Yeah. Right? So it really depends on how you use it.
Yeah. But let me add, this scenario, what you mentioned before, is realistic. So if you're looking to Brussels, for example, here in Europe, that they create a sample like this, it's absolutely realistic, and therefore it's our obligation as industry representatives to push the industry in delivering dates, make the procedure transparent, and say we have to deliver the information and also tell them that it's the wrong way to go. Otherwise, we could have a sample like that, and then.
And I know there's always the dispute between being precise and correct in every detail and being practically usable. And I think that it's really like you cannot fulfill everything, and in the end, you have to have something that is usable, although it may be not correct in every detail. But if you are correct and it's non-comparable, then you just end up in a mess and nobody's able to decide anything. That's the same what we do today with our. If you want to acquire, if you want to buy a machine, and you get the different quotes, they're all sort of different. But in the end, you have to make a decision.
Yeah,
and that's what is actually needed.
And also, I guess we all agree we have to be more sustainable.
Yeah.
As industry in general.
Yeah.
So, and if you have then something what we have to fulfill that we are on the market. The consequence is not automatically that we are more sustainable, but we have to do. Resources are endable, energy is endable, so we have to find more sustainable solutions.
Yeah. What I actually like about the discussion is it's not bashing the manufacturers of the machines, it's not bashing anybody who's then using that machine and producing parts, is that we can only solve this together. I think that's one of the key messages that I take away. Again, I look in the audience. If there are questions, pose them. If not,
I have a question for you guys.
Yeah.
Okay. So, you say we shouldn't bash people, but I'd rather. I think walking around here, you've got some fantastic industrial, genuine application use cases, and you have. I'm not going to say hundreds. There's probably not hundreds, but there are tens of vendors of low-value extrusion FDM who are creating thousands of tons of waste every year.
True.
Because what is being printed is Yoda heads, nodding dogs, and Eiffel Towers. And I wonder if that's actually going to give this industry a bad name.
Yeah.
So I'll put that to you guys.
This is when I was saying we have to use it as a tool, not a toy.
Yeah.
Right? And we just have to get away from that. It's still in the experimental mode. People are saying, gee whiz, we can make this, hollow Yoda head or whatever.
Yep.
But, we have to get away from that.
I would like to switch it a little bit because I said so many times, that was when we started this show 7 years ago. That was the case. Everybody shows these gimmicks. and you're not able to see any industrial application. If you now go around, you said it all before, we see a lot of industrial applications. We see real used products.
And good ones.
A lot of business cases.
Yeah.
But of course we have still some what are not so far, or not able, whatever, let's say they are not able to show business cases, whatever.
Yep.
Maybe the customers are not allowed them to show, or they don't have.
Yeah, but it's the right.
But we're seeing more and more of them. I saw a low-end FDM machine in the middle aisle of Aldi.
Yeah.
Yeah, and somebody's kind of going, Christmas present, yeah. And it's kind of, but why? So, and that to me, that just worries me a little bit in the back of my mind that it could have a really negative impact on our industry.
Yeah, true. Frank, you wanted to add something?
No, I absolutely share that, and I think in Danish AM Hub we said that there are many ways to use AM to benefit a producer. Depending if you want to change your product, if you want to change your value chain, or if you want to do both at the same time. And if you don't want to change your product or your value chain, you can still get benefit out of AM, which is through tooling or prototypes, right? But to be honest, when you prototype stuff with a printer also, maybe being the next level from the Yoda heads, that's also just burning plastic, people. And we're really honest with them. We're telling, we have projects where we give them for free a printer for a couple of months, and we say, you try this out, but we want you to change your product or your production line so you get into a more tailor-made system where you can get rid of material. That's what we want you to do. Or we want you to change your value chain. Look at your value chain. All your CO2 emissions is in your own value chain. How can you use this technology to get rid of that? Or create a completely new business model with your product, with all the benefits that AM can give, where the customer can help you design things, you can have a really nice take-back order. Because that's the wave we need to broaden out there in manufacturing. I think if you just print a Yoda head, that's not okay. But if you print a Yoda head, and then you slowly get on to how to use AM for more benefit and more sustainability, it might actually be worth it.
Yeah.
It's probably worthwhile, making sure that schools,
for sure.
STEM understand this, because you see the cheap Amazon, desktop polymer printer in every classroom, and they're really just, playing.
Yeah.
Right? And so it's like, that you have to stop playing and understand that every time you turn it on, you're using energy, you're using resources, and that, I think that educational component needs to be there, which it's not.
Yeah,
I'm sure
absolutely.
it's not.
I mean, in one sense, simplicity is really good, and making the hurdles as low as possible that everybody can really play with. On the other hand side, if you point the finger in the mirror, it's pointing to you again, and therefore we need to have some sense of the urgency that we need to do something right now.
Yeah.
I wanna maybe we're already running out of time. We've got some more 10 minutes left. Maybe point also at a different topic, which from my point of view is not really discussed here and showed here at Formnext so much. And this is all about the recycling. I mean, we see new fantastic applications. Multi-material is a buzzword. But if I think of multi-material, I think of using it, it's cool. But if I think of recycling it,
hard.
Ooh. What do you think? How can we incorporate recycling? And is additive manufacturing, in terms of recycling, really some sort of able to be sustainable? What are your thoughts on that? Do you have any expectations or any experience on that?
I mean, it really depends on the material system, right?
Yeah. I mean, yeah, sure.
Yeah.
Polymer and metal on one side.
There's some, companies that's, kind of like all the rage. There's, a startup coming every month that's taking scrap from titanium machine shops. Boeing makes a lot of scrap and turning it into powder. And some are better than others, and some even have, yet to be vetted, a circular, truly zero carbon footprint on recycling. The scrap into powder. I mean, that's great. Other polymer systems, I'm not sure.
Yeah, I mean, from a polymer world, we look at it that the greener the front end is, the better.
Yeah.
Right.
But as long as it's the right type of green, growing castor bean oil to make nylon 11 is not great if you're displacing crops that are food-based crops. So you've got to look at that whole front end.
Right.
You've then got to look at the back end and say, well, can you compost it? Can you burn it? Can you reprocess it? In the middle, can we just use less of it? Can we do less prototyping? Do we really need to do 7 iterations when we can do 3 of them in simulation and do CAD? Right. So I think we're getting there. The problem is that we've spent a lot of time and money developing the materials we have, and a lot of time and money qualifying them for the hardware. Yeah. And then, yes, it's relatively, I wouldn't say easy, but it is. It's relatively easy to change the base chemistry of a lot of the polymers we use to make them more sustainable. But the cost of going through that whole process again and building value chains with a new material that's got 40% bio-based to it, that's expensive. So I think industry will drive material vendors to have more sustainable choices in polymers, but it's not going to happen overnight.
True.
But I think, I mean, from my point of view, if I have, some material system that I've qualified, and it has certain mechanical properties that meet the requirements of some engineering design, and another one comes on that you could say this has a fantastic sustainability story, right? Yep. There would be reason to invest in the requalification, from my point of view. That's something that I would actually support, because you want to be using materials that are sustainable, and you want to, we as leaders need to set the example, I think, right?
And I guess one question is always, what's the value of the raw material? As higher the value of the raw material is, as easier will be the recycling. There is a must. If you use titanium or another metal, what is very expensive, you will be interested in recycling, and it will be sensible to recycle.
Sure.
If you have a material where there's not a real value behind, so then we're speaking about polymers, it's too cheap to recycle. It's too expensive, and especially if we then have a multi-mix material, it doesn't make sense. And then we exactly at the point: is that really sustainable? Or is this a giveaway or a gimmick what we have better maybe not produced? It doesn't matter in which way, if it's additive or not additive. So this is the challenge what we have as industry in general, to take care with the product, the raw materials what we use.
Yeah, it's all about the internalization of external effects. So maybe we could we may or should give in the future also some artificial prices to that we can calculate it. I mean, in the end, the beauty of calculation in euro or dollar whatsoever is that makes it easy. We boil it down to one number and then we can decide. Again, it's either detailed or easy. Frank, any thoughts on that?
No, I just keeping it a little bit simple here. We've just, I think it's 9% of all the plastic that has been produced ever is what we've recycled.
Yeah.
The rest is waste on our planet.
And the problem is there is no value behind.
Exactly.
Yeah.
So I think there has to come a change. You know, either politicians will do it. My children will for sure do it.
Yeah.
So there will be a change here, and AM suppliers will also need to look at that change coming and be ready for it. We've developed, I think the discussion around circularity is an issue that is best taken in terms of the whole manufacturing system, because it's the whole manufacturing. If you print something or cast something or mill something, you should always use waste first.
Yeah.
Always. That's just a given, if you can. We have, just given you an AM example, we have a startup in Denmark who is printing 20 square meter homes for students using plastic waste and just strengthening that with a tree fiber. And he built the printer himself in a large factory. And that's a new business model. And that is really hard because he's up against, a really tough, efficient production system that knows exactly how to produce this, right? But these are the kind of models that I think we need to maybe foster, support a bit more, just to be sure that we can use all the waste that's on our planet still. Because that, how can that disappear if we don't reuse it into products?
Yeah.
And we do have to look at the whole value chain. If I'm using a part on an airplane and it's made out of polymer, because it's lighter in weight than something else, and so now that airplane is lighter in weight. So when I'm flying it, I have less drag. I have, I'm using less fuel. I mean, that's might really outweigh the fact that I'm using some material that's not that great, right? Because I'm actually getting a better sustainability trade from the operation of the lifetime of the airplane. It's better for the planet.
Absolutely.
Right? And so we need to look at the whole the end life cycle, not just creating the part and delivering it, but actually the performance and its life.
Yeah, true.
Right?
I think what's interesting is that once we talk about recycling, the natural reflex is that we think about recreating powders, granules, whatsoever.
Right.
But I think what's totally underestimated for additive manufacturing, old-fashioned, I would call it repair. Today we call it remanufacturing. But that still is a value. We don't need to have to go all the way to the smelter. We can use those parts again. And I think that's also totally underestimated, and that's additive manufacturing by itself. We just put some layers upon layers for the repair, and then we are there. I mean, it's a bit too easy again, but that is something that I see that it's also in there. I see the moderator too is there, so we still have some 40 minutes. Maybe 40 minutes? If you have one wish for the future to be additive and sustainably being two sides of the same medal, what is the one thing that you would vote for that we need to have to make that happen? Somebody wants to start. One thing that we need to have to make AM sustainably being so close that we cannot detach them anymore.
I guess we need transparency, and we have, as an industry, work together, all with one target. Otherwise, we won't receive that.
And I was going to say education, which really goes education and transparency. I mean, and working together to educate.
Yeah.
Yeah, I think education and the right tools, the right life cycle tools embedded in the design, the simulation. Maybe that's what we need is our simulation tools to tell us what changes to our designs actually have long-term impact.
Right.
Now, whether that has a short-term monetary benefit to simulation companies, I don't know.
Yeah.
In the long term, maybe people will pay for that.
Frank? Yeah, I heard a colleague say that going to Formnext is like Christmas, because it's dark and it's cold and you'll never get what you really want. So I really want someone inside these great square meters here to come with these are the data behind the cases. This is my material, this is the transparency, this is open source. I'm just laying it out there so that we can really foster and bring this potential out of this technology. It just seems so obvious that this could be the production technology that we would turn to the next 100 years. But it won't be if we don't prove that it's better.
Okay, so Christmas is the right word.
Yeah.
I mean, the good thing about it is it's all there. Nobody mentioned something that's not imaginable. It's all there. So in the end, we all have to do it. And then I think that's the final message that we could send. We have to do it. It's work, but we have to do it. Thank you very much for being so discussive, for bringing your thoughts into that, and for maybe helping the one or the other to put his or her thoughts in a different direction. And maybe we'll see what happens next for next, to have some transparency, to have more education. And then we take the next step. Thank you very much.
Thank you.
Thank you.
Big applause, ladies and gentlemen. Thank you so much to the 5 of you for this inspiring discussion. Very controversial. I liked it a lot. Thank you so much. See you at the fair. Ladies and gentlemen, that was the last point of our deep thought block today on day 3. Very exciting one. I have only one thing to be left for me. I have the pleasure to hand over to my colleague Frank Jablonski, who will have a very interesting guest at the afterwork session. Enjoy that and see you in 4 minutes.
Thank you. Thank you. Thank you. Appreciate it. Thank you so much. Sehr gerne.
Julian, we're here at Siemens, and in front of us this incredible piece of technology. Explain it to us. How does this all work?
So it's amazing to have you here on the Siemens booth. What you see here is an electronic assembly for iWatch kits. And basically what we are showcasing is how to use additive to improve the efficiency of such a factory in every industry in the world. So we are talking about this part here.
Yes, and we have an approach that we have a digital twin of this whole machine and production line. And with this digital twin, we start into an X and start redesigning the part. First of all, we are lightweighting the part up to 60% lighter than it was before. Secondly, we optimize the design. If you just hold it together, maybe we have a topology optimized design, which is also enabling the part to less energy usage in the machine.
So, Seren, you spoke about the lightweight quality of the prototype that you have in your hand. Talk about the support structures that you use in this technology.
So, support structures are a thing you need for several technologies in additive, but in FDM it's most challenging, but also most efficient to use less or no support, and that's what we realized within this design. So we added chamfers, analyzed the part and its functionality and functional elements, and then realized to support this design even in this hold. You can see like a chamfer here as well, and that is enabling us to print this part without any support.
Thank you, Seren and Julian, for talking to us and for the great demonstration. Have lots of fun in Formnext.
You too.
Thank you. Luke, thank you for joining us, Head of Sales and Innovation at Curb. You have joined forces with Formnext this year and organized the Permundus Challenge. Tell us about the Permundus Challenge.
The Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Oh, definitely.
Yeah.
Definitely they have. And that's what this retrospective view of the different winners of the last 10 years really show. That there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well at the applications as how to combine material and process, as how to make a really good design, and because at the end it's a design contest.
what are the developments in the business models of these companies? Like you said, small SMEs, big companies, they've all won Permanence Challenge at some point.
Yeah, there are students with ideas. Some of these ideas will go into startups, and we are happy as a service provider that we could help some of them really producing their products.
What are the expectations? I mean, the past 10 winners, what do they bring to the community of additive manufacturing?
Oh, well, that's a difficult question, and we had several winners every year, but I think it always has been a view into the future, and the future has come true for many things. So especially for people with special needs, you see quite a number of good samples how you can how you can assist people with special needs. And I believe that has become true over the last 10 years, and very good samples have been winners of the Permanence Challenge.
Very nice. Mr. Luke, thank you for your encouraging words really regarding the industry and how it's grown. And I thank you for your time, and thank you for showing us around. And we are excited to be here when the champagne bottles pop.
Thank you.
Yeah, thank you for your time.
Welcome to Formnext 2022 and our after work talks here at AM4U stage. Yeah, the third day of Formnext is nearly over. Let's do a short wrap up. Today the focus was very much on the topics of training, staff qualification and career opportunities. We had some very interesting in-house concept here on stage, including virtual reality trainings and virtual simulations for education. Very interesting topics, these ones. Useful resource for understanding additive manufacturing was also the AM Field Guide, presented here on stage by Professor Steffen Ritter. Very useful tool, I think. And here on stage was mentioned a very special project today, which is currently ongoing, but later concerning that one more. About this project and a general look into the online community, I'm extremely happy to have two community insiders here with me on stage to have the after work talks. And so I'm very happy to introduce to you Sarah Görke. She's consultant in AM, and Joel Telling. He is host of the show 3D Printing Nerd in YouTube. It's displayed in YouTube, where our show is displayed as well. And you are a confessed AM nerd.
I would say that's accurate, yes.
So tell us, what does Formnext mean to you?
Formnext to me really gets to the heart of the matter that AM is the future. Additive manufacturing is what's going to power society going forward and to the stars and beyond. And Formnext is where we get to see that technology take shape and gets people inspired, and it's a joy to be here. That's what it is to me.
So what have you done all these days here in Frankfurt? What at Formnext?
Well,
what was your job, or what, just walking around and talking to people, or did you film the whole day, or what was your job?
Well, we had 2 days scheduled for filming. Masago brought us out, and the goal for our team was to highlight the stories in some of the booths, or as many as that we could get to here at Formnext. And it's crazy because every booth has a story. Every company has an incredible AM story to tell. And so we were kind of brought here with a film crew and my producer, and we just wanted to help tell the stories of some of these booths here.
Yeah, we learned a lot of that as well, because our camera team was on the shop floor as well, and they brought some interesting stories with them. So I think that's the same what you saw. That it's incredible the mass of interesting people and the mass of interesting products, right?
That's exactly it. And what's great is there was other camera crews and other people covering it. And even though every booth has their own story, us as the hosts of these shows being able to tell the story in our own way just just brings about the Formnext experience to people in unique ways.
So we have to wait on that one, because that is a sign that we are here.
Don't they know we have a show going on?
We just displayed this to prove we are really on an exhibition.
That's right.
It's not a green screen here. We are not faking something. That's real. That's exhibition. Joel, you are really best connected in the community. Bring to us the impression, what hurdles must be overcome from the point of view in additive manufacturing of the users, that we get a wider usage of additive manufacturing in industry, that we get a leap forward in the market, that we get a growth in the market. What are the needs from what do you hear from your users?
I think that, well, from my point of view, the need is to really just get the message of Formnext and everybody that's here, their stories to tell to a wider audience, and to have people who can tell the stories in ways that certain communities really hold on to. I think there's nothing impeding AM from going forward and just taking over in manufacturing and just taking over the world, let's be honest, but people need to know about it. And that's why it's so important that each booth is able to have their story told, and that people around the globe get to know about this technology and how it can benefit them, and then that's where it all starts.
And what's the feedback from your users? Do they say something like, okay, we need this or that to adopt additive manufacturing to our processes or to our industry sector?
For me, though, well, so as the host of a show, then what I get to hear from people is how incredible this technology is. And so while I can't speak for the companies and the users, I hear from the people a lot of times that are a fan of this technology and are interested in this technology. And so it's been a number of years that I've been here doing this, and I've heard from people who are working at these companies saying, I came here because of you. I learned about this from you, and I was interested, and I got a job at this company because of you. And so while the users, I understand what you're trying to ask. I have a slightly different point of view, and I think that it's just being approached in a different way.
Exactly. I'm trying to get the perspective of the end users, and I'm trying to get an answer why there is not more growth in a certain amount of time. But maybe we have an answer with Sarah. Sarah, you have a really special project, and you are as a consultant in the community, so you have a lot of contacts as well. Maybe you have the answer where we can enhance the markets and the usage of additive manufactured products.
Yeah, definitely. Everything Joel was saying about getting the stories across, that's the most important thing, right? That's why we're all here together, to get these stories across, to come together as a community in a real expo hall with real announcements and just be together live again. But it's because we can see that this industry is growing, this technology is growing. And what I do when I work with my clients is really help them hone their messaging in an honest way. And we've seen the hype in 3D printing, and I think we're over it. So we have people really nerding out about the technology in delightful ways and digging into what makes it real, what makes it possible. And so I love working with all of the companies across the industry, OEMs, software, materials, service providers, you name it, and getting out not just the reality of their messaging, but how it's relevant to their customer, to the user, and where it fits alongside traditional manufacturing. We always get asked when this will displace traditional, and we need to see how it comes together, just as this community is coming together, but how these different manufacturing suites really come together. And I think that type of collaboration and understanding of the bigger picture is what we're really seeing. And here, we've certainly seen another stage in maturation for this industry, and it's been pretty beautiful to see. I'm also on the board of directors of Women in 3D Printing. We had a happy hour last night. It's always the biggest of the year.
And we had a round here on Tuesday, yes. I think. Yeah.
Yeah, and it was wonderful to see Kristen on stage and with all of the other, some of the women who are incredible leaders in this industry.
Yeah.
And so seeing that community continue to grow, thrive, and come together is really what we're seeing is this industry truly has a place for everyone.
We had another expert from our community who's very active in the community. Alexander, I have to look his surname, Sisek. He's from 3 Your Mind, and he talked about the fundraising project with Ukraine. And you have some colors here to display. Please tell us about the project. Give us a rough overview, shortly, and then where we are standing in that project.
Yes, absolutely. Alex did a beautiful job explaining it a little bit as Formnext opened, what we've brought together with the help from Alex and the 3 Your Mind team and led by the efforts of Björn, Marie, and the team at EOS. EOS designed and 3D printed these buttons, these pins, in the Ukrainian flag colors of yellow and blue, and each pin is available for a €10 donation. Or more, if anyone feels so moved, as all of these funds go directly to Ukraine to 3D print medical devices like tourniquets that have saved the lives of dozens of soldiers already, and helping them to get the help they need on the ground medically and print the parts they need, as well as offer training opportunities for those who have been displaced and need new things. 100% of the funds we raise through this are going directly to these efforts, and it's incredible to see the support that the industry's had. We've got these gorgeous glasses that were just donated as well. I did donate €125, so this is my pair I get to take home. There are 5 of each of 3 different designs available on the 3 Your Mind stand, so anyone can donate and take them home, today or whenever they go. But we've seen some gorgeous things that have been offered up for this silent auction, which is still open until noon tomorrow. And we have several of the pieces on display here. Printers, software licenses, and some gorgeous...
But don't take away from me my new guitar. I want to play a little bit. No, I'm not a guitar player. I cannot play with this guitar, but I would like to have it nevertheless. It really looks great, doesn't it?
This is guitar number 99 from designer Olaf Diegel. And he's generously donated it. It's binder jetted wood.
It's an awesome work, isn't it?
So it's just gorgeous. Joel's producer David played it earlier. It can sound beautiful.
You can play?
No, my producer played it. No, I can't.
But we have, I was outbid on it already, so I'm not taking that one home.
Aww.
But bidding's still open. It's just
and all this as a donation project?
All of it is a donation so far.
Really,
a day
it's a
still
project
before
of
the
heart,
auction
I think,
closes.
for many people.
We've raised over €3,500 so far just at Formnext. The auction is still open until noon on Friday. So we are hoping to continue raising more funds. We started this effort with all of the industry support at Rapid Plus TCT this spring when we raised nearly $55,000.
Wow.
So we're really glad that the industry has come together because really together we are strong.
Wow. That's really cool, and that's a really good news. So it's open till tomorrow. So dear spectators out there, maybe you check, where can one check on the website? Say it again.
It's Together We Are Strong. There's a landing page available from the 3 Your Mind website. There are QR codes available to scan throughout this exhibit hall. And of course, if you ask any of the organizers, we're happy to point you to the Air Auctioneer website where the auction itself is hosted. You can find any of us in person for the pins that have a PayPal code to donate as well, whether for a pin or just because you don't want, things, you just want people to have better lives.
Perfect. Thank you very much for this interesting insights and this important sign of solidarity with Ukraine. And I wish you every luck with this project and with the other ongoing project and with getting the community in more usage of additively used produced products.
I just want to share the good stories here at Formnext.
Perfect. We will see us. Yeah, thank you very much, dear audience, for watching at the screen and here at the booth. I think we see us tomorrow again at 9 o'clock on time. Tomorrow it's the last day of Formnext, so we have to stay together here, and we will find the next, the next mile, the last mile, and we will be together here at stage. Till then, stay tuned.
Joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.